Ladies and gentlemen, good morning, ladies and gentlemen. If you would please move to the center of your section so we can accommodate as many people as possible. And if you have your bag on a chair, please put it on the floor in front of you so that more people can come in and see the presentation. Thank you very much for your cooperation.
Ladies and gentlemen, the show will start in 5 minutes.
Ladies and gentlemen, once again, if you would help us out and move to the center of your section so that we can accommodate as many people as possible, we appreciate it. Thank you.
Ladies and gentlemen, the show will start in 2 minutes. Ladies and gentlemen, please silence your cell phones. The show is about to begin. Ladies and gentlemen, please take your seats. The program is about to begin.
Uber's mission is to ignite opportunity by setting the world in motion. We're making a transition from being a company that's all about ride sharing to a company that's a platform for all different types of transportation. One of those is air.
We're living in cities where people live in 3 dimensions in skyscrapers, they work in 3 dimensions in skyscrapers, and you have a transportation grid that's in 2 dimensions. That transportation grid will not be able to keep up with 3-dimensional life, and that's what Elevate is about.
Electric vertical takeoff and landing aircraft are really the key to doing what we've wanted to do for many years, and that is be able to overcome the gridlock that's on the ground in the cities.
Skyscrapers change cities by taking advantage of the space above cities. Urban aviation will do the same, and in the process, it will reduce congestion on the ground and make our cities feel more open and more accessible for everyone.
Aerial ride sharing is about combining eVTOL technology, which provides affordable, clean, efficient, and quiet vertical takeoff and landing flight, combining that with the ride sharing platform that Uber has built to get high utilization and load factor into those aircraft.
You would still have those existing ground transportation options, but we would supplement some of the most congested routes in the city with a flight portion. Let's say a car or a bike or some other form of transport takes you to what we call our skyports. You would then fly 5 or 10 minutes over the most congested part of your journey, and when you landed, there would be another form of transportation to take you to your final destination.
In-house, we're building software capabilities that will enable safe operations of vehicles in our network. And then we're looking outside for world-class partnerships with aviation companies who are building the aircraft.
We're developing requirements for our vehicle partners so that they can know how best to design these aircraft to meet the services and needs that our customers have.
Aircraft will be taking off and landing in very densely populated, concentrated cities, in places where real estate's pretty scarce. To be able to do this, we're partnering with some of the world's best real estate owners, developers, and operators to be able to unlock new capacity for taking off and landing aircraft across our cities.
There's a lot that has to happen collaboratively with both the Federal Aviation Administration and our international regulators worldwide. Additionally, community acceptance is absolutely key to getting this product up and running, which means working with the community and working with local stakeholders from day one.
Cities are concerned about congestion and air pollution. Uber is addressing that in a lot of different ways. One of the ways that Uber is doing this is looking at electrification of cities. And if we're going to create a fleet of aircraft, we have to go all electric.
At Uber, we're not only providing a marketplace for millions of riders, we're also working with local and federal governments to build out a network operations center and air traffic management systems to make these flights practical and safe.
So this is a whole new transportation system that's being designed from scratch. In 15 to 30 years, cities are going to have so many new degrees of freedom for them to grow while remaining incredibly productive.
Ultimately, transportation has to be shared, it has to be electric, and it has to be in 3 dimensions. And I think we can play a part in that. And I think there are going to be plenty of cities around the world that said, yep, I want that.
Please welcome Nikhil Goyal, Head of Product, Uber Elevate, and Master of Ceremonies.
and welcome everybody to our third annual Uber Elevate Summit. I'm honored to be this year's MC, and I'm honored to have all of you here with the Elevate team today. Raise your hand if you were at our first Uber Summit in 2017 in Dallas. Okay, what about last year, 2018 in Los Angeles? Wow. It's great to see so many faces, both familiar and new, here today. 2 years ago, the Elevate team was hardly a handful of people, and most people in the world had only dreamt of flying cars. Virtually nobody knew what eVTOLs even meant. Now, today, both our team and the industry has grown in ways none of us could have ever imagined. And the ever-elusive flying car future we have all envisioned is one step closer. And as everyone here knows, it's closer than most people think. This year, we're proud to host nearly 1,500 people here in DC from 31 countries around the world and hundreds of cities globally. To all of the engineers, policymakers, government officials, Uber Elevate partners, investors, and real estate developers here, thank you for taking 2 days to join us. This year's Elevate Summit is about making this future real and showcasing all of the progress the industry has made over the last year. We'll kick off the day with an opening keynote from the head of Uber Elevate, Eric Allison, our Director of Operations, Stan Swiatek, and myself. We'll then move into urban air mobility in the United States, where our Head of Aviation Policy, Kate Frazier, will talk about all of the regulatory advancement that's going towards this industry, and she'll be joined on stage with a panel of some of the leaders there. We'll also be joined by a special keynote from the Secretary of Transportation, Elaine Chao. We'll end the morning with a panel on next-generation airspace technologies that are helping make all of this possible, a field led by Dr. Tom Prevost here at Uber, Director of Engineering for Airspace Systems. We'll have lunch, of course, with Uber Eats, and then we'll kick off with Standing for Safety, a top priority at Uber, particularly for aviation, with our Chief Legal Officer, Tony West, who will share the stage with many aviation experts across the industry, including our very own John Ilson, our Head of Aviation Safety. Then, Urban Aviation Worldwide will hear from countries around the world who are equally as excited about urban air mobility, and we'll hear them talk about what they're doing in their very own regions to accelerate UAM in their countries. And then finally, Mark Moore, our Director of Engineering for Vehicle Systems, will kick off a series of presentations from all of our Uber Elevate partners. We'll end the day with our opening night celebration around 7 o'clock at the Smithsonian National Air and Space Museum. I'll tell you more about that at the end of the day. Day 2, we're doing something a little different. This year's Elevate Summit is going to be different because for the very first time, we're going to go beyond Uber Air to show you just how many products fuel one singular Uber platform for everywhere you go and everything you need. This year's Elevate Summit will show you not just the future of transportation in the sky, but how we see the future of transportation on the ground that connects to it, and all of the big, bold bets that Uber is taking to make that real. In the morning, we'll hear from Uber Eats, our Head of Business Development there, Liz Meyer-Dirk, and our very own Head of Flight Operations, Luke Fisher, talking about how drone delivery will propel Uber Eats to the future. We'll hear from New Mobility, our bikes and scooters business, and the head of that, Rachel Holt. And we'll also hear from our self-driving unit leadership, Eric Mayhofer and Raquel Urdestan. We'll then move into Skyports and hear about what the community is doing to make infrastructure real for urban air mobility, and the unveil of new Skyport designs for 2023, as well as 2 new partners in the real estate and infrastructure areas. We'll move into energy storage, led by our Director of Engineering for Energy Storage, Selena Michael-Wychek. And then after lunch, we'll break into 3 tracks. Track 1 will be here, focused on eVTOL aircraft, led by Mark Moore, his vehicle engineering team, and our partners. Track 2 is about moving cities. That'll be in the ballroom opposite. Moving cities is really about all that our Elevate Cloud Services engineering team, our data science team, and our ATC Center in Paris are doing to make this vision a reality. with our head of data science, John Peterson, and our director of engineering for the ATCP, Francois Sillon. And then finally, track 3 will be about energy storage for eVTOL, led by Selena and her energy storage team and partners across the industry. Finally, we'll end the day with a series of keynotes and fireside chats. We'll hear from Sharon Pinkerton from Airlines for America, as well as Senator Ted Cruz, both in a fireside chat with Danielle Burr, our head of federal affairs, and then Michael Ronan from SoftBank in a fireside chat with Jennifer Jarrett, our vice president of corporate development. Finally, ending the ceremonies with Dara Khosrowshahi, our CEO of Uber. And we'll have a happy hour here to cap the 2 days. It's a lot. So I want to say a quick thank you to all of our sponsors who have been a huge help in making all of this possible. You'll see and hear from them either on stage or out on the floor. And one last thanks to Ariana Churchill, our chief of staff for Uber Elevate, and the executive producer who really made all of the things around the summit come together. A few logistical notes from her. You'll find ambassadors in orange polos all throughout the venue. The venue's quite large, and some parts are open to the public, so if you need anything at all, just find an ambassador in an orange shirt. Badges are a must, so the security guards will be checking for your badge. Make sure you have it at all times. And then meals will be out back at the piazza. Finally, social media. Our social media hashtag is simply Uber Elevate, so please tweet, post, share with your friends. A good friend of mine said not too long ago that 5 years from now, many of us will be in Uber Air aircraft, looking back at conferences like today, gatherings like this, and saying, you know what, those were the good old days. So enjoy the good old days. Savor them, enjoy them. And with that, would like to bring up our head of Elevate, Eric Allison. But before I do, let's take a look back over the last year.
After decades of promises, it looks like flying cars are finally becoming real.
Roads, where we're going, we don't need roads.
Everybody, welcome to the Uber Elevate Summit.
Well, the taxi of the future could soon be taking to the skies above Melbourne or Sydney.
Now, companies around the world are developing flying cars.
Today, we are thrilled to announce we are committing €20 million to building out our Advanced Technology Center in Paris.
I'm Yuriko Koike, Governor of Tokyo. It thrills me to think the sight of flying cars crossing the sky will soon be reality.
And I think there are going to be plenty of cities around the world that said, yep, I want that.
It will be able to carry up to 4 passengers along with a pilot up to 150 miles in a single charge at a speed of 150 miles per hour. That's not bad.
If you use Uber Eats, you could soon be getting your deliveries by drone.
Google-backed Wing is the first company to receive FAA approval for drone delivery of goods to businesses and homes.
Now we need to talk with the communities and figure out how to integrate this in a way that's beneficial for everyone.
This vision will become reality much faster than anyone thought possible.
Dallas will continue to serve as a test bed for this type of transportation innovation.
What we see the FAA doing a good job at is starting to define this pathway for certification of the vehicles.
This is a golden opportunity for the country that we can actually do this together in a very concerted and systematic manner.
And we absolutely believe in the vision that everyone is painting here. So thank you for being a part of this event.
Please welcome Eric Allison, head of Uber Elevate.
Good morning. The Elevate Summit is about urban air mobility. But at the core of it, we're really all here to talk about cities. How do we make cities smarter, better, more efficient places to live and to work. More than 1/2 of the world's 7 billion people today live in cities. And with population growth, the UN estimates that by 2050, that will be 6 billion people, more than 2/3 of the world's population. And this is something that we at Uber have been thinking about for nearly a decade. We started pretty modestly. We started with a premium product, the idea of pushing a button and getting a ride and having a black car show up to pick you up. And people really liked it. But as we introduced new products that allowed it to become more accessible to push a button and get a ride, people like it even more. And the innovation really took off. We started to see that we could put more people into fewer cars and use the cars more and more and drive utilization. And people kept on using it. And we've done this. This is just one city. We've done this in cities all over the globe, where today we have 93 million people per month using our platform. We're in over 700 cities around the world, 63 countries, and we've done over 15 billion trips to date. The scale is immense. But what's amazing is that this represents less than 1% of actually transportation worldwide. Most people are still driving their cars by themselves. And so what we see is that cities are clogged. We see traffic and congestion getting worse, and with the population growth that's happening in cities, transportation networks simply can't keep up. For example, in Mexico City, commuters spend on average 5 weeks per year stuck in traffic. We think that we can do so much more. So Uber is making a transition from being all about ride sharing to being a platform for all different types of transportation. We're offering transit in our app. We're offering jump bikes and scooters that you can try right outside of here. And we're investing in self-driving cars because we think that this is the way toward the future. But even with all those innovations, even with all those things I just talked about, we don't think that it's enough. There's an upper bound to what we can do on the ground. The transportation grid right now is in 2 dimensions, and cities live in 3 dimensions. And when we live in 3 dimensions, we have to take our transportation into 3 dimensions as well, and that's what Elevate's all about. It's our bet that we can move transportation off the grid and into the sky in a meaningful way. So what would this look like? How could you take transportation into the sky? Well, you'd have to be able to take off and land vertically from different spots within an urban center. But the reality is that you can't take off and land just anywhere in a city. There's going to have to be locations, skyports, where you can actually land these vehicles and take them off. And this means that every trip that we can put into the sky, that we can move into the 3rd dimension, is going to be by its very core a multimodal trip. You're going to have to get to the skyport somehow, and you're going to get from the skyport to where you're going. And if we want to do this in an economically efficient way, we have to get more than one person into each vehicle, which means we have to get multiple people to the skyports at the same time, and then get them all to where they want to go when they get to the final skyport. This is not an easy problem. In fact, this is an incredibly hard problem that no one's doing right now in a seamless, integrated way. So how do you do this? How do we attack this problem? Well, what helps is if you start with a ground network that has 93 million platform users on a monthly basis worldwide. That's what we bring. We can take our mass, our scale on the ground, and we can use it to drive demand into these vehicles and make this multimodal problem much simpler. And we can do it not just in one city, but we can do it in every city we operate in across the globe. And what this represents is our vision of taking the scale of Uber on the ground and moving it into the sky. So how do we get started on this? How do we do this? Well, we start with our data. We start with a deep understanding of how people move around cities,
how they want to move around cities, where they go on a day-by-day, hour-by-hour, minute-by-minute basis. We start with data. And what we do is we take that data and we have turned it into a simulation of how cities and networks like this work, with the ground leg seamlessly integrated into the air leg. We can then add into the simulation ways to control the traffic. We can add in dynamic sky lanes. We can add in existing air traffic, and we can understand how this system works in the real world because we can feed it with our real-world data. And from that, we can develop the software, the systems, the processes, and the excellent operational concepts that we need to be able to make that multimodal mission, that multimodal trip real. Every day, on demand, over and over and over again, which is what it takes to make this into a real form of transportation. But that's not enough. Multimodal aerial ride sharing and the Elevate cloud services that will connect it all together and operate it are the core of what we're building here at Uber. But this is a system that we have to build. And the same simulation that lets us understand how to do this right allows us to define the other pieces of the system that have to work together and make this possible. It lets us define electric aircraft that will work within this system context in a way that is economically rational. It will let us design and define how skyports have to work, what their capacity looks like, what their throughput looks like, where they should go. But we're not building this alone. We're partnering with world-class companies on vehicles and skyports to make this whole system a reality. Of course, the aircraft is incredibly important. So this set of requirements that we can derive from the simulation that we're building lets us look at standard type of parameters like speed and payload and range, how fast you have to charge the vehicles. We can define the economic mission that then lets the experts that can do airplane design the aircraft, because you can't design the aircraft without a mission. But that's not enough. We can look at the other aspects of what we believe is needed, what we know is needed from our simulations and from our community relations to make this possible. These vehicles can't just have an economic mission. They can't just be technical, excellent objects. They have to be green. They have to be responsible in the communities in which we are working, which we believe means they must be battery-powered, all electric. They have to be quiet. The same technology that allows us to make them battery-powered allows us to have whole new degrees of freedom in how we put these vehicles together so that we can be incredibly good neighbors to the communities that we operate in, and that people will want these vehicles in their communities. They'll be demanding these vehicles be in their communities, not opposing them. And they have to be safe. Safety is the bedrock of everything that we do. We are investing in safety across the board. The vehicles themselves have safety baked into their design architecture from the very beginning. And we're building, you'll hear more about this later today, we're building an Elevate safety management system that will be world-class, that we are starting to build right now, and will be at the core of everything that we do going forward. This is the right way to do it, and that's what we're going to do. So who are we working with? Well, we started with a set of visionary companies, Embraer, Bell, Aurora Flight Sciences, and Pipistrel. They share our goals, and they've been willing to challenge the status quo of the small aircraft industry. And for the past 2 years, the leaders of these companies, who are all here today, have been working to transform not just this industry, but transform themselves. And the results so far are nothing short of impressive. At the summit last year, we added KARAM Aircraft to our network. And in the time since then, we've seen an incredible momentum in product development and speeding of cycles across the industry. And this afternoon, you're going to have a chance to hear from leaders from all of these companies as they talk about their progress and they talk about their goals and their goals and plans for the years ahead. And I'm super excited about that. And we're adding a new member of the family today. I'm super excited to announce that Jaunt Aerial Mobility will be joining the ecosystem. And this afternoon, you'll get a chance to learn more about them as I do a fireside chat with their leadership. So the same data
the same simulation that we use to define and look at and derive the requirements for the vehicles that we're working with our partners on, we can use this to look at skyports. We can look at the way people move through a city like Dallas and Fort Worth, through the metro region, all across it. We can understand deeply how they want to move and where they want to go. And from that, what we can do is we can look at where there's demand for movement. Where is there demand for transportation? And from that demand, we can identify the best locations to put the skyports. So we're working with skyport industry partners across private equity, across developers, to identify key locations. We can go down to the city block and we can actually say this building is the right one to put the first skyport on. And that's something that no one else can do because we have the simulation and we have the data to make this real. We had this vision when we started. We had this vision that the first type of infrastructure that would be appropriate for skyports would be retrofits onto a type of infrastructure like parking garages. But it was just a cartoon when we started, and we've been working with architects, world-class architects across the world, who are imagining and designing what these skyports will look like in 2023, right when we start. This is a little sneak preview of it, and I'm really excited that over these next 2 days, you're going to see a lot more about these amazing visions of the future that they've been developing. But we know that it's not just enough to have the 2023 starting point vision, which is why we've worked with architects to develop the vision for the future on large-scale megaports, skyports that could handle upwards of 1,000 takeoff and landings per hour at peak periods. Because this is the future that we want. This is the future that we're pushing toward. And today, you'll be able to experience what it's like to land in one of these megaports right out into the atrium this afternoon. So please check that out. So when you put these pieces together, if we can build the operational excellence, we can build the Elevate Cloud Services control system, we can build the vehicles that work in this network context, and we can build the architecture, we can build the infrastructure that allows vehicles in a network like this to work. What can we do with this? Well, today, helicopters are only affordable for the fairly wealthy. But at launch, the technology of electric VTOL itself, just the vehicle technology, can reduce that cost by about 1/3. So we can operate Uber Air at launch using the same assumptions and parameters as helicopters for something that's pretty close to an Uber Black price on a per-mile basis. But when we really start to exercise the control systems, the operational excellence that I just talked about, we believe the same vehicles can be pushed to higher utilization and higher load factor, fueled by our enormous scale on the ground. And within a couple years, we can get the price per seat mile much closer, probably exceeding that of UberX. But that's not enough. We don't think that's enough. Our vision is that as we continue to push down on the technology, we continue to introduce autonomy, and we get to scale manufacturing using automotive techniques to build aircraft, that in the long term, Uber Air, on a per-seat basis, will be competitive with car ownership. Our vision is that on a daily basis, it will be more economically rational for you to fly than it will be for you to drive. But let's take a step back. All of this innovation is happening in the context of a highly regulated industry. We know that. And that's why we're in DC this week. That's why all of you are in DC this week. And we've brought together all of you who are shaping the future of aerial ride sharing. We brought you together for a collaborative conversation on how we safely and responsibly usher in these two new technologies for our riders in the very near future. Today, we'll hear from the Secretary of Transportation, Elaine Chao, FAA Acting Administrator, Dan Alwell, and tomorrow we'll hear from U.S. Senator Ted Cruz. And we'll hear about their visions for how the U.S. will continue to lead in the development of this global aerial ride-sharing network. But make no mistake, it will take supportive regulators at every level of our government,
federal, state, and local, working together to bring our collective vision of this future of aerial ride sharing to reality. One such set of local governments that are very committed to shaping these new technologies exists in North Texas. And there we see a unique opportunity in the broader Dallas, Fort Worth, Frisco market to lay a foundation for aerial ride sharing, to lay a foundation for innovation and spur the global industry. And we see this thanks to a leaned-in set of local public officials, public and private sector partners, including our partners, including Hillwood, including Bell, who are investing heavily in the enabling technologies to make this whole industry take flight. And so today we're announcing our support for Hillwood, our real estate development partner, who has released its vision for an Alliance Texas mobility innovation zone right outside of Fort Worth. And we'll be working together with them and with other stakeholders in the region to look at how this innovation zone can be used to accelerate the introduction of demonstration flights as early as next year so that industry partners can be connected with our local community partners, and communities can start to see the benefits, the amazing benefits that this technology will bring to their cities, so that the communities will want us there and will be asking us to come to their city next. So when you put this all together, this is where we're heading. Uber is growing into a platform for every way and everything that we move, and Elevate is our biggest, boldest bet. It's our vision for a dense network of thousands of flying cars speeding people across and through cities every day, extending Uber's unprecedented scale into the sky.
Please welcome Stan Swaintek, Director of Operations, Uber Elevate.
That's why we're all here. That's the vision of the future that we are all committed to work together to create. But to get there, it's going to take a lot more than just a new type of flying machine. To create this vision of the future requires the ability to control and synchronize the activities of riders and drivers and aircraft and support systems, all within a highly complex multimodal aerial ride-sharing journey. And that is a capability that we can build today. Now is the time on our strategic roadmap towards that vision of the future, Uber Air flying eVTOLs in 2023, to close this gap. And that's why we're so excited to present Ubercopter. UberCopter is the first consumer manifestation of Uber Air, the world's first truly fully integrated multimodal aerial ride-sharing product. And we're doing this now to begin to understand our customers' preferences and behaviors along this new type of multimodal journey, and to develop the operating capabilities and the digital products required to deliver safe, reliable, and time-saving services to our riders. UberCopter also provides us with a unique opportunity to demonstrate the power of the Uber platform, the power to drive consistent demand necessary to unlock high aircraft utilization rates and high average load factors that will be required to scale this type of transportation product in the future when eVTOL are ready. And again, this is something we can start building today. While the technology behind the scenes is new, the aircraft, the infrastructure, the flight standards, they're not new. We can accomplish all of our learnings here, enabling the future of Uber Air while operating out of existing aviation infrastructure, heliports, and flying helicopters along published helicopter routes today. And that, in combination with the power of the Uber platform that provides us with driver partners to enable the multimodality of the service and the rider demand, makes this a very real opportunity. And it's an opportunity that Uber is in an advantaged position to operationalize because of our mastery of data. This data provides us with insight into where our riders begin and end their trips, when they travel, how long it takes them on those trips, and how much they're willing to pay. We can use this information to inform operational decisions for UberCopter, like when to make the service available to maximize time savings for our riders and deliver high average load factors, what routes to prioritize to ensure balanced trip flows and high aircraft utilization, and which riders are best served with an aerial ride-sharing alternative. We're able to predictively determine the time savings created by UberCopter against other types of trip itineraries on the ground, and then dynamically manage first-mile geofences to ensure that the riders who can access UberCopter enjoy meaningful time savings on every trip. And this is where we're going to start. Simple. A single bidirectional route between the downtown Manhattan heliport and the JFK airport. On a busy day, there are 10,000 riders who depend on Uber to provide them with transportation between JFK and Manhattan. Unfortunately, on the busiest hours of those days, that trip can take you over 2 hours. UberCopter, which will include an 8-minute flight leg, can save some of those same riders more than an hour. We can give our riders an hour of their time back. But as Eric mentioned earlier, this can only be delivered with a tightly coordinated multimodal product. And multimodality is complex, even just for a single rider. Effectively managing the timing uncertainty along the trip on the ground to seamlessly coordinate transitions between modes is something that requires a deep understanding of how cities move and a constant awareness of all of the actors in the system, the riders, the drivers, the aircraft, and then the ability to coordinate all of those actors in real time. That's complex, and that's just for a single journey. Now, doing this simultaneously for 4 or 5 riders for every UberCopter trip multiple times an hour, consistently and reliably coordinating the first mile, the flight, the last mile, and all of the transitions in between, without forward staging a fleet of vehicles on either end, or making our riders wait for extended periods of time in a heliport lounge. That's something that can only be created with technology, with the power of the Uber platform. But we can't do this alone. Similar to the partnership strategy that underlies Uber Elevate, we will rely on a small group of best-in-class operators to bring this vision to life. Most importantly, HelloFlight. HelloFlight is our Part 135 on-demand air carrier that will provide all of the flight services for UberCopter. And this was a decision that we made after a very long diligence process, and we're very proud to say that our flight partner has achieved the industry's highest safety ratings from both Argus Pros and Wyvern Wingman. Safety is the guiding principle for HellaFlight. They operate only twin-engine aircraft with 2 pilots. They voluntarily implemented a safety management system, and they are working with the UberCopter operations and safety teams every day. Later today, you're going to hear Tony West, Uber's chief legal officer, talk about Uber's commitment to safety. And he's going to lead a panel of aviation experts to discuss best practices in aviation safety. And we have a lot to learn from these experts. And we have learned a lot from these experts, and we're leaning heavily on their experience to help develop, implement, and test our own operating procedures, response plans, training programs, and safety systems. And similar to HellaFlight, we are voluntarily implementing a safety management system to cover our end-to-end operation. Together with these partners, and with safety always in the front of our mind, we are very excited to launch UberCopter in New York City this July, making it available first to our most loyal riders, the Diamond and Platinum Rewards members on the Uber platform. And that's what this is all about. This is about understanding our customers and developing the products and the operating capabilities necessary to build the foundation for the future. UberCopter is fast-forwarding to the future of Uber Air. And now Nikhil is going to join us to tell us a little bit about the technology that we've built to make UberCopter possible.
Please welcome Nikhil Goyal, Head of Product, Uber Elevate.
Thanks, Dan. One second. There we go. So look, Uber is no stranger to helicopters. In fact, we've run our Uber Chopper promotions in over 100 cities around the world. And if there's one thing we've learned, it's that there is a massive amount of demand to fly in and around cities to save time. We've also learned that the only way to deliver that well is to integrate the flight with a full end-to-end multimodal itinerary using Uber's technology. We're talking about an end-to-end trip from downtown Manhattan to JFK in as little as 30 minutes across 3 modes, ground to air to ground. And we leverage our Uber Pool technology to match riders with similar itineraries traveling around the same time, as you heard Stan talk about. Once we batch our riders, they enter the aircraft, and they take their 8-minute flight to JFK. It's imperative that this flight is shared, so that in turn we can make it affordable. Once you land, a fleet of normal cars from the Uber JFK FIFO queue is dispatched to take you to your last leg. All in as little as 30 minutes, end to end, using the same Uber product we know and love, with a single press of a button for a single price. All of this is basically completely unprecedented, and that's because it's really hard. And that's why we're doing this, so that we can learn how to build a truly customer-obsessed Uber Air product. And we're doing this by building an UberCopter technology ecosystem. Our engineering, design, data science, and product teams have worked hand in hand with the operations teams on the ground and our partners to build a suite of applications to make this possible. Our Rider app integration, the Pilot app, Heliport Terminal app, an Operations app, and all of this is powered by our Elevate Cloud Services backend, in addition to a fleet of connected aircraft. Let's take a look at let's take a look at this experience. So let's say you pull open your Rider app. It's Friday morning. You've got a flight that afternoon to JFK. And of course, it's 2 hours by ground. But today you see a third option, Uber Copter. Door-to-door service and a twin-engine, twin-piloted aircraft with room not just for your luggage, but 4 of your best friends. You can take this the normal way you take Uber, on demand, and leave within minutes. Or, and this is the very first time we've built this for any product across Uber, you can pre-arrange your trip to make sure you arrive by 5 p.m. for your 6 p.m. flight, and leave the rest to us. We'll get you there on time. You scroll through your end-to-end itinerary, confirm your route, read through the terms and conditions, and once you agree, the rest is up to us. When you're on trip, you can learn all of the things you need to know before you fly, and you can even watch the safety video before you get there. Now you're at the downtown Manhattan heliport, one of the largest in the world that does over 10,000 rotorcraft operations every single year. And more importantly, this is the very first Uber Elevate Skyport experience. We've focused on making this terminal experience intuitive, comfortable, and fast for our riders. And this is where the beauty of Uberpool really kicks in, because we can use our demand liquidity to make sure that when riders get dropped off at the heliport, they're barely there for just a few minutes. And when you're there, you can check out the in-app terminal screen to get contextual information about your flight. And you can also watch the safety video, which is informative, so you know what's about to happen. Once you're there, we'll get you checked in. In this case, Adam Wormuth, one of our PMs. Your name, date of birth, and weight will be input. We'll run you through TSA Secure Flight, and you're ready to go. Your boarding pass is pushed to your phone, scanned by the heliport staff, and you can enter the flight line. This experience is instrumental in helping us design and build the Uber Air experience of the future and the Skyports that will power that service. And then finally, we have our app for the Operations Center. This is critical. The Operations Center app allows us to proactively manage flight operations and monitor real-time passengers and aircraft before, during, and after the operations window. We ensure that our passengers are tracking on time for their first leg, and if we're not, we adjust passengers and flights to make it so. And then, of course, there's weather. The Operations app has weather built in by the minute, and our operations team uses those weather forecasts to work with our Part 135 partners in order to make weather calls enough time so that if we can't get you there by copter, we get you there by ground instead. And that's the power of the Uber platform. All of this technology extends to the cockpit as well. This is where our Uber Copter technology, powered by our Elevate Cloud Services technology, helps us build a connected aircraft. We've built a pilot app from scratch, built off the backs of our learnings from the Uber Driver Partner app that's been powering Uber for nearly a decade. Our product, engineering, design, and human factors teams have worked with dozens of rotorcraft pilots to build an experience that's intuitive and allows for contextual information before, during, and after flight. We've also optimized these interactions to be when the pilots are safely on the ground, so that they can have real-time access to weight and balance, passenger manifests, squawk codes, and itineraries. In order to do this well, we also need uninterrupted connectivity while we're in the air, which is a challenge. In order to enable seamless, connected aircraft experience, I'm excited to announce that we've partnered with AT&T. Uber and AT&T will partner together to build an urban air mobility communications network for Uber. Not just for Uber Copter, but also all of our future Uber Aviation products. And over time, we will together build new capabilities for constant airborne connectivity, including 5G, to serve these use cases at greater scale, complexity, and fidelity. We're excited to be rolling out Uber Copter this summer. As Stan mentioned, we're using our data expertise to build dynamic geofences for eligibility so we can save you time. We're also dynamically pricing our service just like all of our other Uber products. One price, door-to-door, all in, depending on your origin and destination, as well as the time of day. The average price will be between $200 and $225. And we're also excited to launch this first to members of our Uber Rewards loyalty program. The first to unlock will be Platinum and Diamond, our very top tiers in New York City. This is also the first new benefit we're offering Uber Rewards members since we've launched. And so with that, a huge thank you to the entire Elevate team and Uber team who've worked nights and weekends to get this launched this summer. And I'm excited to bring on stage our head of aviation policy, Kate Frazier.
Please welcome Kate Frazier, Head of Aviation Policy, Uber Elevate.
Good morning. It is my absolute pleasure to be here with you all today. Eric already mentioned that our goal here today is discuss about really why we're here in DC. And that's because we ultimately believe in the importance of engaging with regulators and policymakers at all levels. In addition to being crucial, our work at Elevate requires a more complicated engagement model than ever before seen at Uber. We are now working with products that are primarily regulated at the national level and even beyond through organizations like the International Civil Aviation Organization. So how does this all work together? Let's take a quick look. We're going to use those 4 pillars that Eric just discussed. So we've got electric aircraft, aerial ride sharing, airspace management, and connected skyports. So we have an opportunity then to really hone in on the policy complexities surrounding urban aviation by focusing briefly on connected skyports. Where state and local policymakers have the greatest impact is around the skyport location and zoning. Additionally, issues around noise and flight path placement can all be affected by the will of the community. However, we now must add a substantial layer of complexity, the federal regulations. These regulations dictate all design considerations for the aircraft and certification requirements to ensure the safety of flight. The aerial ride-sharing pillar provides another unique glimpse into the layers of regulations and policy that Uber Elevate faces. Due to the multimodal nature of our product, we have to consider all other facets of ride-sharing policies combined with the issues brought forth by aviation rules and regulations. All of this is to say that each pillar comes with an increasing level of complexity, and understanding this is absolutely key to success. But for a minute, let's focus on the local level. As you know, our 2 launch cities that we're very excited about here in the United States are Dallas-Fort Worth and Los Angeles. But let's talk about Dallas-Fort Worth for a second. We've begun to lay the groundwork to ensure that we are absolutely community-focused. In fact, only a few weeks ago, we convened our first ever Uber Elevate stakeholders group in the North Texas area. We had representatives from various cities in the Metroplex, transit authorities, airport authorities, our partners, and local organizations. And ultimately, this provides a massive opportunity for our most important stakeholders to meet regularly and collaboratively map out a path towards launch, which is ultimately our key to success. Collectively, we can address issues like noise, zoning, city planning, and general community acceptance. But let's zoom back out for a second. Because as we've talked about, historically, Uber has been hyper-focused on local policies and engagement. And that's for a good reason. Regulating ride-sharing services is very much a local issue. While we believe it's critical that we develop these relationships with our launch cities, it's also necessary for Uber to expand beyond our traditional model. And for our aviation products, this broader engagement is not just important, it's required. Our key stakeholder in the United States for any of our Elevate products is the Federal Aviation Administration. We're excited that you'll hear more from several FAA executives later today, to include Acting Administrator Elwell. Everything that touches our aircraft, from the pilots and mechanics, to the controllers and software, to the literal nuts and bolts, must undergo rigorous certification as outlined by the FAA. So let's further simplify this into 2 additional categories: the aircraft and the operations. Now, looking at just the aircraft alone, we see a host of regulatory requirements, and everything from the aircraft itself to the engine to the maintenance, noise standards, and so on. On the operational side, We see basic requirements, airport requirements, flight training, and again. But for those of you in the room who come from the aviation industry, this is absolutely nothing new. But it's a very important reminder. We recognize that there is no path to market without meeting these requirements. As fast as we want to move, there are limitations. And these regulations exist for a purpose. They're there to keep people safe. So let's simplify this just a little bit further. We're going to pull out two categories: Part 23 certification of small airplanes and Part 135 operations. We firmly believe that both of these certification categories provide the best path forward for success. Over the past decade, the FAA and industry have worked collaboratively to revise Part 23 so that it moved away from overly prescriptive standards and instead focus on consensus-based framework. Now, Part 23 allows for the encouragement of innovation and the development of safer aircraft. When the General Aviation Manufacturers Association analyzed the revised Part 23 regulations, they found that around 85% were applicable to eVTOL aircraft. And it's for this reason that we believe Part 23 is the best pathway for certification of these aircraft. For operations, we view on-demand Part 135 as the best fit. And we're working with regulators and our other industry partners to solve core issues around these pilot requirements, particularly as these aircraft evolve. But operational issues like these are not only solved at the FAA level. We also work through collaboration with the Department of Transportation. In fact, Secretary Chow, who you'll hear from shortly, has been instrumental in developing a framework that encourages innovation, particularly in the rapidly growing drone industry. The UAS IPP, which you'll hear all about over the next 2 days, has been an exceptionally successful program that has allowed us to explore drone delivery services with our partner, Uber Eats. In general, the administration has worked diligently to encourage FAA and industry to enhance these new technologies. In addition to DOT and FAA, NASA has really led the way around UTM and airspace integration. FAA and industry are starting to implement UTM and develop the standards for sharing the airspace safely and efficiently. And I'm very excited that we'll hear more from Dr. Jaewon Shin all about what NASA has done here shortly. All right, we're going to zoom out one final time and look at this from a worldwide perspective. Uber is a global company, and we firmly believe that the future of urban aviation and aerial ride-sharing belongs to the world. To realize this vision, we have spent the past year conducting due diligence in major cities of these 5 countries: Australia, Brazil, India, France, and Japan. So let's do a quick walkthrough of the 5 countries that we looked at and look at some of our engagement. In Japan, we had the absolute pleasure of hosting our APAC summit in Tokyo in August of last year, and were joined by Governor Yuriko Koike. In Australia, we had the pleasure of meeting with several key policymakers and regulators. Here we're seen with the Honorable Gordon Rich Phillips in the Victorian Parliament House. In India, Eric and Nikhil had the immense honor of sitting down to discuss urban aviation with Prime Minister Modi. In Brazil, we had several key meetings to include the Governor Doria of Sao Paulo. And in France, we worked to establish the Advanced Technology Center in Paris, which was jointly formed by DARA and President Macron. But an important thing is, what were we actually looking at? There are 5 key factors that fell into this evaluation criteria that were essential to this decision. The first, market factors. Is the economy viable? Can there be full utilization of the Uber Air product in each respective country? Environmental factors. For initial service, Uber Air must be operated in a location that has generally favorable weather. This is primarily due to the fact that these aircraft will initially be operated under visual meteorological conditions. Policy and regulations is a key area. A supportive and innovative regulator is absolutely essential to success. Without rules and regulations that enable new technology, Uber Air will not be able to launch within the next few years. And additionally, having support at the local level and state level is crucial. For infrastructure, utilizing a city with existing infrastructure and existing routes can really help to expedite market entry. And finally, Uber's perspective and strategy. As we've talked about, Uber, this whole product is a multimodal product, and therefore we must have a successful ground business to tie into. So these were the 5 areas that ultimately informed our decision of which we'll be announcing later today. So we've traveled the world, and now it's time to focus back in on the United States. As I said, you'll be hearing all about urban aviation around the world later today, but right now we want to talk about the regulatory environment in the United States. So to really dive into this issue, we thought it would be crucial to bring in executives from our leading stakeholders, the FAA, NASA, and the General Aviation Manufacturers Association.
Please welcome panelists Pete Bunce, Dr. Mike Romanowski, and Dr. Jaewon Shin.
Well, thank you all so much for being here. This is particularly exciting for me because I think we've got 3 perfect representatives of what we're doing in urban aviation in the United States to really kind of paint a picture for you all on where this is headed. We could talk a little bit about the developments that are going on as well as where we see this industry going. So before we dive into the questions, I'd love it if each of my panelists could do a quick introduction of who you are and really what your organization has done around urban air mobility.
My name is Pete Bunce. I run the General Aviation Manufacturers Association. For those of you not familiar, we're a trade association internationally based that represent over 100 companies that do everything from airframe engines, avionics, down to about 3rd-tier suppliers. And we kicked off our effort on urban air mobility in 2015 with 11 companies. Uber was one of the first companies that started that, and our board supported us standing up a committee that we called the Electric Propulsion Innovation Committee. And now, here in 2019, it's 80 companies strong. It's chaired by Michael Thacker from Bell and also Eric Allison here from Uber. And virtually everybody that's a serious player in the space has been participating. So you have traditional manufacturers along with what we would call startup companies that are pioneering the efforts in this arena. And we also have government officials and agencies like NASA, universities like Embry-Riddle, and others that participate in that program.
Great. Mike?
Well, thank you, Kate, and thank you all. Great to be here. In the FAA, I have the responsibility for all of our regulatory policy framework for certifying air vehicles and working across the FAA and with industry on those policy matters and the execution. We're spending a lot of time right now as an agency working with the industry. We are engaged very tangibly with probably between 15 and 20 companies right now, laying out a pathway to certify those urban air mobility vehicles. And that is looking through what is the regulatory construct. You mentioned Part 23 in your remarks. Where does that fit? Where do we need to bring additional requirements to bear to get the performance and safety outcomes that we and the public are looking for urban mobility? In the course of doing that, working with the companies, we also work very closely with the industry and understand the initiatives that industry is taking on. We work closely with government partners like NASA on their activities to truly align our efforts and make sure that we're coordinated, not just across the FAA. We spend a lot of time working across the FAA and those integration aspects, but also with the industry and the federal partners.
Good morning. My name is Jaewon Shin. I'm Associate Administrator for Aeronautics at NASA headquarters here. It's a real pleasure to participate this summit again, but I must say I feel really underdressed here. I work in Washington, D.C., but I tried to imitate the Silicon Valley look, but I failed. The NASA Aeronautics traditionally has been working on all air vehicle, the engine technologies and air traffic management, and also aviation safety research. And I represent that aviation or aeronautics research mission for the agency. But it's really super exciting to see this, the amazing participants here in the third Elevate Summit. So congratulations to Uber for continuing advocating this new capability. So last year at the LA Summit, I announced that NASA will build a series of grand challenges for the UAM community. And over the last year, we have made a lot of progress. And thank you all for participating and supporting the Grand Challenge preparation. So we're excited to see the actual build-up to happen next year, and then actual real first Grand Challenge will take place in 2021.
Great, thank you. Well, Mike, I wasn't going to start with this, but since you mentioned it, I think I have to. When we talk about Part 23 certification, as you know, we've made that very clear that that is our preferred pathway. You talk about some other considering factors. So what does that look like in your eyes?
I think first thing we have to look at is, Part 23 does a couple of things extremely well, and they set a framework that whether we certify strictly under Part 23 or if we take the path that says we're going to create a special category for certification, fundamentally we're looking at the same requirement. We want to be able to use the same requirements either way. What we are looking at is what is the most straightforward path for that vehicle to operation, right? You mentioned Part 135, commercial air operations in your remarks, and it's really working with our flight standards counterparts on what are the aspects of pilot qualification, crew training, maintenance that leverage the vehicle certification, but give us a pathway to operate. Now, at the same time, with Part 23, as I said, it provides a performance-based framework and level of safety that gives us a consistent safety outcome no matter how we apply those requirements. The requirements by necessity, because even out in the lobby you see very different concepts for what these vehicles look like. Some look almost identical, like a conventional airplane. Some look more like a helicopter, but neither of them are strictly fitting into those categories, right? They're aircraft that operate differently and have different flight controls. So it's really working the path that really is most expedient to the operation, and also looking at the international acceptance of the product as well.
And I would say, Kate, just to add, Mike's team has been tremendously helpful to the industry in allowing us, our companies, to come in early, be able to explain our concepts to them. But we as industry, and obviously you and Uber are thinking this end to end, we have to not box ourselves into a situation where if we go with something like 2117B that would require us to perhaps have a pilot that has not only got a private pilot commercial certificate, but also now a rotorcraft, as we was with some of the tilt rotors, we just screwed ourselves as an industry. So we have to, exactly what Mike said, we have to think of this entire end-to-end at a time in a pilot shortage. We shouldn't be boxing ourselves into a set of requirements that gives us a pilot population that small. So we really appreciate that Mike is working very hard with his team and the directorate headed by Earl Lawrence, and I think it shouldn't be lost on anybody that Earl helped start the whole Part 23 rewrite effort even before he was at the FAA along with us, and this was now going on 14 years ago. And Earl knows that we initially, even as of 5 years ago, conceptualized that we could go ahead and certify these aircraft in Part 23, but now we've got the flight standards folks over at the FAA, Rick Domingo and his team, working very hard to help us be able to move what Mike's team is doing, and we can get these aircraft certified, but then very quickly bring them into operations.
Yeah, absolutely. Great. Thank you. Jay, I want to go over to you quickly. First and foremost, I apologize. We dressed up for you today, so. But I want to ask a little bit about what you all are working on. So we talked about aerospace integration, and obviously you guys have dedicated a lot of time and resources on that, and we're really excited about that. But NASA also has some really unique capacities and capabilities, whether it's your Armstrong Test Facility or Ames or your joint facility out at DFW. How can NASA best use its resources to support the development of urban air mobility?
Yes, as we mentioned, Kate, we have been developing a new air traffic management concept and working with the community. I think we have made a tremendous progress in the last 4 years or so in the UTM area. So again, on behalf of NASA, I really appreciate the whole community pulling together and to build this really critical infrastructure, even to enable UAM. But as Kate mentioned, we are not just working on air traffic management capabilities and concepts. We have Armstrong Flight Research Center. We can provide a very secure and robust flight test environment there in Mojave Desert. And also 3 research centers, one in Mountain View and one in Cleveland and another one in the Hampton area. We have a lot of wind tunnels. These are national asset level wind tunnels where our industry partners can come and test or gather data for whatever needs, aerodynamics or acoustics and so on. So I think those facilities have been available for, if I can use traditional industry partners. So we welcome this UAM community to work with us beyond air traffic management side, and that's what's exciting about participating in this building new capabilities.
Yeah, that's very exciting. And kind of while we're talking about new ways that you can incorporate this technology, I know FAA recently reorganized around aircraft certification and flight standards. I know NASA has talked about a reorganization as well. What are you doing as an agency, both of you, to incorporate this new technology, whether it's the aircraft or the aerospace integration side? I mean, there's a lot coming in.
Yeah, we have actually practiced a lot this. So we should be doing this well. With a joking aside, about 10 years ago, we have built a research technology transition team, RTT, with FAA. So we have always worked very closely with FAA for air traffic management and safety and vehicle technologies. But what RTT allowed is FAA key decision makers actually participate in all phases of research development. And so NASA really knows what to develop and how to develop. And FAA knows when to receive this technology and put it in the implementation plan. This is an enormous level of improvement. And I cannot thank enough FAA's executive team to facilitate this and support this. So that's what I say we have practiced. So as we're going into, as Pete mentioned about the fast and safe and cost-effective certification, and FAA has been working really hard, and I really think they stepped up to meet the community needs. And we have laid out this sort of tech transfer path, and we should use that muscles between NASA and FAA and GAMA and other organizations.
Yeah, I think to add on that, I think the research transition team concept has been extremely productive over the years, and it's one we continue to leverage. I think it's exciting that Jay-Wan and the NASA team have launched the Grand Challenge for Urban Mobility. What it does, and we've been working closely with NASA as they go through that process and make sure that that transition path is there, all from the leadership down to the staff level. And I think one of the things that's really exciting about it is the grand challenge is while we're working with companies individually on their products and we're looking and working with the industry, this offers an opportunity for the integrated test environment. You know, a lot of the challenges with urban mobility aren't necessarily in the vehicle technologies, particularly the vehicles we see today. We know how to certify those by and large. As we move forward with greater pushes towards autonomy and increased tech integration into the vehicles, yeah, there's some questions we have to go and resolve, but most of the challenges is really deal on the integration side, right? How does that vehicle integrate with the flight operation? If you look at contingency planning, you look at deviation, safety, you know, routes of travel, community engagement, air traffic interfaces. The grand challenge offers a remarkable opportunity to really stretch and exercise those seams in a controlled environment and allow us to learn and grow.
That's wonderful. And kind of talking about the way that you all are working together, you know, Gamma, as Pete mentioned in the beginning, has really spearheaded a lot of this work on the urban air mobility side. So if we really want to organize and kind of mobilize industry to make sure that we're coordinating as effectively as possible with industry, what can Gamma really best do in this space?
Well, as you know, when you were at Gamma, you were there at the beginning, and when we kicked off the effort with this, and one of the things we wanted to do first and foremost was make this international in nature, exactly what Mike emphasized, because this industry is totally global and we want to be able to sell product all over the planet. So by developing the industry standards that we use, and we use ASTM for these purposes for Part 23 and CS23 in Europe, as we stood up these standards bodies, we have industry experts participating with regulator experts from all over the planet. When we initially set up some of the first standards that people can just go to the shelf and pick off a standard to be able to apply to the product, we had representatives from FAA, EASA, Transport Canada, ANAC in Brazil, CAAC in China, all the major players around. Authorities from New Zealand were participating. So one of our companies is actually working to certify their aircraft down there, because all of the regulators see the value in being able to keep these standards fresh. You look at them recurrently, and it's so much more efficient than trying to do rulemaking all the time. And so one of the things that Mike said is very important, is that we have to keep this harmonization between authorities going. There's a little bit different methodology that EASA is proceeding along with right now. So some of our companies that are certifying their product through EASA, we've got to be able to make sure that when validation time comes that they can mesh. And so that's what our job as an international association is to do, is to talk to the regulators on both sides of the Atlantic and all throughout the planet to say, okay, how are we going to make sure that we have commonality here? And that's why, to me, Part 23, CS23 is such a valuable tool for us, because it is a very harmonized common reg using those standards.
Yeah, absolutely. Oh, go ahead, Mike.
Yeah, I just wanted to tag on a little bit of what Pete said in the importance of standards.
Mm-hmm.
One of the features of that Part 23 small airplane rewrite, moving it to performance-based, was that there is now the utility of voluntary consensus standards as a means of compliance. The authorities can review those standards and determine whether or not those meet the safety objectives of the regulations. And so that's extremely powerful for the authorities, for us to take advantage of, as Pete said, the world's expertise, not just a small advisory team of industry or the public, but now we have the ability to tap into the full expertise of the world. All the experts that are out there, they develop the consensus standards, and we can evaluate those and determine if they meet the safety objective. And if they do, we can accept them as a means of compliance. The key role for the industry there is, industry is supporting all these standards bodies, so there's a natural prioritization that occurs within industry of where they want to put their time and effort into the standards. And that, in fact, because they can match that their technology investment with their standards investment, it allows us to move much more rapidly and keep pace with the emergence of new technology as well. So it's a win on multiple levels, and I think, frankly, what we've seen is a wholesale spawning of innovation and new, not only vehicle concepts, but technologies as a result of this progress of the, that new shift in regulatory framework.
If I may add one more point, I think from regulatory side, again, GAMA has been spearheading international harmonization and discussion. I want to just mention to the audience, that we have also from R&D side, we started coordinating with 27 member states. We have an organization called International Forum for Aviation Research, which was founded about 10 years ago. German DRR and we, NASA, were the founding members, and now it has grown to 27 members. So just about every developed and developing countries that do any kinds of aviation research are members to this body. So we actually published UAM white paper. It's not really well known as yet, but you can search. And so while Pete and Mike and many others working in the regulatory side, we are ready and gearing up to support from a technology development side.
Just yesterday, we had our infrastructure subcommittee of the EPIC meet, and Jaewon had 4 of his people there, and we all sat and just were amazed at the amount of knowledge that was imparted to our committee just on looking at the power grid and what it will take to be able to provide the power generation to, whether it's Skyport, Vertiport, whatever we're calling it out there, but also just how energy is priced, how storage capacity has to be built, how much renewable is actually now into the system that makes it cheaper to actually buy electricity during the day than the night. And so by bringing not only our experts from the aerospace industry together, but now to start expanding this network to include the power companies and those that will provide the digital networks for us to communicate between these vehicles, each ring starts to get progressively bigger, but that's what we have to do because I think we can get these aircraft certified, we can get them in the airspace, but if we can't charge them, we're stuck.
Yeah, no, that's a great point, and it's always interesting to hear what NASA's working on. I think, to your point, maybe the white papers don't go out as much as we'd like, but it's knowing that you all have dedicated these resources is incredibly encouraging, and it's the same thing for the FAA being as supportive as they are for this new industry and this new technology. But Pete kind of hit on a point in terms of being a global product, and we talked about that as well. Uber Air is a global product. Uber is a global company. GAMA is a global association, but we have 2 U.S. agencies here. So what does the U.S. do to be a leader in this field?
Could you repeat that last bit?
What does the U.S. do to be a leader in the field of urban aviation?
Well, I think Jaewon hit on it in terms of that leading that engagement, and it's really the very active and proactive outreach to our counterparts around the world, and setting an example with the policies that we're putting in place. Now, we do work very closely with authorities around the world on the approaches we're taking and making sure that we are, in fact, putting the right framework in place and working with them to understand when they're deviating from that or they're doing something different. Why is that? What is the environmental issue in that area that would lead them to a different approach, but fundamentally really looking to establish the correct level of safety in the regulatory framework and then advocating that around the world.
Yeah, from NASA's perspective, we have always been developing technologies that will enable new market or new capabilities and improving industrial products. So we're applying the same concept and logic, and the reason why we are building this series of grand challenges is exactly that, as Mike mentioned earlier. Each individual company, I think, has been investing a lot and doing great in developing vehicles, and service suppliers also making a lot of progress. And you showed amply about the evidence earlier. But there is a role for government entities like NASA to address system-wide issues. So safety and noise, and some certification basis. We need to build up that knowledge and database to go through a proper certification process. So those system-level issues, I think our government is well fit to support the community. So that's what we are trying to do. And at the same time, in order for U.S. to be continue to be leader in aviation, including this UAM, I believe we really need to double up providing flight test environment, not just very remote area,
right.
nothing out there, but a more representative environment and 24/7 access. We hear that a lot from companies that, hey, we don't want to wait for some certain rigid schedule to go and test. If we are ready, we want to go and test. So I think that's something that government can work better. I know FAA has been really trying to improve that area, and we are ready to support that as well.
Kate, I would just add that one of the ways I think both FAA and NASA can show global leadership is to be open to the other authorities. Mike has been very welcoming for our member companies that are certifying in Europe and in other locations to say, come on into us early and let's do this together. One of our business jet manufacturers just certified a business jet, and on the same day had 3 different certifications from ANAC in Brazil, FAA, and EASA on the very same day. And the more our companies and the FAA brings them in and Jaywan's team shares that information, we can go and certify these aircraft concurrently, and that'll help the whole collective.
That's great. Well, we are going to wrap up here in a couple of minutes, so I kind of want to get one final thought from each of you on really what is the biggest hurdle for this new industry. And Jaywan touched on issues like noise, and of course we all know that that's an issue. Safety is always an issue. But from your perspective, what is the biggest issue that is something that we can all work together to tackle? Jaywan, go ahead.
We'll go down this way. I think it is really public acceptance. So to that end, all the elements of this ecosystem that Uber has been really promoting, we all need to progress together at the same pace. So vehicles and service providers and infrastructure folks and batteries and charging stations and smart cities, all these entities need to progress together in coordinated fashion to show general public that this is safe, economical, and really best alternative for ground transportation.
Yeah, I think I'll echo the same thing. It really boils down to public acceptance, and there are a variety of ways that that's going to be there from the point of view of where we stand in the FAA. It really gets down to the public acceptance of the safety case and the operation. So for the industry to keep that front and center as it's working on all of the other things it needs to work on is going to be paramount.
Great.
I would say our biggest hurdle would be everybody looking at this and as Eric pointed out, thinking 2-dimensionally instead of 3-dimensionally. I heard last week, aren't the skies just going to be too crowded when we've got unmanned vehicles all operating predominantly below 400 feet, below line of sight? How are we going to do that, safely integrate into the National Airspace System? Instead of thinking exactly what Eric pointed out, if we think 3-dimensionally, and we think about airspace, and those of you that fly, you know, in Class B airspace around major metropolitan areas, you got an upside-down wedding cake. It goes down to the surface, but it doesn't take long to get out of that. So if you've got this tube that you're able to launch vertically, be able to get up away from the unmanned vehicles that are going to be down low, fly in that tube till you get to a gate where the Class B no longer goes down to the surface, and then you have total freedom of movement. If you take like Boston, the edge of that airspace that goes down to the surface is halfway out to 95. So all that suburban area is open with total freedom of movement outside of it. And if you enter a gate and enter a tube with vehicle, it's very easy to be able to deconflict with aircraft that are coming into airports. Those of us that have been around this industry a long time heard about the crush of VLJs that was going to happen. It was going to blacken the skies. Senator Stevens called it the Mosquito Air Force at the time. And we all realized over time it was integrated just like any other vehicle out there. So that's why a conference like this is so valuable, because it gets people talking and realizing we can do this, and the time horizon is much closer than people really think. This has got to be the most exciting time in aviation since the dawn of the jet age. And so I'm so glad that everyone in this room wants to be part of it, because it's the most exciting thing I've been participating in my career.
That's great. I obviously agree. So thank you for that. I really appreciate all three of you taking the time to sit with us. I think this is an incredibly valuable discussion, especially to have it from three experts in this field who really know better than anyone else what it's going to take for a new industry to evolve and develop. So thank you all so much, and please help me in thanking our panelists.
Let's give them another round of applause. Thank you so much, Kate, Dr. Shin, Dr. Romanowski, and Pete. That was awesome. So we're going to take a short break, just 20 minutes. So just limited to the atrium. You can get coffee, water, drinks, snacks. Please stay in the atrium if possible. We'll be back here at 11 a.m. sharp to hear the United States Secretary of Transportation, Elaine Chao. See you soon.
Ladies and gentlemen, please silence your cell phones. The show is about to begin. Please welcome Eric Allison, head of Uber Elevate.
I am delighted to introduce U.S. Secretary of Transportation, Elaine Al Chao. Previously, she served as U.S. Secretary of Labor, the first Asian American woman in American history to be appointed to the President's cabinet. Secretary Chao has one of the strongest transportation backgrounds of any U.S. Secretary of Transportation. She began her government career working on transportation issues in the White House. She then served as Deputy Maritime Administrator, Chairman of the Federal Maritime Commission, and Deputy Secretary of Transportation. As U.S. Secretary of Transportation, she has focused on safety, infrastructure, and innovation to ensure that our country remains a global technology leader. In fact, it's safe to say that Secretary Chao is one of the most forward-thinking and innovation-friendly chief executives the department has ever had. She launched numerous AV initiatives, including summits, listening sessions, and the publication of 2 major autonomous vehicle guidance documents, AV 2.0 and AV 3.0. She has helped ramp up the department's drone efforts with unprecedented UAS pilot program and 4 groundbreaking new rulemakings to enable the safe testing and deployment of drones. And during her watch, the department has undertaken a major streamlining of government regulations governing rocket launches to help ensure that our country remains #1 in commercial space launches. So please join me in welcoming Secretary Chao.
Please welcome Elaine Chao, United States Secretary of Transportation.
Hi, everyone. So nice to be here. I hear that you're going to have a really, really important and interesting conference. So I'm so pleased to be a part of it. This summit focuses on an exciting concept, and that's the whole concept about aviation. It talks about on-demand vertical takeoff and landing aero taxis. Urban air mobility is joining autonomous vehicles, drones, and reusable rockets in a wave of transportation innovation that will change the way in which we live, work, and travel. And the department is already playing an important role in enabling this change. The rate of change, as you all know, is impressive. Already more than 1,400 autonomous vehicles are being tested in the United States by more than 80 companies. And these tests are taking place in 36 states, plus Washington, D.C. These initiatives come as the use of drones continues to grow. And at the end of May 2019, there are more than 1.39 million registered drones in the United States, of which more than 372,000 are registered for commercial use. And there are more than 136,000 certified drone operators nearly triple the number in 2017, and this is a job category that didn't exist 5 years ago. And then, of course, we've got commercial space. Commercial space is really taking off with reusable rockets and air launch systems. For the first time in 14 years, America has regained global first place in commercial space launches. The U.S. went from 23 commercial launches in 2017 to 33 in 2018. And as many as 44 commercial launches are anticipated this year, and as many as probably 56 commercial launches are expected annually by 2021. Air taxis are part of this transformational innovation. Of course, there's a lot of questions. There are a lot of questions about these systems. What type of propulsion system will be used? Where and how far and how fast will they fly? Will they be manned, remotely controlled, or self-piloted? What kind of flight navigation and guidance technology will be on board? This leads to questions about governance and how to ensure that aerotaxis can safely operate in our crowded and increasingly crowded airspace. Now, since they may not fit perfectly with traditional, within traditional travel categories, the other question is, how should they be regulated? As manned helicopters, or as drones, as personal or commercial vehicles? And a key question is, what government agency or agencies will monitor and regulate aerotaxis? So as we address these important questions, we wanted to be guided by certain principles. And at this Department of Transportation, in this administration, we are guided by three top priorities. One, safety is always number one. It is the foundation of everything that the department does. The second priority is rebuilding and refurbishing our country's infrastructure to grow the economy, increase competitiveness, improve productivity, and improve the quality of life for everyone. And then the third priority is preparing for the future. We have a responsibility to do that. And we will do so by engaging with new emerging technologies to address legitimate public concerns about safety, security, and privacy without hampering innovation. The department's regulatory strategy avoids overly prescriptive rules in favor of a performance-based approach. So we want to be tech neutral and not command and control. We're not in the business of picking winners and losers, you will be so pleased to hear. That decision is going to be left to the public. So it's important for developers to engage the public early and often to address legitimate concerns and questions about safety, security, privacy, and another one, noise. To help answer questions like these, on March 12th of this year, the department announced the formation of the Non-Traditional and Emerging Transportation Technologies Council, or NET Council. To let you know how much power I have, I actually asked for that name to be changed. It's still called the NET Council. But this council will coordinate internal review of new technologies that have implications across multiple DOT agencies. The NET Council is empowered to establish working groups for each new cross-modal project. And internally, it's going to address and resolve, hopefully, matters of jurisdiction and policy. And externally, it will ensure that project sponsors have a single point of contact or access to discuss plans and proposals. And going forward, there will be one place, a one-stop shop for innovators and stakeholders to work with the department to address new technologies that touch upon multiple transportation systems. The operations of aerotaxis themselves clearly fall within the oversight of the FAA. But operators have got to work with FAA to get permission to conduct flights, delivering packages, or even people by drones. But getting the economic authority to charge customers for these services comes from a variety of different organizations. The Office of Aviation and International Affairs, which is part of the Office of the Secretary of the Transportation. So this came as a surprise to a lot of these new tech operators who don't really understand government very well, and also UAS manufacturers when they first began to explore drone deliveries. And so on April 30th, 2018, the department issued a notice to advise UAS operators that they may need to register with OST, Office of the Secretary, if they want to deliver packages for compensation. So to stay ahead of this issue, the department continues to actively engage in discussions with UAS operators to better understand their operations and provide options for the different types of economic licensing currently available. These discussions, I think, have been pretty helpful in the department's ongoing effort to become more responsive to the outside community of stakeholders. There are other drone-related activities in the department that may interest you as well. The Unmanned Aircraft Systems Integration Pilot Program was launched in 2017. And the department selected projects from around the country to test the safe operation of drones in a variety of conditions, currently only permitted by literally manual waiver or exception. These include over the heads of people, at night, and beyond the line of sight. So the IPP enables live operations, including package delivery by drone, and future regulatory efforts will be shaped by concrete data gathered from actual flight experience. And that's just the beginning. Data gathered from drone package deliverers may prove useful in the development of vehicles, systems, procedures, and infrastructure for safety, picking up and delivering people even. So additionally, in January of this year, the department awarded contracts to service providers for the development of an air traffic management system for drones. It will supply flight planning, communications, separation, weather services for drones, which will operate under 400 feet. And this system is separate from, but complementary to the traditional FAA air traffic management system. It will help to create a kind of a shared information network and a framework for maintaining air safety. And this should really benefit urban air mobility systems since they will operate within this airspace. And in addition, 2 recent announcements of proposed rules will also impact aerotaxi development. The proposed rule for operation of small unmanned aircraft systems over people will allow routine drone flights over people and at night under certain conditions without having to obtain a waiver or an exemption. But this will only be allowed if the operator has received appropriate safety training, completed approved testing, and the drone is equipped with kind of like anti-collision lighting and meets other physical and technical criteria. Well, since aero taxis will likely operate at night and over the heads of people, the FAA will need to determine which existing regulations might apply and what new regulations may be needed to fill in the gaps. So another initiative of note is the Advance Notice of Proposed Rulemaking for the safe and secure operations of small unmanned aircraft systems. This focuses on the security issues that drones in the hands of bad actors could pose and how to ameliorate them. But perhaps the most important next step is taking the issue of remote identification. Think of remote identification as an electronic license plate. Knowing who is out there and where they're going can be critical, not just in terms of safety and security, but also in terms of public acceptance. The department is moving forward on this critical effort, and you can expect a proposed rule in remote identification later this year. It's a pretty complicated issue, and we need to get it right. So remote identification is essential to enabling routine drone and aero taxi operations. And a lot of the lessons learned from integrating drones into the national airspace will also be applicable to urban air mobility as well. So the FAA has a lot of experience with traditional aircraft designs and operating concepts. And over the last 2 years, the FAA has been amassing an increasing amount of operational experience with unmanned entrance into the national airspace. And it has used that experience to help enable different kinds of drone operations, even those once considered quite experimental. So, as you can see, the department has a very strong innovation agenda. But as you know so well, public acceptance is a critical element in determining if any of these new technologies are actually deployed. So let me once again challenge developers to step up and help educate the public about their vision of the benefits of these new technologies. Because without public acceptance, these technologies will never realize their full potential. So I appreciate so much the opportunity to be here today. You're going to have a great conference with great speakers. So hope you learn a lot and have lots and lots of good ideas. Thanks so much. Great.
Thank you so much, Ms. Secretary. Please offer her another round of applause. For our next session, we have a super exciting panel in store for everyone. As you heard Secretary Chao talk about low-altitude airspace and the technology to manage that low-altitude airspace is critical, not just for urban air mobility for people, but also for the movement of things. And so we've got a really great panel moderated by Lisa Ellman and a number of her colleagues across the industry. So please join me in welcoming our panelists.
Please welcome moderator Lisa Ellman, Co-Executive Director, Commercial Drone Alliance, and panelists Tom Prevost, Parimal Koperdecker, Sean Cassidy, Margaret Stewart Nagel, and Jay Merkel.
So many familiar faces here today, so many friends and colleagues. We are about to dive in on unmanned traffic management, or low altitude airspace, and thrilled to be here. So PK, let's start with you. NASA had this grand vision a few years ago now, and you really took the low altitude airspace challenge. You partnered with the FAA, you partnered with leaders in industry, and you had a vision on how to manage aircraft in the low altitude airspace. This is now well known. We've heard today about UTM, or unmanned traffic management. But what was so new about this at the time, and what was NASA hoping to achieve with this vision?
Yeah, thank you, Lisa. And first of all, thank you, Uber and Tom, for acknowledging that airspace is one of the interesting challenges. Used to be the airspace would be on the last day of the conference, in the last session, but now we have come a long ways. We are on the first set of the session, so it's great to be here. So a few years ago, about 4 years ago, we started to think about what would future look like and what kind of support system for air transportation we need to have. Current practices are too cumbersome to accommodate the 800,000 plus small drones that are expected by 2023 and so on. So we felt that we need to have a different way of looking at and accommodating these vehicles. So we started to think about migrating away from clearance-based delivery to managed by exception, instead of figuring out what to do or instruct the vehicles what to do, tell them what not to do, and leave the operators to decide what to do. So focused on cooperative, digital, intent sharing, leveraging third-party services for tracking, flight planning, weather data, and such, and then migrating towards managed by exception. So that was the main set of tenets for UTM. And the other underpinning of that is to work very collaboratively with FAA, DoD, DHS, and industry partners, all of us together to solve this problem. So it's an example of collaborative innovation. NASA, we started the idea, but then we also brought everybody together to solve it and take advantage of everybody's capabilities.
Excellent. And you all have done a great job, PK. And Jay, you at the FAA have somewhat taken this baton from NASA, and you're running with it and looking to implement UTM, or are implementing UTM. Can you talk a bit about FAA's efforts?
Sure. It was after one of PK's UTM meetings out in NASA that we realized that not only was NASA onto something we really needed to understand and adopt, but we needed to do it quickly. And so it was really a seminal moment in the FAA realizing that UTM was not only coming, but needed to come very quickly. So our efforts in registration, automated airspace authorization, and now in remote identification are all stepping stones on the path to UTM. And true to the concept that industry and NASA developed together, we're pursuing this as a public-private partnership. I don't think we would ever be able to afford an infrastructure for the sheer number of drones. And the places they fly, it would be impossible. In fact, I remember my reaction to PK's first chart that had little things like radars all over the United States, and we can't afford that. $10 million of radar, all the radars we would have to put out, we can barely afford what we have today, right? And so taking this very innovative public-private partnership approach was very important. And we've learned along the way from registration and from LANCE, our low-altitude, and I know the acronym, Low-Altitude Authorization and Notification Capability. And now Remote ID is really our next step in that journey. And I think all of us on this panel agree Remote ID has to be done right, or we will not be able to enable the next phases of UTM.
Well, speaking of Remote ID, Margaret, you and your colleagues at Wing have really taken a leading role on development of that Remote ID standard. Of course, industry agrees that in order to have commercial drones flying broadly and air taxis taking off, that UTM and Remote ID is critical. And you've played a leading role in that. Can you talk about from your perspective and the broader industry perspective?
Sure. Agree that Remote ID is really critical for safe and secure integration of drones into the NAS. And so it's been a priority, I think, not just for us, but for all of industry to make that happen. I think it's also really important as we've thought about our operations from a community perspective, and as the community begins to see drones flying more and more in their neighborhood, having the ability to look up and know what that drone is that's flying around them, I think that's a very important component of Remote ID as well. The next thing that I would say is I've seen industry really come together over the last handful of months around the Remote ID standards that are being worked at ASTM. And it's really exciting to see the progress there. And I think the standard for both network and broadcast Remote ID is very close to being complete. And there's a lot of industry consensus there. And so I think that will help us move forward as an industry. And hopefully in partnership with FAA and NASA and others who have been at least observing those sort of that work. The other thing that I would just note on Remote ID that I think is important and that we've spent a lot of time thinking about is that it can create both transparency, but it can also protect privacy. And I think as we think about drones and the way they will interact with communities and with the environment that they're in, it's important that we create solutions on the technical side that have both of those capabilities.
Mm-hmm. Absolutely, and I think the industry would strongly agree, and I think that the government would also agree with that. So Sean, we're aware that Amazon is also, you're working on small drone delivery as well. And of course, we're all very excited about this. What do you see as the path to enabling commercial drone package delivery? And what do you think are critical aspects to successful low altitude operations?
Great question. So first of all, I think as most of you are aware, we had an announcement just this other week about our new delivery system that we're going to be wrapping our first commercial deliveries around. We're very excited about that. The other thing that was repeated earlier, which bears repeating, is that no viable commercial operation will be viable for much longer unless it's a safe one. And Margaret just talked about safety and transparency, which we certainly share. So before we do our first customer delivery, we are going to be absolutely sure that we can do so safely. Now, as far as the things that any commercial operator has to think about, as we have, is first of all decomposing the concept of operations, taking the business case and looking at every single phase of that business case and understanding what required safety mitigations are going to be required for that business case. And those mitigations then transfer into the design of the vehicle and the airworthiness requirements for the system. So it's the business case, the concept of operations, which leads to the airworthiness, the performance of the vehicle. But then the final thing, which I think we've been talking about in the context of UTM, is how do you safely integrate into the airspace? And I think that that's one of the things that we spend an awful lot of time pouring resources and energy into, is using the construct of UTM, much like my past as an airline pilot, to separate trajectories strategically, as you would flight plans, And then the next thing, also with the assistance of a UTM construct, is having the means by which you can have ad hoc communications or communication sessions between vehicles, either directly or through perhaps a ground station, in order to ensure safe separation assurance. And I think the third part, which is particularly applicable to our ConOps, is having independent ability, sensor-based ability, to detect and avoid other vehicles in the absence of any communications protocol, in the absence of any kind of ground-based system. I think it's all those things that roll up to make our commercial operation a viable and a safe one.
Great, thank you. And you've, just to follow up, I know Margaret talked about several of these standard-setting efforts. You've been involved with many of those as well?
Oh, me, yes. We've been involved. I know that there was some mention earlier. I think Pete Bunce from Gamma was mentioning all the great work that ASTM is doing. We happen to actually lead the F-38 working group for the unmanned traffic management. We work very closely with Google and others on the remote ID. And I'll just put one more plug into what Margaret just mentioned, is that even in the absence of rulemaking, even before there's kind of the formal framework and requirement, we should be referencing those standards, and we should be applying those in our operations so we can demonstrate the safety and viability of those.
Mm-hmm. And I think that said, the commercial drone industry and the UAM community is very much looking forward to a remote ID rulemaking to help kind of put together a comprehensive framework. Jay, the latest timeline I've heard is September?
That's correct. And in performance-based rulemaking, that's the approach we're taking with remote ID, you very much rely on industry-based consensus standards. So we're very supportive of the work that's being done at ASTM, SAE, CTA, all three of those organizations leading us to standards that would potentially meet the performance required in a remote ID rule. Very, very important. And so with this rule, we're keeping in sync not only the rule, but keeping in mind what's coming along in the standards. At the same time, we're working to build public-private partnerships to build out the infrastructure for remote ID. So it's a complex activity to keep all three in sync.
Gotcha. Well, we're all looking forward to seeing that notice of proposed rulemaking, and of course, all of us from industry will need to engage once we do see that come out of the FAA. So Tom, we've been talking about small drone delivery operations and making those a reality through UTM. You're also, of course, Uber is also in the small drone delivery space with Uber Eats and your IPP program in San Diego. So, but you're also, of course, looking forward to the air taxi market in UAM, making that a reality. What's your view from Uber?
Yeah, so first of all, I'm also extremely happy about kind of the progress that's been made and how well we're working together across everything that, related to UTM already, and the progress has been actually tons of hours and days spent in meetings to progress the standard for remote ID, at least the ASTM standard, to get it out very quickly, which is really, really awesome. There's also all the testing going on with NASA, the technical capability level 4 testing that Uber's also participating in. We're in the IPP, we're in the UTM pilot program. So all these things for us kind of set the foundation for sort of the type of airspace integration model that we want to use for pursue further for air taxis as well. So we kind of really want to build upon the lessons that we're learning through the UTM process and hopefully work with the FAA, extend the construct of UTM towards UAM type operations to allow us actually to scale up and scale up relatively quickly. So I think it's extremely important for us to kind of set the tone right from the beginning and start integrating urban air mobility in a way that is going to be scalable. Again, working very tightly on how can we implement the rules and regulations with the FAA right now through finding more consensus across the industry to really kind of safely share the airspace with drones, air taxis, and everything else.
Yeah. And of course, the collaboration, like you said, is critical. And events like this are really critical, right? Bringing together industry and government and regulators and policymakers, and hopefully you all have a chance to meet each other and thanks to Uber for bringing us all together. I still remember that first event that NASA hosted back in, what was it, 2015, PK?
Yeah.
Where, when you were planning a small event out in, on the West Coast, and we're hoping for a few hundred people and got maybe a few thousand. That was a key moment, I think, for the community and the UTM community, bringing everyone together to work together towards these common goals. So, back to you, PK. I mean, you're now. You mentioned that there's some work being done right now in Reno. Of course, the next stage is flying in urban areas. What's the latest?
Yeah. So before I answer that question, there are several NASA folks in the audience. For those who are NASA folks, just raise your hand so you can see there are a bunch of people who are here, and there's several on the left wing, some on the right wing, some in the center here. You can all ask them questions as well. UTM has become one of the big projects inside NASA, and it's imbibing the next level, which is the urban air mobility. Fundamentally, what UTM's principles and tenets that we talked about before are meant to not overload the air traffic control system. FAA has the regulatory and operational authority for all airspace, but the idea is to give them the right level of tools and take services from industry to enable the next level of traffic density in the different type of operations and interoperability. The key here is interoperability. Because it's digital, because it's sharing intent with each other, the size and scope of the vehicle is less relevant as you start to increase the density and complexity of operations. So from small drones to these electric vertical takeoff and landing vehicles, they will all be interconnected through UTM type of platform, and standardized application protocol interfaces which allow operators to exchange information about intents.
And I know there's testing ongoing now. Can you give any of us a sneak peek at what you're seeing?
Sure. We did shakedown test in Reno. The actual test starts next week, and then Reno, and then going to Texas in August. But clearly, the Reno and Texas are the TCL4s, but all test sites really have helped us throughout the UTM evolution from technology capability level 1, 2, 3. And there are a number of lessons we learned from in terms of the weather and susceptibility and tolerance to different types of conditions, as well as sense and avoid capabilities and such. So in Reno, one of the test will begin next week, as I mentioned, but one of the key lessons we learned so far, just going through setup and processes, is how well we get basically help from the communities and how critical that is to have community engagement in terms of acceptance. When we were walking around town checking out the processes and such, everybody in town, in that area, downtown Reno, knew we were from NASA, and that we didn't even have to say anything. They were very welcoming and very accepting. So someone had, of course, the mayor's office had done a lot of work to try to prepare the local community for the test, and that was very critical. That was a big eye-opener for me personally, too, to make sure that the community is brought into picture earlier on in terms of acceptance of these things. And the other thing I want to say is FAA has been really a very great partner to help with, Jay and I talked, I still remember there's one item we were talking about it late on Friday, discussing, trying to figure out what to do about certain things. So it was very interesting, and we are very thankful for FAA's continuous guidance and support in making sure that we are doing all the things that are necessary for safe operations and testing.
Yeah, UTM does not know a time zone yet.
It's global.
It is.
Well, speaking of community engagement, of course, Jay was a key part of the integration pilot program, which we've heard about some today from some of our speakers, which was announced by the president, and of course, which was mentioned as well by Secretary Chao, and I think which we can all agree has been a great success. There's also the UPP, so that's the IPP. There's also the UPP, the UTM pilot program, lots of acronyms. From the FAA's perspective, I mean, how helpful are you finding these pilot programs? What kind of information are you getting? I know the UPP is still kind of in process in terms of kicking off, but what do you hope to gain from that program?
Well, it was a year ago in May that we actually signed the agreements with our lead participants. We had 10 at the time. We now have 9. So when we think about the number of operations that we've enabled in the last year, and you kind of relate that to the speed at which you innovate in manned aviation, it's pretty phenomenal. So if I go to San Diego, where Uber is working on their Eats delivery, we also have the Chula Vista Police Department who've used drones as a first responder. And they've dispatched over 400 times, been on scene first, providing police with vital intelligence and video information about the scene, over 280 times with over 60 arrests. I mean, that's real good for society being done today. Wing, one of our partners in Virginia, obviously made aviation history with the first Part 135 certificate, and will begin operations soon. I won't steal your thunder, Margaret. One more that I just want to highlight, and that is State Farm has received a national COA, or Certificate to Operate / waiver, to allow them to do operations in disaster recovery, including some limited ops over people, and partly because the drone is frangible or basically falls apart. The hard pieces fall off if it hits something, and it's covered in soft foam, so it won't do any damage to a vehicle. But those are all accomplishments that have happened in 1 year. But those are really the safe integration into the airspace. Our partners have also been very hard at work with community outreach. And community outreach is going to be vital. Margaret mentioned it. I know I'd like you to speak a little bit about it when I get done framing it. But we have to have a public that is confident that the operations are safe and that the operations are secure. And they also have to understand the operation and what benefit it brings their community. Our experience collectively is the earlier you engage, the more frequently you engage, the better interaction you have with that community. Not very different from what we already know from manned aviation. If you choose not to engage your local community and you want to change the airspace, that is not going to go well, right? And those two pieces we see starting to put in place additional information that will inform how we move towards regulatory frameworks, but also what we'll leave behind for municipalities, states, and others who follow in the path of these leaders and go to approve more operations. So could you give a few words about your experience in Blacksburg?
Yeah, absolutely. So we've, as you said, community engagement is critically important for any of these operations to be successful, and we know that for our operations and for the kind of operations that we want to do to be successful, we have to have the community support. We won't be successful without that, and so we start talking to the areas where we want to operate early, frankly, even before we gain all of the regulatory approvals that we have to do that, and that is a conversation that continues as we build up to operations. And what we've seen in Australia is that we get a lot of questions. You're bringing something to a neighborhood for the first time, right? People are not typically used to seeing drones flying over their houses, and so it's really important to be present and to be available to answer questions about safety, about privacy, about the benefits to the community, about noise, and we get a lot of those questions. Typically, when you spend time with people in the neighborhood, they're excited about the opportunities and they're excited about the benefits, greater sustainability, more efficient delivery of goods, taking cars off the road, things like that. But they want to know that you've done the work with the regulator to prove that your operations are safe. They want to know that you're thinking about the impact that it will have on the community, and really sitting down and having a conversation with them, whether it's showing up at the local mall with a drone and someone to answer questions, or going to the community, the town hall meeting in the community. All of those things, I think, are really important as we think about bringing this really exciting technology into communities.
And when you're talking about, so given that you just received your 135, which was a really big deal. It was a an important step forward for the community as a whole as well. How do you envision your drone delivery operations within the larger airspace operations?
Sure. So I'm going to build a little bit on something that Sean said, right? Airspace is obviously one component of our 135 certificate. How will we operate safely in the airspace? That is the first, safety is always the first priority for any of our operations. And so we spend a lot of time with the FAA and frankly internally thinking about how we'll do that. And UTM is a critical component of that. It's not the only one today, but it's a really critical component of that. And thanks to the work that PK and NASA have been doing for a long time and the work that the FAA has been doing, we have a really good foundation to work off of, right? The vision is there, having a decentralized system that allows competition, that brings industry into that conversation and allows us to innovate, I think has been great. And then industry can go out and build solutions, right? Certainly our planner and our UTM system has been a key component of the approvals that we've gotten with the FAA. And will continue to be so. And I think as we look forward into more operations and when we have Amazon and Uber and others operating in the space as well as recreational users, having a UTM system that can talk to each other it will be critically important. And I think that's where then you see sort of industry builds, then the standards bodies come in and start building standards so that we're building in a way that is collaborative and that works across industry. And so, again, that's the benefit of having these really positive, I would say, positive work that's happening in ASTM and other standards groups around things like remote ID and eventually UTM. I think very soon, actually, at UTM.
Thanks for that, Margaret. So speaking of safety, and Sean, you're co-chairing the UAST, the UAS safety team. How is the work of that group feeding into this broader UTM picture?
Yeah, as a matter of fact, I co-chair the UAST with this fellow that's 2 seats down to the left of me, Jay. And it's a privilege to work with him on the team. So I think the way that, I'm going to riff a little bit off of what Margaret just said, and it's a little bit related to the community question. The UAST is a public-private partnership that's roughly about 80 members right now that come from governmental entities, NASA, FAA, DHS, and others, and as well as industry. And what we do is, even though we compete, very aggressively on the business side of the house, when we walk into the door of the UAST, the one thing we do not compete on is safety. We compete on the marketplace, but we will never compete on safety. And it's taking that mindset that allows us to have this kind of free flow of information and have the collective benefit of some really, really good ideas. For instance, looking at NASA, there's a program called the Aviation Safety Reporting System. It's decades old, goes back to the early 70s, if I remember. And it's a anonymous reporting tool that allows pilots to report in the system if they notice something that's amiss or that maybe they make a mistake. Wouldn't that be great if we could leverage the ASRS reporting tool and create a new reporting tool for the UAS community? And that's exactly what we're doing right now in conjunction with the FAA Council's office and in conjunction with the flight standards. Wouldn't it be great if we could take the stuff that we were talking about earlier this morning, the safety management system, and look at best practices and look at templates that we can then share freely with all the other members that have various types of commercial operations. And that's exactly what we're doing right now. And I think the biggest thing that's coming out of the UAST, which is a little bit of a derivative of the commercial air safety team, which I used to belong to in my commercial days, is that we're putting up front the community's commitment to promote voluntary recommendations that drive up the collective safety of the operations, which, tracing it back to the community receptiveness, I think is incredibly important that we show this collective collaborative effort towards introducing this community and introducing our commitment to safe and responsible behavior.
Great. No, thanks for that, Sean. So, I mean, I think we can all agree when we talk about UAM policy, moving UAM forward, there are a lot of lessons learned from the small UAS industry and policy that we can cite to that we understand that there are certain issues that are going to come up, and in many ways, UAS policymaking has been foundational for the UAM industry to really take off. What's your view, Tom, is from the Uber perspective as you look at lessons learned from the small drone delivery context and what that means for the larger air taxi market?
Yeah, I think the first lesson, and it's really amazing when you think about it, and I mean, PK kind of started the whole UTM thing. I was in there relatively early as well, just from sort of dreaming it up a little bit and seeing it actually come to life, I think the most amazing thing is that it actually, it works. I mean, we are...
Thank God it works.
So we're all really working together through research, through implementation, through building the standards bodies, and we're making just tremendous progress. I think, like Jay was saying, we're really moving the needle, and we're doing it all in a very, very safe environment. And so we should really take this model and keep applying it towards what we do with UAM. And continue down that path, I think. And there's many lessons learned from our perspective. The way that we manage drones is not very different from the way that we intend to manage small passenger-carrying vehicles. Of course, where we're going to have pilots initially in there, but I mean, they're going to be flying very well-determined flight paths, structured routings, in a sense, things that have been deconflicted with other folks that are in there. We're all going to be sharing the same airspace. If we take off from skyports, they're going to be very close to other drones. But we're also then going to go into other airspace classes as well, where we have the bigger air carriers. So we got to work on integrating those properly. But I do think this overall model of these types of partnerships and working very, very closely, lockstep essentially with the regulators and with other companies is really something that is extremely promising. And I believe that even though we are continuing to set relatively tight goals on when we want to start to operate, as long as we keep the process going, as long as we keep the collaborative spirit and the cooperation going, that I'm thinking very, very positive that we can find good ways of airspace integration and making this, at least from an airspace perspective, really happen and not be the factor that's going to kind of stop everything or bring everything to a halt.
Mm-hmm. Oh, absolutely. And there are definitely lessons learned. And PK and Jay, I'd be curious from your perspectives, from your agency's perspective, how are you approaching lessons learned from the small UAS context in as we see larger UAS and eventually the air taxi market?
You want to go first?
Sure, yeah. So there are a number of technical lessons. One is we need to have methods and expect that GPS may not work everywhere. We need to make sure that we have methods to accommodate when the comm doesn't work everywhere. We need to make sure that we can address the changes in environmental conditions such as wind and temperature, rapid temperature changes and such. So we have learned a number of lessons that actually have got into the UTM construct. So that's on the technical side. But on the collaboration side, without the folks that are sitting on the table and many on the chairs here and many folks in the audience, UTM would not have happened. Truly collaboration with everybody that was involved. Everybody brought something to the table, and that was a really key lesson here. To accelerate, to go fast, and to make it very more inclusive. I think collaboration and collaborative innovation is really key. And we're taking those lessons and now going towards urban air mobility that NASA is launching in terms of Grand Challenge and collaboration with the industry. So talk to the NASA members about how you can participate in a similar fashion with the urban air mobility Grand Challenge and other initiatives that we are undertaking. Those are the key things that I would say, but really working collaboratively is fundamental to...
Key.
Yeah.
I think you're so collaborative that you even set your members on the left, center, and right side of the aisle. I mean, that was pretty impressive, too.
So from our perspective, as the regulator and the air navigation service provider, much of the work that NASA does in collaboration with industry is actually tech transferred directly to industry. It's not necessarily transferred to the FAA and then sent to industry. So we actually see, and we expect to see the work coming back from the Grand Challenge coming to us the same way that it came through UAS, and that's really through applications. either for airworthiness or flight operations or airspace integration. And one of our biggest lessons learned from the UAS community, and we're taking forward in the UTM capability, or excuse me, the UAM space, is we need to have airworthiness experts, flight operations experts, and airspace integration experts working with the applicants from the very beginning. Because unlike manned aviation, where the interfaces between the aircraft and the airspace, or the pilot and the aircraft, have been relatively static for at least a couple decades, there are opportunities to mitigate risks that were previously mitigated with a pilot can now be mitigated with the aircraft. Or the infrastructure can mitigate risks that might have been mitigated by the aircraft in the past. And we found that you have to have all three of those in the conversation. The other lesson we really learned is that you can't wait for regulation. And we've demonstrated that our existing regulation and guidance really can enable these operations. And so we work to enable early operations that then allows us to collect data that informs later operations. I think we've gotten away from that model that says you need to bring us the perfect answer. It's the, here's a starting answer, let's go work on that. Okay, a few months, maybe a year later, now here's the next answer. And we start building on those opportunities. So I would say those are the big collaboration pieces that have informed where we are today and where we plan to move forward. Very much taking what we learned from the UAS space, the small drone space.
That's fantastic. And all of these lessons will be very important, in all the continuing collaboration will be critical. Question for the whole panel. So we've talked a lot about the United States, what's going on here in the US. What are you seeing in other countries around the world? Obviously, this is a global challenge. Other countries are thinking about these same opportunities and challenges.
Okay, well, I'll start. So what we're seeing is that even though the taxonomy may change a little bit, U-Space versus UTM, for instance, a lot of the core elements are the same. And so it's a matter of promoting, for instance, remote ID here in the United States actually translates into electronic conspicuity over in Europe. But the building blocks for those things are exactly the same. So I think that the important part is that we don't necessarily look at these things as sequential events happening where something happens in the US and then that builds it upon in the Europe, but more in Asia, but more basically feeding in and having the synergistic effect where they all actually have a value-added prospect towards promoting the development of safe standards, safe techniques, safe equipage, and safe policies.
I would say from the regulator perspective, we're seeing that companies that are operating in other parts of the world and get their safety approvals there are learning techniques and bringing safety information to us. And likewise, we see the companies working with us going overseas doing the same thing. Back to Sean's point, we're not competing on safety. This isn't a global challenge to some trophy. It's a global challenge to safe integration, and everyone's working together. I've also seen that we have, it doesn't matter where the seed takes root and starts to sprout, it spreads across the globe very quickly. This is a digital age, this is a digital community, so it doesn't matter which country or what country it's developed in, it spreads. And part of the ability to spread is back to sharing the core principles and all working towards common standards. And I think that is going to make the spread of all this very, very rapid. And we're starting now as a regulator to develop relationships with other like-minded regulators so that we can directly share information about how it's going in each other's countries.
Yes, that will be incredibly helpful, the data sharing and information sharing. PK?
Yeah, so certainly there's a ICAO group on UTM for harmonizing the concepts. There is a number of countries that are adopted, Japan, JUTM, Korea, KUTM, Singapore, Australia. There are like places where and Europe with U-Space. So there's variations, slight variations, but essentially the ideas and the construct is pretty much the same. And the other interesting thing about UTM is because of such a good, tight collaboration with government, FAA, industry, FAA started to deploy things in a much more agile fashion with LANs and remote ID. Traditional tech transition process would be we would build something, then we'll validate all that at the end, and then transfer it. And then with this, I consider this much more agile management style where you are actually showing some limited capabilities, we test them, they work, and then FAA is able to implement them in a way that will benefit everybody. So I don't think we're waiting for every part of the solution, but taking pieces and getting there.
And PK, I think you're being a little bit modest. If I continue with the seed metaphor, you and NASA really are the Johnny Appleseed of UTM, and you've planted those seeds across the globe, and that's why we have sharing of core concepts. It was really the work that you did, you and your colleagues at NASA taking those core concepts that paved the road for us as regulators and industry as well to start using these core concepts across the globe.
I think we can all agree on that. So thank you, PK, and to other NASA colleagues here in the audience. Well, we only have a few seconds left. Any last words? I think we can all agree that collaboration is key. Any last words about how we can continue to collaborate together, or areas of improvement, or any final thoughts from the panel?
Well, I just want to say I'm very happy with where we are right now as far as the collaboration is concerned. I'm also very, very thankful about my colleagues here that they're all here and sharing the stage with us and talking about these things. I just want to basically continue down this path because I think it's a very, very good way to potentially be successful very soon.
Absolutely. Anyone else?
We need to lean in strategically. I mean, we work so well together in so many committees and working groups and everything else. You know, setting aside the separate business interests, right now we're at the point where we really need to lock arms and drive forward towards industry standards, remote ID, UTM, and all those things, irrespective of the business case. And fortunately, we're doing that right now.
Agree.
Agree, absolutely. Well, thank you, Tom and Uber, for bringing us all together so that we could collaborate on this panel. Look forward to continuing collaboration. And please join me in thanking our panelists.
Please give it up for Lisa and the panelists once more. So now we're on to the best part of the day, lunch. Lunch is going to be outside in the Woodrow Wilson Plaza. Basically, just exit this room. There will be a number of brand ambassadors in bright orange polos. They will be leading the direction out to the lunch plaza. Everyone, please be back here by 1:15 so we can get started on time. And while you're outside, please check out activations from the Bell Nexus team, as well as the Jump Uber all-electric bikes. So please enjoy lunch. See you back here soon. Thank you.
Please welcome Tony West, Chief Legal Officer, Uber.
Still not good? Okay, can we start over?
Ladies and gentlemen, the show will start in 10 minutes. Ladies and gentlemen, the show will start in 5 minutes. Ladies and gentlemen, the show will start in 2 minutes. Ladies and gentlemen, please silence your cell phones. The show is about to begin. Please welcome back to the stage Master of Ceremonies, Nikhil Goyal.
All right. How's lunch? Good. Really excited for this afternoon. We're not even halfway done. It's a very exciting block of events and activities all afternoon. Our next speaker is the Acting Administrator of the Federal Aviation Administration, Dan Elwell. Please join me in welcoming him to the stage. Dan?
Please welcome Dan Elwell, Acting Administrator, Federal Aviation Administration.
Thank you, Nikhil, for that introduction. And it is awesome to be here, soaking up the energy, creativity, and innovation of a brand new form of transportation. And I find your vision for the future to be refreshing, invigorating even. And that's not easy to say coming from me, from where I sit, because we at the FAA have historically been a bit reticent to welcome new entrants in the national airspace system. But that is changing rapidly. It has to change, because this kind of energy, innovation, and vision is what will fuel the future of aerospace. And frankly, get the next generation of kids interested in taking part. Because they see innovation as a Tesla Roadster circling the sun, blasting David Bowie, or rocket boosters coming back and landing softly on the Earth. Or drones delivering popsicles, or slipping the surly bonds of traffic in a flying taxi. And look, let's face it, you guys make aerospace cool again. The energy you bring is also helping us at the FAA become more responsive to a rapidly evolving aerospace industry. Gone are the days when we could ignore an entrant that was radically different. Nowadays, we either evolve or we get left behind. And we learned that the hard way when UAS technologies and an entirely new industry sprung up practically overnight, and we weren't ready for it. Sorry. Well, we're sort of caught up now, but we're also determined not to let it happen again. And that's why we're out in front with Uber Air Mobility, or UAM, working with the industry and with NASA to make sure we get it right. Time is short. Companies are already testing a variety of vehicles, both in the US and abroad, and some already with passengers. And these two movements, UAS and UAM, really bring into focus how fast everything is changing now compared to earlier in my aviation career. You know, it doesn't seem possible that when I started flying C-141s as a pilot in the Air Force only 30 some odd years ago, and yes, I realize that 30 years is an eternity, and for some of the folks as I look out here, longer than they've been alive. But when I started flying, we had a dedicated navigator who would look through a small portal in the top of the flight deck with a sextant. Yes, a sextant. Sextant is essentially the same thing Magellan used hundreds of years ago to look at the stars to get a position fix on the high seas. Well, we got rid of the navigator and his medieval sextant in the 1980s when we ushered in the age of inertial navigation. And soon after, computers and advanced systems design made flight engineers obsolete, leaving us in the flight deck with a pilot and a co-pilot. The pace of change picked up in the late 90s with the introduction of GPS, which greatly simplified navigation. And when GPS was combined with sensor and actuator miniaturization, more computer power and lithium batteries, the unmanned aircraft revolution kicked into high gear. And then some very bright minds saw too many people sitting in traffic and thought, you know, we can take all this technology and create a better way to move around cities, UAM. And look what you in this industry collectively have conceived and are currently working on. These are truly some of the most exciting innovations and developments in aerospace since the Wright brothers. And it's all taken place over the course of really a very few short years. Everyone is riveted by this, especially me. But then I put on my FAA regulator hat, and I got a whole new bucket of stuff to lose sleep over. You see, what you see as the ideal way to transporting people across cities, when I look at it, I see car-sized vehicles with multiple rotors hanging over dense urban populations. And that's the challenge, taking an industry of incredibly bright minds and fast-moving technology and joining that with a regulatory agency that wants innovation, but only if it can be safely brought into an urban environment. It's why we have come up with the crawl, walk, run analogy. As I said earlier, the FAA can no longer just say no to a new entrant. We are evolving, and quite rapidly for us, into a more responsive regulator, I hope. And just like with technology, the pace of our evolution is accelerating. And back in the 80s, when I was first in the business, it was not unusual for the FAA to take 5 or 6 years to write a rule. Some are saying, well, that hasn't changed. Do you have the patience for that? And it's also normal or fine to take 10 or 12 years to develop and certify a new aircraft type, clean sheet. Do you have the patience for that? As you know, today with the tech eruption that is coming to the aviation world, product cycles can be measured in months. And we don't have the luxury of so much time anymore, but we have to ensure that safety is paramount. That cannot change. So how do we do that? We become a data-driven oversight organization that prioritizes safety above all else. To do safety right, you have to start with a safety culture. A good safety culture produces the data you need to figure out what's really happening. If we know about errors, we can fix the processes that lead to those errors. A safety culture demands that we infuse that safety data into all of our processes, top to bottom, in a continuous loop. When you think about how far aviation has come in a little more than a century, it's hard to argue the point. We've come from barnstorming to a safety record that is the envy of all modes of transportation. We evolve in our rulemaking by transitioning from prescriptive to performance-based rules. A few years ago, industry helped us modernize Part 23 airworthiness. Those are standards for how we certify small aircraft. Performance-based rules will ultimately form the backbone for how UAM vehicles will be built. For new entrants, we started with our legacy regulatory framework, but have evolved to an operations-first approach, where we use existing rules where we can and derive new rules where we need. And as usual, safety is the primary concern. Integrating UAS into the National Airspace System is a good example. Our process is simple. Get the data to assess our risks, and then create useful regulations, policies, and guidance where needed. As a point of reference for how fast this industry is moving, The FAA has been registering manned aircraft for 92 years. And after only 4 years of registering drones, we now have 4 times as many drones as we have in all the rest of legacy aircraft. The UAS integration program, through a variety of demonstrations, is helping us capture data. It's also paying dividends on the investment side. Recently, the FAA granted the first air carrier certification to Wing Aviation, a commercial drone operator. Wing is doing beyond visual line of sight package deliveries in rural Blacksburg, Virginia, using existing rules. What happens next is that we gradually implement new rules to expand when and how those operators can conduct their business safely and securely. Now, we've just closed the public comment period for proposed new rules that would allow small UAS to operate over people and at night. On the horizon are the rules for beyond visual line of sight operations, which, as we all know, is the holy grail of UAS rules. So to manage the traffic, we're working with NASA and industry on a highly automated UAS traffic management, or UTM, system. And even though we're in the crawling phase of our crawl, walk, run path to full integration, we're seeing positive impacts. Small drones are already changing the landscape of our community and economy and society. And here are a few examples. In San Diego, the Chula Vista Police Department and CAPE, a private UAS teleoperations company, are using drones as first responders to provide aerial views for officers to document accident or crime scenes and search for missing persons. Since October, they have launched drone first responders on more than 500 calls, in which 67 arrests were made. And for half of those calls, the drone was first on the scene, with an average on-scene response rate of 96 seconds. Equally important is that 75 times out of that, a surface policeman wasn't needed at all. Just think about the safety ramifications of that. In Kansas, the State Department of Transportation showed us how to use drones for power line inspections and precise agriculture. And the Choctaw Nation of Oklahoma is using drones to bait feral hog traps. Yes, that is a feral hog trap. In North Carolina, drones delivered blood samples to a lab for testing. Drones delivered automated external defibrillators in Reno, Nevada, and inspected airport ramps and perimeter fencing in Memphis. Now, I have a strong hunch that the benefits we discover with urban air mobility will be no less extraordinary. NASA will again be our partner in this area with their UAM Grand Challenge that's planned for next year. The Grand Challenge is about bringing the best and brightest minds from government and industry together to begin live testing of carefully designed scenarios to show how a variety of vehicles and airspace management systems will or won't work together. And most importantly, bringing them together to gather data. That's crawling. We're not ready to walk or run yet. Walking and running will require that these highly automated or autonomous vehicles and systems meet the FAA's and the public's safety expectations for aviation. And as we've discussed, those expectations are very high. Now, the FAA, understand your desire to sprint out of the starting gate, but you have to understand our safety mandate. Let's begin this integration by working with industry to start crawling with low-risk operations in remote areas, gathering data, and evaluating safety all the while. When we're ready, we'll systematically graduate to high-density urban areas with semi-autonomous operations, which will be the walking phase. And eventually, the system will mature to fully autonomous operations in busy urban airspace, and we'll be running. And that's where, given the level of safety that we have in the National Airspace System, that's where we cannot fail. Achieving this final state for a radically different new entrant will be an evolutionary process, and it won't occur overnight, but it also won't take as long as it used to with yesterday's FAA. So here's my challenge to you today. Shoot for the stars. The commercial aviation safety record. In the past 10 years, there have been more than 90 million commercial flights in the NAS, carrying more than 7 billion people with one fatality. That's a safety record that's hard to get your mind around in any human endeavor, much less one where you're carrying humans in a highly advanced aerospace vehicles at 500 miles per hour, 7 miles above the earth. You are working to become part of an elite club, commercial aviation. Work hard. To be part of the safest mode of transportation on the planet, your operation must become synonymous with safety. That's the only way to fully exploit the energy and creativity of this exciting new innovation and this amazing new industry. So thank you all very much.
Please welcome Eric Allison, head of Uber Elevate.
I needed that.
That was fantastic. It's such a privilege to be able to talk with you after such an inspiring talk, and that fits so well with the vision that we're talking about all day for these 2 days. Mm-hmm. And the way you ended this is perfect because it fits right into my first question. So when we talk about shooting for the moon, with the safety record of civil aviation, passenger aviation in the U.S., what are some of the things in your mind that have most stood out along that journey that's gone over the last 100 years from barnstormers and early mail carriers to where we are now, that have really been, and it's many, many things, but are there things that have stood out as like differentiators, especially over the last 10, 20 years, that have made a big difference?
Yeah, I mean, there are a number of milestones over the, since the Wright brothers that have led to the safety record we have today. Obviously, the introduction of jet engines, a much more reliable form of propulsion, the creation of the regulatory agencies dedicated to commercial and to civil aviation, of course. But I think, to me, because it happened during my career, the single biggest change, and we were talking about this earlier, is the point at which we went from a forensic safety agency or industry, where literally an accident would have to happen for us to then go in and see, well, what went wrong, and then fix what went wrong, to a data analytics. So rather than looking backward on safety and fixing safety from looking at what happened, we're gathering data now in amounts that it's inconceivable to me. We're filtering it, we're analyzing it, and we're finding trends that we then proactively correct before the next accident happens. And of course, that's the only way you can get to a point where you're 10 years in that much activity without an accident. And the reason we can do that in aviation, in commercial aviation, is because we literally do not compete on safety. No airline competes on safety. You'll never see an ad of an airline say, come fly us, we have better seatbelts, or we have, a better safety process, because it's not true. And we allow people in our industry to report when they make a mistake without fear of getting in trouble or losing their license. And only through that collection of data are we able to make the changes that makes the system safer.
And the specific mechanisms that we use now to do that are the Commercial Aviation Safety Team, CAST, and the ASIAS,
Yes,
the
sir.
Aviation Safety Information Analysis.
I
don't remember the last one.
I just say ASIAS.
But anonymized data sharing between the actors in the system. So as this industry is just being born essentially, and as we're looking to create the safety culture at the very beginning, that will lay the groundwork for what we want to build, which is exactly what you said at the end of your remarks. What are things in your mind that we can do now as we're starting to build not just vehicles, not just infrastructure, but a system that we want to grow into this vision that we all have?
So I think one of the things we should all do is focus on what we call the 3 A's, right? The airspace, the aircraft, and the airmen. Because those 3 areas each have their own unique challenges to tackle. And it doesn't matter what's being brought into the system. And the airman doesn't have to be in the vehicle, right? The airman, in the case of drones, can be the operator from any point. But it all boils down to proper certification of the vehicle, proper training and qualifications for the operator or the airman, and then controlling the airspace in a way that, quite simply, keeps one vehicle from hitting another. And I see Jay in the front row. I'm so glad that he's at NASA and he's doing the air breathing stuff in NASA, because he's a great leader and he's a great partner, as NASA is with us, on the UTM side of things.
So on UTM, or I guess related to UTM, Uber is actually participating in the IPP as well on the San Diego team, working on drone delivery. Hear about more about that tomorrow at 9 a.m. Everyone knows. But I've been personally, and our team has been collectively incredibly impressed with the way we've been able to work together with the FAA under that program. And when it was first announced, we weren't quite sure, to be completely honest, what to think. But it's exceeded, I think, our wildest expectations in terms of a collaborative approach. And as I'm thinking about this, I'm wondering, what lessons has the FAA taken from the IPP, and how could they be applied down the road to the emerging UAM industry, maybe not in exactly the same way, but in perhaps kind of more of a high-level principle way to help accelerate things and get industry connected more closely with the regulators?
So the integration, the pilot program, the UAS pilot program that you referenced and that I showed a couple of examples in the slides, that's been extremely helpful for us in understanding the best way forward. And there's several questions that we have to answer. We have to answer, what parts of user restrictions or use restrictions can we leave to the local? What parts of use restrictions belong to the locality, and which parts of UTM and UAS operations belong to the federal side, to FAA? So we're learning there. We're also learning that through collaboration with industry, that we can start attacking the 3 A's with the regulations we have. We already have Part 135 applications. Wing did it. There's others pending. We welcome more. There are Part 23 and Part 21 certification applications on the table. And we think that we can learn through the pilot programs and through the applications that we get from different participants and through data collection. Data collection is the biggest part of moving forward. We are an industry that works on 10 to the minus 7, 10 to the minus 8. You don't get to those numbers without collecting a whole lot of data. So that's what the test, the 7 test sites are all about. That's what the IPP is all about. That's what the FAA and NASA collaboration on UTM is all about, is gathering data.
Has there been anything that's come out of the IPP that's particularly surprised you, or that is notable in terms of a learning?
I don't think I can narrow it down to just one. I think that the one thing in going over, as you know, you probably know, we had 150, I think, 150 different applications that were winnowed down to 9 or 10. And what the biggest learning for me was the amazing entrepreneurial and technological creativity for the application of drones, things that I never would have. I mean, of course, I figured they would bait feral hog traps. I mean,
Obviously, yeah. Yes.
I mean,
I do that every day.
That was a no-brainer. But some of the other stuff that they've come out with has been.
So I think that one of the things that's been remarkable to us is, and I've talked with other people involved in the IPP, is how when the dialogue really gets going in a high bandwidth way with the regulators, that there's learning that can happen in a bidirectional way that really can change the perspective in a very positive. Like the things that maybe the industry person thought everyone cared about were not the things, and it may have taken many months of back and forth, but because of the tight coupling and communication under the IPP, the learnings happen much faster, and it's been very impressive to see.
Yeah, I think one of the biggest lessons for us is that the technology is moving so fast. There's no other way to go forward than to do it in a performance-based regulatory. So to tell industry, this is the bar you need to reach. Now go do it, and then you come back to us with how you're doing it, and that works a lot better. Plus, what I've found fascinating in watching like the Drone Advisory Committee and other venues is so many players in this space are not coming from aviation. So at first we thought, wow, this is going to be a real problem, but in reality, when you give a technical hurdle, a technical problem to somebody that isn't constrained and hemmed in by decades of legacy aviation thinking, sometimes you get a very creative solution. There's some acoustic stuff that's happening with acoustic detection stuff that some drone operators are playing with that we probably would never have come up with ourselves. So I think that partnership, that collaboration is very important.
As you think about, you mentioned that learning that we can use existing rules and regulations to enable the things that industry wants to do, but do it in kind of a safe and regulated way. Can you think of, or can you provide maybe a couple of examples of how we can actually enable innovation by using existing regulatory constructs?
Well, I think one example is the 107 regulation about flying drones near or in controlled airspace, and the innovation of LANCE, the low altitude authorization notification. That was a problem that industry saw, created a fairly simple answer to, and we went from taking weeks to get authority to fly a drone in actually B airspace to being able to do it in seconds. I know there's many more solutions that have been driven, but to me that was one of the most amazing responses.
So as we think about the future for the urban air mobility industry, and we look at the way the rulemaking, you mentioned the reorganization of Part 23 and the embrace of standards and basically compliance standards from industry under the consensus standard approach, like ASTM and RTCA and others. Do you think that with that, the FAA has all of the tools needed to certify the pieces necessary for urban air mobility?
Well, I'm not going to say we have all the pieces because you never know as this progresses. That piece that's needed to fill in a gap. We may discover gaps as we go through the certification process, especially in urban air mobility. So I think we have definitely what we need to start this ops learning, this crawl, walk, run. And I know for a crowd for this crowd, the concept crawl, walk, run sounds probably exceedingly slow. But, your children go from crawl, walk, run in a matter of, 3 years. So But I think if we do it, in a methodical way, and we do it in a communicative way, in a collaborative way, and we do it as a multi-agency effort, as we are with NASA, I think any missing piece will be identified early enough to get the answers and to, for the most part, use our current regulatory structure within 107 and beyond. We'll be able to get it done.
Cool. So for additional rulemakings, I think there are a few upcoming ones in the UAS space, not really anything in UAM space right now. But could you tell us a little bit about some of those and what potential implications they may have toward UAM down the line?
Well, certainly remote ID. Remote ID is really the linchpin rule that probably going to be closer to the latter part of the year. Remote ID is sort of the key that's going to unlock beyond visual line of sight and a couple of other things. BVLOS, of course, is, as I said, the holy grail. When you have urban air mobility, you're going to have to, the deconflicting that's going to have to be done, of course, is with legacy, as well as delivery. And I mean, it's kind of where the whole cauldron is going to come together in what UAM's trying to do. But I think the regs we have coming down the pike, we just did over people and at night, and not final, but we got it out there. ID is, as I said, critically, which is going to lead to beyond visual line of sight, and markings and safe small use. All of them will come together to create sort of the platform for ultimately for UAM.
So, with UTM, what is the? So, many companies are working on their own pieces of the UTM system under the general construct that PK and NASA have put out. How does FAA see those pieces coming together? And in terms of the enabling companies like Uber, like Google, like Amazon, to be able to interoperate these UTM systems for the small drones initially, and do it in a safe way that is well regulated but leaves space for innovation on the companies as well.
So what's happening so far in the UTM world fascinates me, and I'm an operator, not an engineer, so I don't really understand I don't understand how my cell phone works, but but it's explained to me as federated, that I can take my cell phone. I'm going to go to Europe next week, and they throw a few switches, and now it's totally compatible with whatever the servers are and whatever is going on in Europe. I can do, and to me, that's what's going to happen with UTM. Is that there's going to be a federated understanding of what all these aircraft are doing. Intent is clearly the most important thing. In fact, there's going to be an exercise done very shortly, the next week or two, out at Blacksburg, where they're going to create all of these different constructs of UAS use in the same geographic area and watch how they deconflict. And I'm really looking forward to that, and PK's nodding his head. Because to me, it's fascinating that they can own their own space, and it can be overlapping, and they still are going to avoid each other. UTM is going to be the linchpin, obviously, to safe ops. It's what's going to bring the three A's together. But don't ask me anything deeper than that, because on the engineering side.
So one last question. We're almost out of time. A little bit of an off-the-wall question. I've thought a lot about what regulatory constructs that we could use in new ways, or perhaps in ways in which they weren't entirely intended. And one of the things that have wondered about is there a use of special use airspace to demo fully cooperative type of future air traffic management systems, for example, maybe under the auspices of a NASA program or another agency, that maybe we could take advantage of that we haven't so far?
Mm-hmm. Depending on where you want that special use airspace to be, it can be very difficult or it can be pretty easy.
Mm-hmm.
And airspace is premium, especially airspace that you want to be completely segregated from any other use to do testing. That's actually not easy. It's not impossible. I think that special use airspace as a common way for anybody who's doing testing and trying things out, again, the more players you have wanting segregated space to do their testing and their practicing, the harder it becomes. So, is that non-committal enough? I mean, I don't. I don't.
Well, I've often thought about how Edwards Air Force Base is this.
Which one?
Edwards Air Force Base,
okay.
Right, which is a restricted airspace that the military has use over. And there's a lot of innovation that can happen up there because they control the airworthiness and they control the airspace and they can test under their own kind of perspective. And I guess my thought was, for some of these things that need to be worked out in a communal way, is there an opportunity to leverage that construct in the future?
And actually, I think that's a great idea. I mean, we at the FAA are looking at ways that we can leverage facilities and test apparatus that we have for more use than just the FAA. And best use of airspace, to your point, is a great idea. And they certainly have a lot of it out there. Less than they did a couple decades ago because of the flight paths. But I think that's a great idea, and I think we would certainly welcome that kind of thinking, and we would facilitate conversations with our partners in DoD, because we're partnering with DoD on everything UAS, primarily counter and detection right now. But I know my friends in the Air Force and at DoD and we talk all the time about how to leverage our assets and our resources to get to get more data and to get more done. So I think that's a great idea.
Well, fantastic. Well, thank you so much for being here today, and enjoy the rest of the day that you can.
Thank you so much. Thank you for having me. I appreciate it.
Thank you so much. Yeah. So I'm excited to announce that up next, you're going to hear from our Chief Legal Officer at Uber, Tony West, and he's going to talk about how we are standing for safety at Uber in everything that we do. So please welcome Tony.
Please welcome Tony West, Chief Legal Officer, Uber.
Eric, thank you very much. Good afternoon. I'm happy to be with you this afternoon to talk a little bit about safety and to kick off what I think will be an incredibly interesting panel. You know, Uber started with a very simple idea. Push a button, get a ride. And over the last decade, we have seen that evolve to moving not just people, but food and goods. In fact, Uber has grown enormously quickly, and it has grown to an enormous scale. Over 16 million trips every single day in over 600 cities worldwide. In fact, we carry more people from point A to point B than all of the commercial airlines combined in a single day. With that kind of scale, of course, comes great possibilities, comes great potential, but also comes important and great responsibility. And we recognize that safety must be at the heart of meeting that responsibility to millions of people who rely on Uber every single day. When he first arrived as our new CEO, Dara Khosrowshahi made do the right thing, period, our North Star. And that meant making safety the core principle and the core idea of how we run our business, and how we measure our success. So we're constantly looking for ways to raise the bar on safety. Let me share a few examples of how we're trying to do that every day. It starts with technology, because we believe that technology can make travel safer than ever before. Features such as continuous checking, which strengthens our background checks by monitoring new criminal offenses through several data sources. If a driver is involved in a new criminal offense, then we immediately receive a notification that allows us to proactively take action to keep our riders safe and to ensure the integrity of our platform. Features like Ride Check, which allows us to harness the power of GPS and telematic info from a driver's phone. That will allow us to detect rare events like a possible crash or a route deviation, and allows us to proactively reach out to both rider and driver to offer assistance. We launched an emergency button in the app that immediately connects riders and drivers to 911. I'm particularly proud of this feature. And in 60 cities across the country, we've worked with local officials to directly integrate with their local 911 systems. That means that vehicle information like location, like make and model, like license information, that is automatically transmitted to 911 with the push of a button. Because we know that in situations that are difficult and dangerous and challenging, saving time can mean saving lives. Now, no doubt that technology will make us safer, and we're seeing that every day at Uber, but we're also investing in partnerships, key partnerships with experts who can help us make our platform safer. We've partnered with third-party organizations all over the world on a whole range of issues, from ending gender-based violence to disaster response to drunk driving prevention. We've built a safety advisory board, which is led by our former U.S. Secretary of Homeland Security, Jay Johnson, to advise us on the development of our company's safety priorities. We've partnered with over 100 women's organizations and advocacy organizations to help improve the platform safety for women, because we believe if we can make our platform safer for women, we can make it safer for everyone. And they have helped to inform the way that we respond to certain safety incidents, as well as informed the way that we deal with safety transparency. Because one key lesson that we have learned over the course of our journey as a company, particularly when it comes to safety, is the importance of being transparent about your safety profile, even when it's difficult. Being transparent with trusted third parties who can help you to improve and can give you the guidance necessary so that you can improve your practices and improve your response, improve your safety profile. In fact, we applied this lesson following the tragic accident in Tempe, Arizona, involving one of our self-driving vehicles, which killed a pedestrian, Ms. Hertzberg, tragically. We decided at that moment to do a top-to-bottom safety review, which is typical. But we decided to do something that was atypical at that moment, which was to make the results of that review public, to be transparent about that, because we knew it was such an important moment, an important safety moment for the AV industry, and that our action would set a precedent for how other companies would deal with similar tragedies. So we tapped former NTSB Chairman Christopher Hart to lead a team to conduct a top-to-bottom safety review and to produce a report not shrouded in attorney-client privilege, but one that we would make public so that we could help to improve the safety profile of the entire industry. Because we believe that safety should not be a proprietary proposition. And as a result of that report, we made some important changes to our organization, as well as ways that we operate our platform. That includes a new internal safety review, safety reporting system that allows us to act more quickly when identifying and resolving safety issues. Now, one of the important features of Chairman Hart's report recommendations is that they drew heavily from the aviation industry's experience. They're rooted in these lessons that were established in the aviation industry, which help to ensure that safety will be as much a part of Elevate's DNA as will be clean next-gen technology or entrepreneurial vision. Because safety at Uber is not just about the cars we have on the ground. And when it comes to Elevate, we have a lot that we can learn from the aviation industry about critical safety processes, about data sharing, about effective collaboration. And that begins by reaching out to some of the best and the brightest from aviation who've helped to build its exceptional safety culture and systems. People like John Ilsen, who we asked to join our team as our new head of aviation safety for Elevate. Now, John has decades of experience in aviation safety, both as a commercial pilot, as well as for 28 years, as well as an airline safety advocate. And in addition to his serving as the chief of operational safety at ICAO, the International Civil Aviation Organization, John led the development of international safety standards, which provide the foundation for regulatory requirements issued by FAA and civil aviation authorities around the world. Now, John and the safety team are in the process of implementing a safety management system, or SMS, for our Uber Copter and our drone delivery products. Now, as many of you know, SMS provides a comprehensive framework to manage operational safety risks that include safety policies, a risk assessment and mitigation set of processes, mechanisms to measure and monitor performance, and safety training and communication to develop and to continually reinforce an effective safety culture. Now, SMS is being implemented throughout aviation and has been a key driver to the industry's safety record. Elevate's SMS will be consistent with internationally recognized standards, practices, and recommended practices, while tailored to our unique operating model. And to help us dig in to what implementing an SMS would look like at Elevate and how safety can be at the core of building urban aerial ride-sharing at scale, we're excited to have a panel of distinguished aviation experts and professionals with diverse backgrounds here to talk with us today. Let's introduce them. We can introduce them anytime.
Please welcome panelists Terry McVinus, Peggy Gilligan, Michael Quiello, Andrew Fly, John Ilsen.
All right. I'll just stand. Don't mind me.
You got no choice.
Or not. All right. No worries. All right. Well, I appreciate, thank you all for making time for this, because there are many things that I know are demands on your times. Why don't we start with talking about these new standards, particularly how new standards can be developed more quickly, more efficiently, to match the pace of urban air and its urban air transport delivery and sort of its development. And maybe Terry, if you could kind of kick us off with some thoughts on that.
Well, I don't know if I have the exact answer on how they can be developed more quickly, but I can say they need to be. We have to figure out a way as we work with industry and some of the new technologies out there in developing standards that we do it in a much more quicker sense than we've done in the past. You know, traditionally we've taken a very consensus-based approach, bring the industry, bring the government together. We find out all of the things that need to go into that standard, and when we're done, we have a really good standard. It's operationalized, it's ready to go, and so that's the good news. The bad news is when you do that long consensus approach, it takes time, and it takes a lot of time, and in industries that are moving very rapidly with new technology, that's just not going to be acceptable in the future. We've got to find a way from product concept to product delivery that we can meet the needs of the industry that we have today, which is moving much more rapidly than ever before.
Right, and maybe Peggy, from a governmental or regulatory perspective, what are your thoughts on how we can move more quickly when it comes to establishing those standards?
Well, I think it has to be a little bit of both. So, as Terry's just described, it needs to move more quickly than traditionally. But we also need to know that the standards, once established, really are going to provide the appropriate level of safety. And I think, as you heard on the panels this morning, there's a tremendous amount of collaboration among industry, regulator, other government agencies, organizations like Terry's taking the lead in bringing those folks together, and FAA finding ways to allow voluntary implementation in advance of finalizing regulations that also allows us as a community to collect more data and make sure the standards really do provide the appropriate level of safety. So I think you're seeing a new model that's coming, really being operationalized in this particular part of the community.
You know, we've seen collaborative safety initiatives such as CAST, you know, and sort of the information sharing. We're talking a little bit about this backstage. They've really proven to yield some very significant safety benefits for the industry. Maybe, Peggy, if you could talk a little bit about how the aviation industry has been able to share information for the benefit of safety, particularly, you know, balancing that with the compliance and the enforcement functions that you have to also meet.
Sure, Tony. I'll give a little history lesson. I think that's part of what this panel's here for, the history of aviation. But so traditionally in aviation, we learned from our mistakes. We learned from accidents. We learned oftentimes from catastrophic accidents. And we had a commitment as an industry to never allow that to happen again. Starting around the mid-1990s, when we started to be able to work together more closely and be able to collect a lot more data about what was happening in the system, we also started to realize we could no longer wait for the catastrophic failure. The public would not accept that, and as an industry, we didn't want that to be our measure. And so we made a commitment to reduce accidents by 80% in 10 years, and we did that by collecting together, coming together, and using our collective data to understand what risks remained in the system and what could we do to eliminate them, mitigate them, or manage them. Well, once you ask your regulated industry to come together and share information, as a regulator, you need to make sure you can protect that you can encourage them to do that and not be putting at risk the certificate they hold that's issued by the FAA. And so FAA and the Congress recognized that we had to be able to provide protection for that shared data so that the industry, both operators, manufacturers, and labor, because at the end of the day, it's a lot of our employees who are telling us what's going on in the system to help us make it better. And by bringing that protection to the community, we kind of created a safe place for everyone to be able to come together, bring their data, and share their experience of what's happening at their airline or at their maintenance facility or at their manufacturing facility, so that as a community we could learn and improve and reduce risk.
Well, and that was certainly the intent by government, by regulators, to create that safe space. Michael, how did it feel on the industry side? Did it create a safe space? And did you feel at the time this this framework was being put together, that it was an opportunity for you all to be able to share information in a way that advanced safety but didn't expose you unnecessarily to any kind of legal or other risk?
I think initially within the organization themselves, even though some of us knew this is where we needed to go, that there was pushback within the organization, both on the industry side and on the FAA side, because the FAA always had the ability to inspect in safety and compliance rather than build it in through a safety program. And so you had to build that trust, and trust isn't something that just happens. Trust is something that it's relationships, it's having open and honest conversations with each other, and it's solving problems mutually to understand what the issues are on one side, what the issues are on the other side, and how do you come to an agreement to say, how do we meet in the middle? And it's a long process. At United Airlines, we have a corporate safety review board with the CEO and all the senior executives. And we talk about safety issues. And we talk about what we're seeing in compliance and non-compliance within the airline industry and within United Airlines. And in that meeting is our certificate manager from United Airlines on the FAA side. And so when the CMO is in the room, that goes to show you what kind of trust we have, because we're putting everything out in the open, and he's in the room listening to everything that we have to say. And it's just that great collaborative type of meeting, if you will. And so that's, and it just didn't happen because it's built on time.
Mm-hmm. You know, part of establishing this culture really is the SMS, is establishing these safety management systems. And maybe, Michael, you can talk a little bit about how SMS implementation has contributed to the airline industry safety record.
So Peggy talked initially about 1998, and if we had the same accident rate today that we had in 1998, we'd lose an airplane every 3 weeks, something like that. And so we had to do something radically different. And what SMS does, it's about gathering data within the airline itself, and sharing that data with our colleagues in the other airlines and putting it all together. But that's empirical data. That's just what the airplane is doing. And then we had to conditionalize that data with air traffic control data. We had to conditionalize that data with meteorological data. And then we had to conditionalize it with the view of the person who was operating the aircraft or somebody who was dispatching the aircraft. Those are our safety action programs. And so what do you want to manage to? Do you want to manage to the fatal accident, the minor traffic accident, the speeding tickets, or the behavior? And so what we've learned in the airline industry is how do we get below and we get out of being reactive and proactive to being predictive? And then putting that risk model on top of that predictive side and understanding what is risk, probability times severity. Probability is a mathematical term. Severity, high probability, high severity is high risk. Low probability, low severity is low risk. And put that risk model on top of the data you're seeing, and all of a sudden you've got this different view of the world. That spill that happens in the terminal that somebody can trip and fall on is high risk. That same spill happening in the corner of the employee parking lot is low risk. And what do you want to manage to? Well, we want to manage to the spill in the terminal. And then when you start looking at things from that perspective, it just changes your view in the world. And SMS has allowed us to do that. It's very data intensive, but it's not just the empirical data. United Airlines has 56 now, 787s, that throw off a half a terabyte of data per flight. When you combine that with the other 750 aircraft that we have, it's a huge amount of data. So how do you use AI, neural patterns, machine learning to ask the right questions of the data, and so we can get more predictive? And that's what SMS is about.
Andy, I see you're shaking your head. You agree that's been your experience?
Yeah, absolutely, yeah. The one thing is to collect the data and have the data within your organization, the airline, or sharing with external suppliers, with other airlines. And I think the airline industry and safety departments are working in a collaborative manner since decades, since 10 or 20 years. And that's the effective part of the SMS overlapping one industry or one airline. I want to pick up one point, which is something very important. It's the proactive part of an SMS. And SMS is, of course, safety, it's in management, and it's a system. You have to have systems. You have to manage the systems, adapt it, evolve it, and you have to measure somehow safety. But I think it's very important to have a proactive way in measuring data, looking forward with your data, with your experience, with the pilot's reports, and so on. So we're working at Lufthansa, we're working to develop our compliant safety management system more into a proactive systems, looking into threats in the future, the risks which arise because the airline industry is changing. We don't have the same industry like 10 years ago. We have more wet lease partners, more external suppliers on ground, and everybody must be incorporated in an SMS system. So basically, the airlines maybe in Europe, I don't know which in the US, in Europe, they have a very flight ops and training focused safety management systems. And the challenge is to deploy that onto a really overarching SMS within your airline and your partners, and even more into a kind of system where ATC, traffic data, other airline data is merging together in order to have a proactive risk management, actually.
John, how can, picking up on Andy's point, how can Elevate contribute to that environment where you're not only sharing data and you're leveraging information, but we're actively contributing to the pool of safety information through SMS?
Yeah, thanks, Tony. That's a great point. So for Elevate, as we implement safety management systems, the data will be different from the traditional airline model. We'll have different types of data sources. But one thing that's constant, and I think just about everybody on the panel has alluded to it, is the value of the reports that come in from operational people who can provide insights. The empirical data tells us what happened, but those reported events tell us why things happen. And so I think we can certainly contribute taking the types of operations that we'll be developing, the different data sources that will be recorded and collected through the safety management system, and how we fuse that with the other types of data that Michael referred to, particularly how we can contribute to methods that better help us engage with the people involved in the operation, and how they help us understand why things are happening in a new and evolving type of technology.
One question I have, what's extraordinary about SMS and about the collaboration and the data sharing is that the premise is that safety should not be a proprietary proposition in the aviation industry. I think it's the only industry where that's true. I can't think of another one where it's like that. And so what that requires is an extraordinary, and Peggy, you touched on this, an extraordinary amount of trust on both sides, right? You have to balance, if you're the regulator, you have to balance the compliance, the enforcement. If you're in the industry, you have to balance the competition and the sharing and the exposure. And I guess the question I have for any of you is, how do you protect that framework from either becoming politicized, or in periods where incidents happening, the pendulum swinging too far one way or the other? How do you protect that trust?
I'll start. I think we've been successful in aviation because we can show the result. Mike referred to it. When we started down this path, we still had very few accidents in this industry, but the number of accidents, given the expected growth, was a level of risk that we knew the public wasn't going to accept. And this industry can't survive unless people buy tickets and get on airplanes and go to Chicago or wherever it is they want to go. So we knew that we had to better understand what those risks were and how we were going to manage them as we started to see this very explosive growth. And so that's when I think those pressures brought together a lot of different things. The government's recognition that this is an industry of compliers. You don't build an airline and go to all the expense of getting that certificate and building that system and that infrastructure to put it at risk. There are very few fly-by-night operators in the aviation industry. There are a couple of bad actors. Most of the folks in this group and in aviation know them by name and we know how to manage that piece. But as an industry, this is a compliant industry, and so if we could find the mechanisms that allowed for us to learn from one another before we had the catastrophic failure and commit to one another to do something about it and hold one another accountable to make sure that got done and that it was effective, well, then as a community, we could address that risk and keep people confident in flying both in the U.S. and around the world. And there's just such, and I think in your industry you'll see the same thing. You have such a common commitment to the business that you want to be in that it's worth your while to find ways to make sure the public understands what you're doing and why it is beneficial to them to support what you want to do.
Terry?
I would just add, when you look back to the 90s when some of these safety programs got started, we started pretty slow. And when it came to the data, and I always like to think of it in terms of information that data is telling you, it started with some trust, and started with just some trust between a few individuals within an organization, very few individuals. Yeah. That then expanded into some trust with other departments within your organization. Eventually it became the whole airline, it became segments of the FAA, and that whole thing of trust grew into really a change in culture of the aviation industry. But it started very small with that trust between just a few individuals. The airline I worked for at the time, U.S. Airways, we had two kinds of safety programs, one that collected the reports from the pilots, and then we had the FOCA data coming off of the airplanes. And we would work within the safety department on some of that, then sharing it with the flight ops department. And then we got to the point, and then we'd include the FAA once in a while too. But then we got to the point where we would start talking with United Airlines, and we would go to Chicago and spend a couple days comparing notes essentially with just one airline. And that's really what grew into a lot bigger data sharing that goes on today. But it really started small with that trust between individuals. And that, because trust takes a while to develop. You don't just flip a switch on and all of a sudden you have trust. You got to earn it. So.
Yeah, and I would add there's no competitive advantage when it comes to safety at the airlines. I can't highlight that enough, that if one airline loses an aircraft, we all lost an aircraft. And the proof is in the pudding. Over 10 years without a fatal hull loss in the United States, over close to 8 billion passengers flown in the United States without a fatality, without a fatal hull loss, that the latest statistics show that it's more dangerous walking down the street as a pedestrian than it is getting on an airline. And that is an amazing, amazing record that I would challenge all of you to replicate in your industry as you're going forward. Because when safety risk goes down, your reputational risk goes down. When safety risk goes up, your reputational risk goes up. And in an industry like you're doing, it's very exciting. I wish I was a part of it. It's almost like the 1960s with the space race. It's really an exciting thing to see from my perspective. But I think you got to protect your reputational risk, and you do that by sharing the data. I can't highlight that enough, because anything that happens inside the walls of United Airlines today happens outside the walls of United Airlines. But if I treat that as a one-off, then I'll solve it as a one-off. If we treat it as an industry, it becomes an industry solution, and you solve it for everybody.
John?
I was just going to say that, building that trust was critical, and it did take time. But even before we got to the point where we were sharing data and sharing information, we were sharing experiences. We were sharing ideas about how each airline was measuring safety. And in some cases, there were some different ideas. And so I think that always helps the industry grow and develop new perspectives and collaborate. So that led, I think, to a greater trust, a greater amount of confidence, and the willingness to go forward with actually beginning to think about how we would share actual data once we got to that stage. A lot of groundwork was laid, and a number of people in this panel were instrumental in doing that, just understanding what the criteria were, what specific safety performance indicators were being used by the different players, and how we could harmonize that and bring it together.
What's your thought sort of on that, and hearkening to the first question I asked about standards and speed? What's your thought, John and Andy, I'd like to hear your thoughts on this too, about how one balances their approach to safety in all of the ways you all have described, data sharing, collaboration, what have you, and innovation?
Well, if you ask me, I think safety drives innovation. And I think the proof has been in the aviation industry throughout the years. We look at a number of technical advances, and without that strong foundation, using the data, and as Michael and Peggy have said, being proactive and being predictive, having that culture has allowed us, or the aviation industry, the traditional aviation industry, to become not only more efficient, but also simultaneously safer at the same time.
Yeah, the other thing.
Oh, I'm sorry, Michael.
Yep.
It actually helps you operationally. We find that the operations that are highly compliant and highly safe are highly effective operationally, and so they're not exclusive. You hear people say, you go into a restaurant, you don't say, do I want it hot, quick, or fast? I want all three, right? And so the same thing in aviation. You can have a highly compliant organization and be highly effective and operationally reliable if you put it all together and you do it properly.
Sorry, Andy?
Yeah, I want to add that safety is a basic for development and for innovation and for the business case. It's not a problem deploying the industry, but it's an enabling the topic. And we're hearing from keynotes, from manuals, everybody's talking about safety first. It's very easy to put it into a manual or into a speech or in any wording, but it's very hard to live it from day to day, from end to end, from the pilots through the other administration persons. So it's really hard to deploy that and to keep the safety really as a key initiative for an airline.
Great. Well, we'll let that be the last word. Thank you very, very much to our panel.
Are we done?
Thank you, Tony, and thank you to all of our panelists for joining us. We're going to go to a quick break. Please be back here by 3:05, and then we'll get started with the remainder of the afternoon. Thanks.
Ladies and gentlemen, the show will start in 10 minutes. Ladies and gentlemen, the show will start in 5 minutes. and gentlemen, the show will start in 2 minutes. Ladies and gentlemen, please silence your cell phones. The show is about to begin. Ladies and gentlemen, please take your seats. The program is about to begin. Please welcome Susan Anderson, General Manager Uber, Australia and New Zealand.
Hello, everybody. My name's Susan Anderson, and I'm the Regional General Manager for Uber in Australia, New Zealand, and North Asia. It's wonderful to be here today at the 2019 Elevate Summit and to have the privilege of announcing the third international pilot for Uber Air. But before I do, I want to tell you a bit about the process that we went through when we were deciding on the third pilot city. As a growing global business, it was really important that the third city was outside the US. So in addition to Dallas, Fort Worth, and Los Angeles, we wanted to look at other great cities from across Europe, South America, Asia, and the Pacific to form a shortlist of exciting options. Since the shortlist cities were announced in 2018, Uber's regional offices and the Uber Air team have had numerous meetings with government officials, industry stakeholders, and aviation regulators from across the different cities. We were looking for a place that has forward-looking regulatory regimes, environments that support innovation, and where a product like Uber Air can have positive impact, improving how people live and work in their cities. And finally, a place like us that is excited about future mobility and that will be with us in this for the long term. So, it's my privilege to be able to announce that the third city, which will test fly Uber Air from 2020, is a city where there's great coffee on every corner. It's a city where a horse race stops the nation, a sporting capital, a cultural epicenter, and consistently voted one of the most livable cities in the world. Of course, I'm talking about Melbourne, Australia. Woo! How good is Melbourne? So, why Australia? Well, let me tell you a bit about Uber's operations and history in Australia, and why we think it's a great market for Uber Air. Since Uber entered Australia in 2012, Australians have embraced the service. We now operate in 37 cities and towns across Australia, and have more than 60,000 driver partners. This reflects the demand from the community for a better way to get around, as well as from people looking for flexible earning opportunities. Around 3.8 million Australians regularly use Uber as a reliable way to get from A to B, and governments across the country have recognized ride-sharing as an important part of the transport mix. But it's not just the rideshare business that Australians have embraced. Uber Eats has had an amazing journey in Australia over the last 3 years. We've grown from our original 100 restaurants in, of course, Melbourne being the first city, to more than 20,000 restaurant partners in 24 cities across Australia and New Zealand. From a brand that didn't exist 3 years ago, now there is brand awareness at 95% of the Australian population. That's the same as McDonald's. Really extraordinary. And we know Australians will respond just as positively when we launch Jump e-bikes and e-scooters later this year. Partnering with governments in Australia has been core to what we've been working on. We partner across significantly parts of the Uber story in Australia, delivering innovative partnerships and solutions, such as on-demand public transport and mobility-as-a-service trials, such as a Ferry Connect trial and late-night journeys to and from the public transport network. And just last month, we announced one of our most innovative government partnerships, a partnership with Tourism and Events Queensland for an on-demand submarine ride through the Great Barrier Reef. That's our scuba product. So what is it about Australians that make us so receptive to innovation and to Uber? Australia's a big country, around the same landmass as the US, and is highly urbanized, with over 2/3 of the population living in a small number of capital cities. And Australia is one of the fastest growing countries in the OECD. In the next 30 years, the population will grow from 25 million to 35 million people, with over 80% of that growth happening in those 5 capital cities. And so, with such large land mass, small populations, Australian cities grew out, not up. And like many American cities, they became dependent on private cars for transport. Even today, only 35% of homes in Sydney and Melbourne are within 400 meters of public transport. The private car remains the dominant form of transport, And in major cities, congestion's a growing problem. It's estimated it's costing Australia around $16.5 billion a year in lost productivity. But it's not just costs. That is, missed bedtimes and actual human time that's spent sat in traffic. And so, Australian cities need transport alternatives that are faster, easier, and cheaper than owning your own car. And governments in Australia are ready for this. They are thinking about innovative ways to solve those problems, in addition to that already impressive investment in existing infrastructure and public transport networks. So Melbourne will be the first city within the Australian market, but we see other cities such as Sydney following soon after. So why Melbourne? I'm going to start by showing you a bit about how people get around the city today. What you can see here is Melbourne broken down over a 24-hour period. We divide the city into 1 kilometre tiles. Red means people are moving into that tile. Blue means they're moving out. And the height of the tile represents the number of trips going to or from that tile. And with this data, we can build intuition about travel patterns in the city. We can identify hotspots in the city that experience the most traffic. These are represented here by the yellow zones, and they show where the traffic can be the worst. We then use these hotspots to serve as a guide to identify possible locations where nodes in the Uber Air network might be. And whilst we would initially start with 2 nodes, as you build them out, you could see the potential of how Uber Air could change the way a city like Melbourne moves. And of course, this is just the beginning of the conversation with communities, governments, and customers as we together start thinking about site selection and where skyports will best fit in individual cities. So what could this mean for the everyday person living in Melbourne and commuting on key routes? Well, firstly, Melbourne Airport to the city. It's 19 kilometres, but given traffic conditions, the time to do that journey can vary from 25 minutes to 55 minutes. In an Uber Air, that journey goes down to 5 minutes, 9 minutes, end to end. Or another great example, Geelong, a city fast growing just south of Melbourne. It's 75 kilometres from the city, and from Melbourne city centre, people commute in weekly or daily, and it can take up to 2 hours. With Uber Air, this would be 14 minutes by air and 18 minutes end to end. So Australia's approach to regulation at every level has been an important part of this decision. Australia was one of the first countries to embrace Uber and regulate ride-sharing. We've had so many positive and forward-looking conversations with Air Services Australia, the Civil Aviation Safety Authority, and the City of Melbourne, all of whom have been extremely progressive in their approach to the future of urban aviation. The Victorian Government has been an extraordinary partner as we've worked together on this project for the past year. The Memorandum of Understanding that Uber and the Victorian Government are entering into today is a testament to this important partnership and the government's approach to the future. This support has been critical to our decision. And in addition to governments and regulators, Australia's business community has been enormously supportive of Uber Air. We have partnerships in place with leading Australian companies to support this launch. We're very excited to announce that Telstra, Australia's leading telecommunications company, as our preferred network infrastructure partner for Uber Air. Our respective teams will now work together to assess what network infrastructure, connectivity requirements, and other capabilities would be needed to support airspace mobility in urban centres. And in addition, we're pleased to announce Scentre Group, who own and operate Westfield centres across Australia, as our preferred infrastructure partner as we identify, develop, and co-locate Uber Air skyports. And we also partner with Macquarie Capital's Green Infrastructure Fund, a division of Australia's largest multinational bank, Macquarie, focused on skyport infrastructure and electrification in Australia and the US. And lastly, Uber Air will continue to work closely with Melbourne Airport, who are here today, and the gateway to Melbourne for tens of millions of travellers each year. and with whom we can see strong potential as the first node and skyport for Uber Air in Australia. This positive environment keeps Australia at the forefront of transport innovation. A future urban aviation network, as we know, we've talked about today, is not something we can build overnight. This announcement today marks the next step in our conversation with Melbourne and Australia about making this vision a reality. Thank you, and please join me in welcoming the Minister representing the Victorian Government, the Honourable Robin Scott, in order to give some words.
Please welcome the Honourable Robin Scott, Minister, Government of Victoria, Australia.
Ah, no mic. Sorry. Oh, sorry? Okay, it's on. Okay, I'll start again. G'day, DC. What an incredibly exciting occasion. It's a great pleasure to be here from Australia on behalf of the Victorian Government. I'm delighted that my home city, Melbourne, has been selected to join Dallas and Los Angeles as the first trial cities for Uber Air. We are so very proud. Thank you. If you have never visited Melbourne before, please do. It's just a 10-minute ride, Uber ride of course, to Reagan Airport, but then a 20-hour flight. Australia is a long way from much of the rest of the world, and Melbourne is right down in the bottom corner. We're a very large country, roughly the same size as the United States, but with less than 10% of the population. As you could imagine, that means there's a lot of space in between everything. A lot of space between businesses, a lot of space between people, and a lot of space between the services that businesses and people need. Historically, this has presented a number of challenges. Whether you're operating a business that needs to move goods across the country, or you're a government that needs to deliver services across a broad area, overcoming the tyranny of distance has always been tricky. It's a challenge that I'm proud to say the Victorian Government has taken up with enthusiasm. There is an unprecedented amount of infrastructure being planned, funded, and delivered. Everywhere you turn in Victoria, there's a transport project underway. In this context, the opportunity to be at the next frontier of transport technology, it's not just exciting, it's absolutely necessary. Victoria has always embraced technology. Melbourne is undoubtedly the #1 tech city in Australia, and I'll repeat that. Melbourne is undoubtedly the #1 tech city in Australia. Thousands of cutting-edge companies have chosen to make Melbourne their Australian home, including Square, Slack, Zendesk, Eventbrite, Splunk, Stripe. They come because Melburnians embrace the potential of technology to improve people's lives. We're home of Australia's top universities and R&D centres. Now again, I'll make that emphasis, the home of the top universities and R&D centres. We have an incredibly talented tech workforce engaged in changing the world. We welcome new ideas and creative thinking to meet future demands. Our economy is very strong. We've had a 27-year period of continuous growth. That's right, 27 years of continuous growth. But the best thing about Melbourne is that we're not just about technology. We're not just about producing bright, young, innovative thinkers. We're not just about building the economy. Melbourne is a cosmopolitan, culturally diverse city. We embrace our people and celebrate their diversity. The Economist, awarded us Most Livable City in the World for 7 years running. Global companies with offices in Melbourne run 24/7. Our time zone means our day starts before most of the world wakes up. Right now it's already Wednesday morning. From the Victorian Government's perspective, the Uber Air partnership announced today is a natural fit. It is an opportunity to keep our state at the leading edge of innovation. Well-planned, forward-looking transport systems have always been an enabler of growth and prosperity. We see the potential of Uber Air to become an integral part of our region's transport system. We look forward to continuing our relationship with Uber and its manufacturing partners. We will help nurture and grow this new industry, which could revolutionise commuter travel. We are here, we are ready, and we cannot wait to make this happen. I would now like to introduce Greg Coleman, Senior Managing Director and Global Head of Energy Technology at Macquarie Group. Thank you very much.
Please welcome Greg Coleman, Senior Managing Director, Macquarie Capital.
Thank you, Mr. Scott. That is really a close-up there, isn't it? It's a request to zoom out next time. Thank you kindly to everyone. Thank you to Eric and team for having us here. It really is a privilege for me to be here today representing Macquarie Capital in the Green Investment Group. We're excited. I think it's fair to say we're super excited about working with the Elevate team and its partners on the development and electrification of this infrastructure. I'd like to. Oh, good. That's better. I'd like to tell you a little bit about Macquarie and our team, and then share the 3 reasons why we're most excited about this partnership. First of all, how many Australians in the room? They're here? Gotcha. Okay. How many folks from Melbourne? Yeah. How many from Sydney? How did that happen? Yeah, well, you can probably discern at this point from my accent that I am not from Australia. I have spent a lot of time in Australia. I spent enough time in Australia to know the unique opportunities and challenges both in energy and in transportation. I've also spent enough time in both Sydney and Melbourne to know that if you're after the very best coffee in Australia, you'll find it in Melbourne. And is that true? It's probably true, right? That might be one of the reasons for the choice. I don't know. The folks from Australia certainly know a bit about Macquarie. Macquarie is the largest owner and operator of infrastructure on the planet. I think right now we're currently at about $391.2 billion of infrastructure under management. We also happen to be the #1 financial advisor to infrastructure projects globally and the #1 financial advisor to public-private partnerships globally. Recently, Macquarie Capital has doubled down on green and sustainability. We acquired the UK's Green Investment Bank in 2017. We've rebranded that the Green Investment Group. We've taken those sustainability and green impact metrics and we use them not only in the UK and in Europe, but wherever we go. that is an asset development and project development shop focused on energy and sustainability. We have something like 90 projects globally now around 12 countries, many of them landmark projects, such as Taiwan's first offshore wind farm. Interestingly, lately in the news as well, we structured the financing around the only behind-the-meter energy storage portfolio that uses non-recourse project debt, which, if you're into project financial, know is an interesting step forward. Maybe a bit about our team and how that leads to why we're so excited about this. So I lead a global team. That team is based in San Francisco with a significant presence in Australia. That team is exclusively focused on new energy and mobility technology. We focus on developing the infrastructure that those technologies require. We also invest in technology companies that ultimately enhance the value of those assets. That's really all we do. And so that dedication of focus inside a group like Macquarie, I think, is unique. Probably relevant to let folks know that I'm not a banker. I've been with Macquarie for about a year now. I was previously with Tesla. At Tesla, I had 2 jobs. I led the development of what has become the world's largest high-powered DC charging network on the planet, the Tesla Supercharger program. Has anybody ever used a Tesla Supercharger? Yeah. My personal phone number is on a forum somewhere, so sometimes when the cable doesn't work, they'll call me now still on my cell phone. Please don't do that. Just call the regular number. I was also responsible for the build-out of our energy storage business. That is, batteries out of cars, all the way from the big 100-megawatt battery in South Australia. Some folks might have caught that on Twitter. To distributed energy storage systems. This is relevant because oftentimes you want to put energy storage behind the meter where you have very peaky loads like charging stations. I think we built the first battery-backed charging station in California in 2012. So it's not just me. There's a team of people with that sort of DNA focused on this effort inside of the largest infrastructure player on the planet with deep roots in Australia. Why are we so excited about this? There are 3 things that really come together that have us pumped up. One is that if you kind of think about the cost down chart and think about the meaning of what an infrastructure asset is, we have to work. We're excited to work with Elevate and its partners to get access to the lowest cost of capital so that this can really look like infrastructure. That's super important. And Macquarie just has a long heritage in working with its partners and communities to do this. Starting close to the community, figuring out a way to help them drive down the cost of capital so that you can get access to the safe, reliable infrastructure. So that's really core. The second reason we're super excited is because this is about electrification of transportation. And the electrification is the operative word there. Has anybody ever been responsible for really any part of a vehicle electrification program where you had to worry about utilization rates? Yeah, there's a few people. Was that easy? I don't know. I don't think, if you thought it was really easy, then we invite you to come work more closely with us. It's complicated. We're excited about it because it's complicated. The value inherent in electrifying transportation is about increasing utilization rates. However, if you want to increase the utilization rate of a new technology, that means you're co-optimizing across more and more factors. You're co-optimizing across thermal management of a battery system, across routing optimization schedules, against what the utility tariff looks like, what's happening in the real-time energy market or ancillary markets when you get into the detail. The more you want to increase utilization, the more that complexity comes on board. You're also doing that, as we can tell, in an environment where it's a relatively high upfront capital cost that you're dealing with both the vehicle and the charging infrastructure relative to other conveyances. There is emerging a new technology and shifting regulations and standards. That's not easy. That's super complicated. We've built a team that's dedicated to working on that problem. We see a tremendous amount of complementarity in the intellectual capital and DNA between our teams and the Uber Elevate team and its other partners, and we're really excited about that collaboration and partnership. Third, and I think this is really, really important as well, this is about green. This is about making this sustainable. We're really keen to make sure that the electrons that go into the Uber Air conveyances, the EV tolls, the air taxis, that those electrons are as green as possible. We ourselves are a developer of renewable energy projects. We have a trading desk that can firm and shape renewable energy. We're happy to work with other developers that develop projects that can deliver renewable energy. That's a key focus for us as well, because what you can, at scale, the really wild thing that you can start to envision here is that you have a network of skyports where they can actually serve as a balancing mechanism for the grid, a renewable generation falling mechanism for the grid, actually enable more renewable energy to come onto the grid, actually help balance the grid with dynamic charging or bidirectional use in off hours. And what that could do, and it has done in South Australia, is reduce the cost of power for everybody, for businesses and homes on that grid. That's pretty wild to think that a skyport in your state could lower the cost of power for everyone. So that's how we're approaching this. That's why we're so excited. It's about infrastructure, low cost of capital. It's about solving the complexity of electrification and pumping up utilization, and about making sure that those electrons are not only green, but maybe going even further and turning these into real assets on the grid. I think there's more to talk about. There's a panel tomorrow. Really looking forward to everybody's questions. Close by saying that we're super keen to work with Uber Elevate, the state of Victoria, Center Group, Telstra, and all the other partners. And also really excited to be here and thankful for this group of folks, and look forward to talking with everyone in the room. With that, it is my great privilege to introduce a video message from the Deputy Prime Minister of Australia, the Honourable Michael McCormack.
Well, as a kid, I used to watch the Jetsons on TV, and I used to marvel at how these little gyro aeroplanes used to fly around the sky. Well, the past is now the future. The future is now here, and Uber Air is launching in Australia. This is exciting. This is technology for today, but for the future. So good luck with Uber Air. Good luck to what they're trying to achieve, because it is the future. It's going to be a brave new world we are now venturing in, and I acknowledge and I encourage and I recognise the great establishment of this Uber Air initiative and wish it every success in the future.
So excited about Australia taking this next step with the Uber Elevate team. So innovative and such forward-thinking vision for our country. I'm super proud to be part of that. And now I'm going to hand over to Susan Hendrick, who's going to take us through the next panel. Thanks.
Please welcome moderator Suzanne Hendrick, Federal Communications Lead, Uber, and panelists Chris Monahan, Rajiv Agarwal, Francois Sillon, Andre Stein, and Takanori Ito.
Well, hi everyone. Welcome to the Urban Aviation Worldwide panel. My name is Susan Hendrick, and I am the head of Federal Communications for Uber, based here in Washington, D.C. Over the past year, Uber has begun to share our vision for urban aviation at scale with regulators, policymakers, and industry champions from around the world. During this panel, we'll get to hear directly from aerial ride-sharing advocates from Australia, Brazil, France, India, and Japan as they discuss their views on the future of aviation and steps that they are taking to ensure that they are prepared as we all work to embrace the future of urban aviation. Thank you to this amazing panel for being here today and traveling from all over the globe and representing your countries. And before we dive in, I'm going to ask the panelists to introduce themselves and their organization, and we'll get started with Chris.
Sure, I'm Chris Monahan. I'm the Executive Manager for National Operations and Standards at CASA, which is the equivalent of the FAA in Australia. It's pretty much the place that covers regulatory policy as well as for UAM, but also for drones and also rocketry as space. So it all kind of falls in the same space.
Hi, good afternoon. I'm Rajiv Agarwal. I'm the Joint Secretary in the Government of India, Department for Promotion of Industry and Internal Trade. And as a department, we look after all the foreign direct investment issues, industrial licensing, and promotion of industry across the board.
Yes, I'm Francois Sillon. I've been a researcher for 20 years, working in computer graphics, computer vision, artificial intelligence. And more recently, I was an executive in a public research institution. And I head the newly established Advanced Technologies Center for Uber in Paris.
Good afternoon, everybody. Well, first of all, it's a pleasure to be here. It's also a pleasure to learn and to share a bit about our vision about the future of urban air mobility. So thanks so much for the invitation. I'm Stein. I'm the head of strategy for Embraer. Embraer itself is quite well known in the aerospace world. We are celebrating 50 years of existence this year. We have delivered and served more than 80,000 airplanes based out of Brazil. But Embraer X, it is kind of new. The X stands for exponential. And that's what we were created for, to find and build opportunities that could become exponential, transform the lives of millions of people. And for that, the collaboration with Uber, it's a good step. And urban air mobility is exactly the case, where you see this potential exponential growth.
Hi, I'm Takanori Ito from Ministry of Economy, Trade and Industry in Japan. We have two ministries in Japan. One is METI, Ministry of Economy, Trade and Industry, and this ministry is supporting the aerial industry and collaborating with the universities or local government and private companies to support this industry. And one more is MRIT, Ministry of Land Infrastructure and Transport. And this is the regulator. I'm from Ministry of Economy and supporting this industry.
Great. Well, thank you all again for being here today. And we clearly have a diverse group of folks. Let's dive right in, and I'll open this question up to all of our panelists. Can you explain how your country has embraced the future of urban aviation, whether it's through drones or enabling regulations and infrastructure for aerial ride sharing? Francois, we'll start with you.
Yeah, well, first of all, I'm myself fairly new in the world of aviation, but it's interesting that I've known for a long time that France was very active in drones, for instance, and the French Aviation Authority actually establishing a national council for civil drones back in 2014. So I think it was at the time fairly new. So there's a strong appetite for all sorts of applications, mostly doing with surveillance, monitoring of installations and things like that. And more recently, also urban air mobility. And this is maybe taking place a little bit at the European level, where, for instance, EASA has issued a special condition on VTOLs recently, and I think it was the first at the global scale. So it's only a first step, of course. It's a modest step, but it shows that there's really a strong appetite in France and Europe for air mobility.
Great. Open it up.
I'll step in now. The kind of opportunities and avenues that urban aviation offers, and for a country like India and for cities of million-plus population and the kind of densities that these cities have, the potential is huge. A city like Bengaluru, which, from the electronic city to the airport, a normal car ride would take 2 hours when you're lucky, and if you're not lucky, it can go up to 4 hours. And the same ride can be covered in just 15 minutes by the chopper services that are right now being provided. So it just speaks of the kind of opportunities that are there in the country. That's only one part where you have the heli taxis and other chopper services which are available for city travel. The second is obviously drones. So India did come out with its own regulations last year, and even as those are being put into place and being implemented, we are already looking more towards the future, going beyond 400 feet, looking at beyond the line of sight drone operations, also night operations. So the potential is there, and there is a recognition, and there is a need to do something urgently.
Well, Australia is, first off, very pleased and welcomes the announcement from Uber Elevate, as Melbourne is the partner city. Australia has been trying to work very early on for regulations from the regulator that had a framework to go into place, but that continues to evolve. But over the last several years, that evolution is going to happen a lot faster. With the advent of this selection, it demonstrates that not only innovative, but that Australia is ready for the innovation, and it will also have both the economic and the regulatory aspect, working with our partners in NASA and the FAA and other like-minded regulators. So we're looking to progress as well with them.
Stein.
I think even before talking about urban aviation, it's interesting to note how we have embraced new ways of urban mobility. São Paulo, for example, has become Uber's single largest market. On top of that, it's one of the largest, if not the largest, helicopter fleet in the world. So there are some air mobility there in some shape or form, not to the scale or to the affordability you'd like to see, but there is already something there. Beyond that, we've embraced the whole concept. We've embraced not only the operation, but you are developing the vehicle, you are developing aircraft solutions of support and service, you are developing solutions for air traffic management. We have embraced the collaboration with Uber, so we are right there on the way.
Yeah, as for Japan, we think in Japan, a big market. There's a big market. For example, we have Tokyo and Osaka. Around Tokyo, about 40 million people is living there, and they are suffering from the overcrowded, congestion. So we realize there is a market and potential, but we also need to set up a regulation and new rules for there. So we established last year the public-private conference, and then we took place 4 times, and then we published the roadmap for this industry. And it says in 2023 that is the target year to start business of the eVTOL. So yeah, we start discussing of making new rules in Japan.
Great. And so this next question is for Rajiv and Stein. How do you see the prospect of aerial ride sharing benefiting India and Brazil? And what do you believe to be the greatest challenge to this new mode of transportation?
The problem is definitely there. Every year, about $70 billion are spent or wasted in traffic jams around Brazil, so it's clearly a problem. And it's not only São Paulo, it's the largest city. When you think about Rio, normally the image that comes to mind is the statue with open arms on top of a mountain. Mm-hmm. That's a mountain chain right in the middle of the city. That doesn't help the traffic. And the average person, seriously, and the average person in Rio spends about a week stuck in the traffic jam. So there's definitely a problem there. we don't believe that urban air mobility by itself will solve the problem. There's no silver bullet. There's not one solution that will solve it. But it's part of a bigger puzzle. And even if you don't use every day, even if you don't fly every day to work, that gives you a choice. That gives a chance. Maybe someday you have a meeting in the two parts of the city. Maybe you need to catch a flight. Maybe you want to be home for your kid's birthday. And urban air mobility gives you that. Gives you the chance to be there. So right there, that's a great benefit. There's more to it. And there are a lot of challenges that you need to overcome. Not only the vehicle, there's a lot of technologies that need to be developed. Battery normally is the thing that you're thinking about the most. But it goes beyond that. The infrastructure itself, it's quite an issue. The good thing is where there is an issue, there is opportunity as well. Thinking about, I mentioned São Paulo having one of the largest helicopter fleets in the world. But you cannot really have more than 6 flying at the same time around downtown. Conventional air traffic management doesn't work for more than that. So there are infrastructure that needs to be built, and there's definitely opportunity there. And we truly believers that is through finding the pain points and solving them together, you're going to get there.
Likewise, India has, in both ways, ride sharing first. So Delhi, a recent study showed that from speeds of around 40 kilometers an hour, the average speed has come down to 22 and will drop down further to maybe 5 kilometers an hour because of the traffic and private vehicles with hardly any occupancy plying on the roads. So ride sharing is there to stay. And if we were to go by a report by Morgan Stanley, we should be seeing almost 30% of rides being through ride sharing by 2030 and going up to maybe 50% in the next 2 or 3 decades. So that is the future, and that is recognized. And that's why it is coming in more and more, not only in terms of surface transport, and now the next thing is the aerial transport. I did give you an example of Bangalore. So that's already changing the way people are looking at traffic and looking at traveling across these cities. There are challenges, infrastructure, having the right heliports, for instance. So those are challenges which have to be met. We have to look at heliports as being different from the normal airports. How do we manage the ATC? How do we manage the fly zones? So those are challenges which have come up and which are being recognized and are now being addressed.
Great. And so this next question is for Ito and Francois. How can companies like Uber work with governments to ensure community acceptance?
Yeah, guaranteeing safety is the most important, but moreover, I think the collaborating with the national government and both local government is also important, I think, because the local government can persuade the key players in that region, such as the interested group or the politicians. And if we want to start the demo flight or test flight, we need to search a good space, good place to start. But if we want to do so, we have to collaborate with local government. So in that means, I think the collaborating with local government is very important.
Well, it's similar in France, and of course there are several levels of government, at least 3 layers, sometimes 4, depending on the location. So it's important to actually engage with all these levels of government, and they're concerned with slightly different topics. But in general, what I find is that there's really a need to present very openly all of the issues, and especially as you talk to the local level. It's been mentioned several times this morning about public acceptance, and noise in particular is an area where it's actually difficult now because the vehicles are not yet flying, so it's difficult to show exactly what it will look like. But it's very important to be open about this, to really explain what it's going to look and sound like. And in fact, since I'm heading a research lab, we are developing a research project so that we can maybe simulate and show what it's going to be like so that we can gather some public support.
Mm-hmm. And so another question for you, and also to Stein. Uber predicts that their operations will eventually be numbered in the thousands per day. This ultimately means a massive influx of new, highly skilled and highly paying jobs. How can we work together to ensure we're planting the seeds now for the future?
It started already, co-creating the ecosystem. And there's an interesting story about Embraer. Embraer decided to, or was created, to start building airplanes in Brazil half a century ago, at a time where bicycles were not made in Brazil. That did sound crazy, right? But our first airplane became the backbone of regional aviation, not only in Brazil, but even here in the US. And that generated the need for a lot of high-skilled aerospace jobs in the region. So there is some tracking on that. There's some history on that. That does work. And now we have a new frontier ahead of us. And incidentally, we are based in a region it's a valley as well. It's not the Silicon Valley, but it's the Paraíba Valley. And that's fastly becoming the new Silicon Valley of Brazil in a way. And we really have open arms for everyone. And that's an invitation for everyone that want to come in and join us to help to create the ecosystem. Because not only the vehicles, the whole supply chain behind it, like happened with the Embraer throughout these 50 years, but the ecosystem, the traffic management, the infrastructure, the charging, all that's going to happen, and that needs the high skill, not only aerospace, but all sort of different professionals to make that happen.
Yeah, it's actually a very good question, especially in France, an old country with a lot of tradition and a very high quality of life, where people tend to be a little bit wary and suspicious of disruptions, big changes, and things like that. It's actually very interesting that since in the last few years, there's been really a tendency to confront the disruptions of artificial intelligence, new technologies, and things like that, and try to see them as opportunities to develop new types of jobs. Whereas maybe 10 years ago, everyone was so tense about jobs disappearing. So I think Uber is in a really good position to explain that we're going to open, as you said, a whole new ecosystem, and we're going to need pilots, for instance, at least for a fair number of years. But not only pilots, there will need to be training for these pilots. There will need to be all sorts of operational jobs. And also, because I mentioned artificial intelligence, also some, again, research and development. If we want to have very safe, everyone is insisting on safety, the safety culture, all of the optimization and the connection between the various layers of these multimodal systems will require some guarantees, some certifications, and for that we also need to invest in research and development. So all this together, I think we have a convincing case to present to say that we're not just changing things and making them scary, but we're actually offering a lot of new opportunities.
Yeah.
So just like to add something. So while there would be high-end jobs and we would be moving up the value chain, and that's something which, frankly, the people are ready to embrace. But how do we connect it with the common man? And just give one pointer from our regulations. So to be a pilot, a remote pilot to operate drones, all you need is a high school degree, class 10, so basically normal school in English, that's it. Mm-hmm. And then you can undergo the training and thereafter become a remote pilot for drones. So can we find a way in which we can take people with normal educational background, skill them, and then take them into the fold, so that it's not an us versus them kind of divide. We can all be on a common page, and that's the secret, to get people on board, to make them see this as something which is for them, for their future, and not something which is against them and only for a certain elite.
Mm-hmm. And Chris, I'll kick this next question to you. How is Australia working with other countries interested in urban aviation to harmonize with regulations or policies as needed?
Obviously a great question. It's a balancing act with any regulator to balance creating regulation that's proportional to risk. And learning from other countries, harmonizing, which you've heard that in the FAA administrator mentioned it earlier, and it's completely appropriate, is finding that. But also we're working quite a bit with the FAA, we're working with NASA as well to have an understanding for the UTM. One of the other challenges that we're working with other regulators is when you get out of the kind of the smaller drone aspect, which is fairly finite inside one regulation, now the UAM will now start to intersect Part 135, which was mentioned earlier. Having that intersect now with the drone and how to integrate those two regulations is different because those two communities have always been somewhat separated. So creating those regulations to create a framework that enables people to work now and into the future is going to be the challenge. So working with like-minded regulators, people solving the same problems. And it's also equally important, which is great with this sector, because this sector is creating a lot of data. And that's what we need to help make good data-driven decisions. And so we don't over-regulate something. And that's just as key to us as important as not to do that. So good information enables us to make good decisions and not over-regulate. So I'd encourage people to continue to do that data-driven, because that drives not only this sector, but all the sectors as we write.
And so this next question I'll open up to everyone. Understanding existing transportation options in your respective countries, how do you see aerial ride sharing complementing other modes of transportation? Do you believe this will improve congestion? I know we had some traffic issues with some of our panelists even today. So maybe Rajiv, I'll start with you, since I know you hit some of that famous DC traffic on your way here.
So I had planned that I would be here from my hotel in 5 minutes. It took me over 20. So it definitely makes a case for aerial ride sharing. I mean, obviously, it's something we have to look at. When we, even for surface transport, we had roads, and then we started constructing flyovers, and then the next layer, and then the next layer, then we came up with the mass rapid transports, and those also, we ultimately went vertical. So similarly, aerial ride sharing is only an extension of what we have already been doing in terms of road transport. And this is something where we see a huge potential. I mean, I remember a story of seeing it in the news yesterday. So some blood sample collected up in the hills in some primary health center. And through a drone, they brought it to the main hospital, a distance of around 35 kilometers. What would have taken over 2 or 3 hours, a few minutes. So it's not only in terms of passengers, but also in terms of goods, in terms of essential services. The potential is huge. And this is what we need to capture and see how we can link it to the common lives. And for a country as complex and as populated as India, it's definitely the way the future is unfolding for us.
Francois?
Well, I see a huge potential because in France and in Europe in general, there's been a lot of investment in infrastructures such as railways, for instance, that are really good, but they're connecting cities basically just, in one dimension. And so it's difficult. If you're going from one city to the other and there is a railway line, this is wonderful. But if not, it can be actually very difficult. And so if I combine this with the fact that in general, generally speaking in Europe, cities tend to be maybe a little denser, but you have usually clusters or constellations of smaller cities, a few tens of thousands of inhabitants, within a range of 40, 50 miles. I think there's a huge potential if you take the Paris region, for instance, to connect these cities basically in a fully connected network. And this is something you cannot invest in the rail infrastructure, for example. I guess the government is investing in what they call the Greater Paris Rail, but it just, it's basically beating all of the forecasts in terms of budgets and things like that. So it's just unmanageable. Air transport will be a real solution for that.
Maybe Stein?
When internet came into existence, it kind of changed the way you think and the way you interact with the world. People got used of content, data, going from A to B in a very seamless way, very integrated way. A lot of technology behind it, 5G, satellites, fiber optics. But for the user, who is expecting the data, the content, it's basically going from A to B in a very integrated way. The way I see the future is try to bring that to the physical world. Think of it of a network of transportation or of an internet of mobility, if you might. And that's, I think, the direction we need to go. Urban aviation, by itself, it's not the silver bullet. It won't solve traffic jams. It's the integration of the different opportunities, different modes of transportation. It's being able to fly in the vertiport to the airport, integrate with the airplane, in the other end, integrate with the scooter, and for the user being a very seamless integrated solution. It's that type of more holistic approach that might solve it. It's not getting better, and there's so much you can do with physical infrastructure, so it goes beyond that. Aviation has done great things to change the way how people move. To cross this country, back in the days, it would take generations. I mean, you're a kid, you're going to get to the other side. With aviation, you can cross in a few hours. You can go all the way to Brazil in a few hours, and then get to São Paulo a few more hours just to get the next 10 miles. So there is a pain point there in urban mobility. Air, adding another dimension to it, definitely helps. But what's really going to help, what's really going to create a new way of mobility, it's this integration, is these different transportation modes. You might get the train one day, you might get the scooter and a eVTOL another day. And having that choices, that's what matters.
Ito?
Yeah, Japan has good transportation system and infrastructure for mainly train and buses or cars. But especially Tokyo, we still have the congestion. And in morning, the average congestion rate is more than 150%. So it's very overcrowded. So we have many modes of transportation now, but still we have congestion. So the new mode of transportation is, I think, big potential. Yeah. And one more thing, we have the many train station, and major train station has the good building to set the heliport. So maybe by utilizing such kind of the building, we can set the heliport kind of maybe intense, yeah. So in that way, we can move by eVTOL or some other air mobility from the station building to station building, right? Yeah.
I think you'll find that this model will fit in very well in Australia because of the high density cities, but they're separated by a long distance between them. So as those cities grow and become a lot more dense, the ability to dovetail into the existing transportation system, maybe not as robust as Japan, but will then be able to fit right in very nicely, and the model sits over a 20 to 40 kilometer stretch. So I think you'll find it fits very well.
Great, great. And so I'll also open this last question up to all of our panelists. What do you believe is the biggest potential roadblock to the full-scale launch of urban air mobility and aerial ride-sharing services? Maybe Ito, I'll start with you down there.
Okay. Maybe social acceptance is the biggest bottleneck, potential bottleneck, I think. If the full-scale Uber Air service is starting, maybe we need more and more heliport in cities. Maybe we need maybe 10 or more than 10 heliports we need. So if we need more heliport, we need more consensus of the residents and people. So maybe it is the biggest bottleneck, I think.
Francois?
Well, actually, I see two. You're asking for the main one, but I see two. One of them is to, in fact, I was struck this morning by the alignment of regulators and authorities, like Secretary Chow or the FAA administrator. They both said that, of course, no one's going to compromise on safety, but they want to see innovation and they want to see this happen, or they realize that it has to happen. And also on the industry side, there was this panel with the people from Wing and Amazon and Uber, and the industry coming together to realize that before they can even compete on the market has to exist, and so they have to align forces to make this happen. I think these are the two things that are not quite happening this way right now in France and Europe, and hopefully it will happen in the next few weeks or months. But that's really what I see as the main roadblock.
Stein?
Well, I mentioned infrastructure being one of the major roadblocks. It needs to be great for this to really to escalate. It doesn't need to change a lot for it to start, but it needs to change for it to escalate. Social aspects are important. People not often are willing to accept this coming to town. So all of us working together to create that social acceptance and really promoting it as something that will make people's life better, not only the ones that are actually flying, but the rest of the community around it. So questions like noise, questions of like safety, making sure we have the community embracing that as a good thing. That's going to give more choices in terms of mobility. That's going to create economical growth. We mentioned that earlier in the panel. And we don't do innovation by yourself. So it's really about collaboration. It's really about all of us collaborating, competitors, other players, other parts of the ecosystem, collaborating to make sure that happens. Because I'm truly passionate about mobility. And I truly believe that's for the good. Mobility is something that makes the world a better place. And that's the message I think we need to bring to the community to create social acceptance.
So, yes, I would agree with that. Social acceptability is going to be an issue, given the fact that you're going to be flying over densely crowded areas, populated areas, and even slight cutting of corners could have catastrophic impact. So that's one area we'll have to be very careful about. But there's another issue in terms of urban agglomerates, and that's most of these cities would have a lot of no-fly zones. There would be, critical infrastructure. There would be military defense installations, etc. So, how to navigate around these areas? Because it's not going to be easy flying over these areas, and they will always remain no-fly zones. So, one will have to find ways of tackling, these roadblocks in the air itself, and that's going to be an interesting way to see how we're going to navigate from that.
I view it through a regulator lens, so a little bit different. I think that several of the concerns have been highlighted here today about a type certification, what differences will be, licensing and training. While those are not to be dismissed and there's work to be done, this innovative group of people are going to solve that. They're going to find a way to drive through that. As a regulator, one of the underpinning tenets we have is for airspace is equitable use of the airspace. This is going to vastly expand the number of people, but also the freedom of motion. Right now, aircraft can move in fairly defined patterns. You can move in 360 degrees from your operation. So being able to make it available for as many users as we can in a reliable and safe way is going to be an ongoing challenge, because that's just going to build. But one of the other things that as a regular public has an expectation that somebody's going to make sure it stays safe. The manned aviation world over the last 50 years has got a fairly robust system. They've got a lot of data, and they've got a lot of understanding of where those adjustments need to be made. This is the Wild Wild West. This is brand new, and that's why getting as much data as we can now to have an understanding of how that integration happens, because at some point those two communities are going to come in contact with one another, figuratively and literally, and we need to figure out how to ensure that they go forward together, and then that the public, once the public starts to accept that it is as safe as currently manned aviation, then you'll see those real advantages start to come. Until then, it'll be a little difficulty for us to get across new regulation because they're not convinced. And we do have to satisfy the public as well. So.
Yep, Uber can relate to all of that. Well, and with that, we are out of time. Thank you all for being here today and for traveling from so far and for sharing your insights. We are very excited about the prospect of Uber Air in all 5 of these countries. Stay tuned, more to come. And thank you all for being here.
Thank you.
Thank you.
Please welcome Mark Moore, Director of Engineering, Vehicle Systems, Uber Elevate.
Hey there. Don't be tired on me. We're just getting into the fun stuff. So, my passion at least, I'm thrilled to introduce this session on eVTOL aircraft. And right up from the beginning, I want to make sure it's clear what Uber's objective here is. We want to make many manufacturers successful in developing new products for urban air mobility. So we're working to become an Amazon-like platform that can bring all the best vehicles onto the network to serve our customers. So since we're not designing and developing a vehicle ourselves, but simply trying to accelerate our partners and help them get to the best vehicle, in these past 2.5 years, we've been able to focus on the design of the network and develop the vehicle requirements that can help these vehicles to be as successful as possible. So we want to provide as much guidance as possible to our manufacturer partners so that they can be designing those vehicles that live in the network and are doing the best possible job. So we've released our Uber Air vehicle requirements, and we've invested a lot of time and money on this Flux simulation tool, which lets us model every single concept out there and see how well it does on the network. But we're at a really cool stage where it's not about design and analysis anymore. It's about validating that analysis and getting to hardware. So you'll notice we already had the announcement that this year, in fact next month, we're going to start some of that validation with hardware. And so we're starting the Uber Copter effort, which proves out the ability to do this multimodal stitching of ground and air trips together. But 2020 is when the real fun begins, right, for all you vehicle fans, where we actually start testing these brand new aircraft, and we prove to the world just how safe, just how quiet, and just how great of performing vehicles they are. So by getting to those 3 hurdles, then we can make the commitments to our manufacturers that gives them the ability to go through the certification, and in 2023, give us the first handful of certified products. So 2023, we will introduce Uber Air service in our early adopter cities. So just a few cities and just a few aircraft in the beginning. But as you look at the next 5 years, that's where we prove out all the assumptions, all the analysis, when we actually start to optimize the network, how these vehicles behave in the network, and prove to everyone that this can be and will be a scaled mass transportation market. And with that confidence, then, there's going to be even more investment. And with that further investment, we're expecting some additional technologies to help us out. So by 2028 to 2030, somewhere in there, we believe that's when autonomy will be ready to be certified. We'll have somewhere on the order of the first 50 to 75 million trips completed, with the autonomy in the background and the pilot in command of the vehicle. And that will give a statistical basis for the FAA to approve autonomous flight, free up that one more seat, which gets us to an even better revenue stream with these vehicles, and really get to that scale with autonomous vehicles. In addition, we're excited about a couple other technologies that we expect in that time frame, as this second generation of eVTOL aircraft will be enabled through lean design principles in the manufacturing, and especially some really important manufacturing technologies such as thermoplastics that can lead to mass production of these vehicles, not in the hundreds of units like in the first years, but in the tens of thousands of vehicles. We also are hoping and will push for, through our awesome battery team led by Selena, for lithium metal to be able to be safe, proven safe, as the next generation of batteries that can give us lighter aircraft and more range. So we've got an exciting few years ahead of us. This is really a time of opportunity, right? If you look at this wheel of opportunity that I call it, you see that there's just so much design freedom that has opened up because of this new technology set called distributed electric propulsion. That's near to dear to my heart, as I was working at NASA for a decade to bring about this new technology. And you look at it and it's just so obvious that this is a Wright brothers era again, right? Because everybody's trying different things and nobody's quite sure of what the best answer is. And I will give you that, right? There's a lot of uncertainty. Not only are these new technologies and brand new concepts and vehicle aircraft that have never been flown before, but this is also a brand new market, right? So you have this combination of uncertainties from the technology to the vehicle to the market. That's a lot of uncertainty. But I can tell you, there is a lot we know. And the network simulation tool that we've developed really helps to decrease some of that uncertainty. So I want to walk through some of the design space and some of these concepts to tell you some things that we're really quite certain about in this wheel of opportunity. So it's only natural that, you know, when new things come about, new technologies, people start with what's simple. And that's what multicopters are, right? They're the simplest incarnation of eVTOL aircraft, where you've just got 4, 6, 8, maybe 16 or 24 different rotors that are lifting the vehicle. But that's all they're using for flight. So even in cruise, they're using these multitude of rotors to push themselves forward. And unfortunately, that's really high drag. So it results in inefficient aircraft that can't go very far, very short ranges, and they're loud because even as they start to go forward, then if they have a fixed pitch blade, they have to actually spin it even faster. So the application for these multicopters, well, first they make a great test bed to prove out the technology. So in fact, you see one of our partners, Boeing, with their CAV vehicle, having it be a test bed to establish a knowledge of all these great new technologies and potentially using it for very short-range cargo applications. But multicopters really don't have the characteristics that we want for compelling transportation, which wants to be faster, wants to be high productivity. So let me show you walk you through the design space a little bit, where you can see a bunch of vehicles that we've analyzed. None of these are partner concepts. We don't show partner information. But you can see where multicopters show up, where the bottom axis is lift-to-drag ratio, which is a proxy for cruise efficiency. The top is disk loading, which is a proxy for hover efficiency. The place where you want to be is really in that lower right-hand corner, because that's where the lightest aircraft are. That's where they'll be most cost-effective. And you can see that helicopters, electric helicopters and electric multicopters are nowhere close to that lower right-hand corner. In fact, they're infeasible. They don't even close. Then if you look at something like the slowed rotor compound aircraft, one of our partners, Jaunt, is doing this. You can see that it moves into the feasibility region where those are contours of constant gross weight for the vehicle. And then vectored thrust solutions. So we have partners such as Bell and Carum developing vectored thrust concepts, which are even more a broader area of feasibility. And then lift plus cruise concepts, which are a little bit further away and so that they're higher gross weights. So these are essentially the different types, buckets of eVTOL aircraft. And one I'm going to point out. So I've got permission to point out where one of our partners is. So Carum is way down on that lower right-hand corner at a really impressive gross weight. In fact, as you go from 2021, as you go forward in battery technologies to 2021, you can see that the weights even get better. Go to 2023 and they're even better. But so we're not going to talk about electric multicopters or helicopters. And I'm going to move on to the next simplest incarnation, which add a wing to it. So that gives you this nice L over D so that your cruise thrust can come way down by a factor of that L over D ratio. So now I'm going to show you a different part of the design space. And this is looking at performance, which which is L over D, the lift to drag ratio times the cruise speed, versus the complexity and the criticality of the design. So really what you want to do is, again, drive to the lower right-hand corner where you have the least complexity, least criticality, but the highest performance. So you want to get down to the right. But it's not just about complexity. Really, the magic of eVTOL aircraft is about getting rid of the criticality. That's why helicopters are way over on the left, up high, because they have lots of component criticality, which makes them expensive, very high maintenance cost. So it's an interesting thing because a lot of people say, oh, well, complexity is bad. Actually, what's cool about eVTOL aircraft is that a lot of the complexity goes into the software, which is expensive the first time you develop it, but then has a low recurrence. So for high production volume aircraft, you really don't mind the complexity so much, but you don't want the criticality of components. You want that redundancy. So a lot of the multi-copter companies are saying, hey, simplicity equals safety. That's why we're doing it. Actually, I'm going to say that is a myth. That is not true. If it were true, we'd all be flying around in Piper Cubs instead of commercial airliners, right? Because the 1938, Piper Cub is about the simplest aircraft that ever existed. But what's the safest aircraft that ever existed? Commercial airliners. Not just the safest aircraft, they're the safest way to travel in the world, and no vehicle comes close to that safety record. So goodness is reducing criticality. And the truth is, what you want is to be able to achieve redundancy and reliability in these highly reliable electric components, get rid of the criticality, and that's what equals this ultra-high safety that we're shooting for. So really want to get down into that goodness of the design space where the vehicles are lighter and more effective. How do we do that for something like lift plus cruise, which are draggier vehicles? Well, Pipistrel is going to show you their incredible way of getting their lift plus cruise concept into a really clean configuration. And we want to enable all partners to be able to get to better vehicles. So we're freely sharing the research that we're doing in stacked co-rotating propellers, which has performance, acoustic, and configuration benefits by stowing, very simply, these lift propellers and getting them out of the way. And this is really an opportunity to enable this class of vehicle to be very competitive in that lower right-hand corner. We're thrilled that we're not doing this alone, but as we develop design and analysis tools, the University of Texas is providing validation data. The Army is also using their tools and expertise to be able to prove out this technology, and in parallel, Launch Point is proving the ability to have precise tracking of the azimuth of multiple motors and multiple propellers, so those propellers can work in harmony together. We're at the point where all the pieces, individual elements are proven, and now we're ready to integrate it all into a total eVTOL thruster. That's our next step. So in conclusion, I just want to say that, hey, it's all about having great design principles and great requirements to have success. So as we implement safety and the redundancy of eVTOL and recognize that the door that opens this market is achieving a dramatic improvement in noise compared to helicopters, we've got to take that really seriously as we develop these aircraft. Tech readiness, that's all about understanding what batteries can do in the near term. No magic batteries. So that's key. Selena is going to do a whole workshop tomorrow on that. Tomorrow we have a vehicle track that's going to go into depth on that, and we're going to show cycle data specifically relating to eVTOL aircraft. Productivity, we are convinced you've got to keep the speed high. These are aerospace products. They're going to be expensive. They need to be productive. They need speed. especially when the compelling thing we're offering is value of time. So we've got to be able to achieve that. All of this has to come together at a reasonable competitive cost, and that all equals Uber Air eVTOL and what we're pushing industry to be able to achieve. So I'm thrilled that the next step is you actually get to hear the progress from our partners, starting with Embraer, Bell, Boeing, Pipistrel, Carum, and then Eric is going to do a fireside chat with our newest partner, Jaunt. Thanks very much. This is going to be an exciting hour as we see and hear what all of our partners are doing. Thank you.
Please welcome Michael Thacker, Executive Vice President for Technology and Innovation, Bell.
So it's great to be together again at Uber Elevate. I'm excited to speak about the progress Bell has made in urban mobility since we gathered last in California. I would say as a community, we have come a long way since our initial session in our backyard in Dallas 2 years ago. We've made great progress on our combined objective to enable cleaner, more connected, more livable cities by alleviating ground congestion with air mobility systems. On the regulatory front, EASA has proposed a special condition VTOL to help expedite the certification of eVTOL aircraft. The FAA is making progress understanding operational requirements through the various UAS integrated pilot program projects and through their partnerships with projects like the NASA SIO. And NASA is beginning to make strides on the UAS traffic management system to develop airspace integration requirements for safe, efficient, low-altitude operations. Many others in this audience and across the globe are working to move on-demand air mobility forward. Together, we're at the cusp of a tremendous change in our transportation system, but we must continue to work together to create this shared vision of the future. The same opportunities that we discussed at this forum 2 years ago still hold true. The urban population growth trend continues and may even be accelerating. And communities are paying the price, both in economic losses and in reduced quality of life. Societally, physical mobility limitations can impact social mobility as well. Developing solutions is critical for our combined future, and in most locations, there is no ground-based solution that is as scalable, quiet, clean, or as fast as urban air transport. In January, Bell revealed a part of our vision of the solution, a next-generation aircraft, the Bell Nexus. You may have seen it out in the Woodrow Wilson courtyard. This hybrid electric aircraft has 6 tilting ducted fans as the primary source of power and lift with a wing to get that efficiency that Mark was talking about a minute ago. It will take off vertically like a helicopter, then quickly transition to forward flight to get into that efficient mode of flight and minimize the energy drain on the batteries. This gives the Nexus the speed and the efficiency of a traditional airplane with the agility of a rotorcraft. It seats 4 passengers plus an operator with ample room for bags. Why an operator or a pilot? For passenger comfort and for initial operational approval, we think commercial operations will start with a qualified operator or pilot. As comfort level increases, and we have sufficient data to satisfy ourselves and the regulatory authorities that we're ready to go, we see a transition to fully autonomous flight. We will get there. And ultimately, Bell believes a fully electric autonomous aircraft is the way forward. The Bell Nexus is a critical element of the system of solutions needed to improve the mobility and livability of our cities. We started the Nexus with safety in mind. It has to be a system that will meet or exceed the safety expectations of our existing aviation system, something we would feel comfortable letting our own families ride. This system includes not only the aircraft, but the pilots, the maintainers, the infrastructure, and of course, the concept of operations within which these elements perform. We know the Nexus is an amazing aircraft, and we continue to make rapid progress in its development. But we also know it's just one part of the equation to make this vision a reality. Bell has established 4 frameworks to ensure successful development of the entire air mobility system: operational, regulatory, manufacturing, and technology. Implementation and execution will require collaboration across industry, regulatory agencies, communities, and other interested parties. We can't have operations of an aircraft without public support and a regulatory environment that enables it. The Bell approach is to work with regulators and communities now to establish a safe, holistic approach that doesn't overburden any one aspect of the system. This holistic approach is critical to ensure a consistent and appropriate set of requirements across the vehicle, operations, and air traffic management for aircraft in operations that are different from the historical norms of our existing regulations were designed to support. It is encouraging that EASA, FAA, Transport Canada, and other regulators are already working with industry to understand the needs and define paths forward. While paths exist today to certify an aircraft like the Nexus, we would like to see a more streamlined approach, one that is consistent across all of the aspects of the regulator's oversight, and one that is consistent and harmonized internationally. Along those lines, we are working with NASA, regulators, and other interested stakeholders to develop solution options for fleet and low-altitude traffic management systems. While we have a tremendous existing air traffic system that will work for test and potentially even for low-volume operations, to increase the scale and volume of traffic, new solutions will be required. Ground-based infrastructure, the network of system nodes, charging, and maintenance stations will also be a critical element of the system. This requires determining where to build the vertiports and how to integrate them into a multimodal system to provide a complete passenger and delivery experience. Uber's been talking about that all day. The vertiports will also need to safely manage and support the interaction of vehicles, passengers, and baggage at a very high rate of operations. While the Nexus is designed to be quiet and environmentally friendly, the location and design of the system nodes will also play a role in ensuring that urban air mobility is a good neighbor in our communities. Since communication and automation technologies are important enablers for this system, multi-layered cybersecurity will also be a key element of the system. When we get to the bottom, safety is paramount. It is the key to passenger and regulatory acceptance and to commercial success. It's our obligation to ourselves, our customers, and our communities. At Bell, we are committed to working with an ecosystem of capable partners to develop and build an urban aviation system that is cleaner, quieter, more accessible, and safer than existing transportation options. The Elevate community is a big part of that plan. From booking the flight to air traffic management, the onboard experience to tracking the health of the vehicle to maintenance and digital infrastructure that tie it all together, all of these things are critical to the success of this system. And like the theme of this summit, making UAM real, I think the world is taking notice. It's no longer an if this will happen, but when. I'm glad to be here today, and thank you to Uber for bringing us all together, the best and the brightest helping chart the course of our history. Bell is ready to accept that challenge and is committed to make it happen. Thank you again.
Boeing next.
Great to be here. Thanks for having me. My name's Steve Nordland. I'm from the Boeing Company, and I run Boeing Next. About 3 years ago, the Boeing Company hit its 100-year anniversary as a company. It was a real reflection point for us. Our history has paralleled the history of aviation, but it was also an inflection point, because it gave us the opportunity to start thinking about, looking at, and shaping the next 100 years of aviation, because we truly believe aviation will be used differently in the next 100 years than it was in its first 100 years. However, we'll take all of that learning, experience, knowledge gained, and apply it going forward. But it starts with the problem. What is the problem that we're trying to solve? This might look familiar to some of you. 25% of us spend 90 minutes or more in congested urban traffic. That's 90 minutes of our lives taken away from us, time that could be spent with our family and friends, time that could be spent with customers, business engagements, getting things done, unwinding, going to Little League games or soccer matches. There's a problem, and it's only getting worse. I travel often, and it frustrates me when I'm in a 40-minute flight and then get on the ground in a city like Chicago and have an hour and a half to get to my office in downtown. Or when I travel internationally and go from a city that's a 3.5-hour flight in Europe, and then the airport transfer to the hotel is another 2 hours. As a society, we're fundamentally going the wrong way. We're going backwards, and it has to change. And that's where aviation comes into play. And what it'll give us back is the most important and the most precious asset we all have, which is time. How do we get in a society where we're becoming a much more on-demand information, on demands of us? Our lives are getting faster. How do we protect this most precious asset called time? We have to step back for a moment and look at the environment that surrounds us. We all know about the technology. What the technology has accelerated an exponential growth in the digital world, we believe there's going to be exponential growth in the physical world. And that's where things like urban air mobility come in. That's where the future of mobility and a mobility transformation that will happen around the globe will happen. It's fueled by the technology, whether it's electric, cognitive computing, and then also thinking about the security aspects of cyber and anti-tamper technologies. It's going to be new business models, much like what Uber has launched, where they've looked at it differently. How do we focus on the utilization of the assets? How do we focus on the economics? How do we focus on the convenience and our openness to new business models? If you look at what the World Health Organization says, 80% of us live in pollution that exceeds their standards, their maximums. We have to be the champions for sustainability. We have to look at ways that we innovate around making a contribution back to the earth that we live on. So electric becomes very important to us. And then lastly, we not have to just be thinking about the travelers of today and the transportation of today, but the habits of those of tomorrow. In an on-demand society, I don't know about you, but in my household of teenagers, everything's available. And it's available instantaneously. How do we make transportation more instantaneous to our future travelers? All of this starts to collide and converge. So our approach from Boeing is thinking about the ecosystem that we need to go spur. It's not about the platform. It's not about an individual solution. It's about collaboration and cooperation amongst industry that we go work together and form a successful ecosystem. This is where history starts to repeat itself. In the 1950s, we innovated a wonderful airplane, the 707. It fundamentally transformed transportation, not just here in the US, but around the world. But it wasn't just about the airplane. What happened over time is an ecosystem developed around that airplane and into the jet age and into future jet aircraft. You live this ecosystem a lot when you travel. The airports and the infrastructure that you utilize, the conveniences that have been added to airports, the rental cars, the light rails, the hotels, the connected transport when you get off the aircraft, all the services around us, the maintenance and repair, the ecosystem formed around the platform. And we see that repeating itself as we look to future mobility. And in areas that we're trying to spur in this area are in the areas of flight operations. How do we make sure that safety is not lost? And what we learned in the first 100 years is applied to the next 100 years. In our first 100 years of aviation, the aviation industry did not compete on safety. And that needs to be the rules going forward for the next 100 years. Asset management, airplane management, the management of integration into airspace, the infrastructure, the data connections, the services all around us will need to take shape. We're all on a journey together. And our focus is helping to spur this ecosystem going forward. It's too big for just one company, so it takes collaborations and partnerships, both private and public. We've been talking a lot today about the urban environment, and that is where one of the problems really does exist. But it's not limited to urban. It's regional and it's global. Today, 95% of people who have to fly 500 miles choose to drive. Again, how do we get time back to an asset that they control? We think that technology emerging in the area of electric and hybrid electric can open up and change the economics of regional travel. Today, our studies have shown that 97% of the commercial air traffic here in the United States travels through 3% of the airports. There's infrastructure to be unlocked. There's opportunities to gain. You take the regional travel, connect it to an urban connected transport environment, and it fundamentally changes how we move around this earth. Globally, we're focused on bringing supersonic flight back because time is critical. We've partnered with a company in Reno, Nevada called Aireon, and one of the reasons why we partnered with them is they have an approach to sustainability. We don't want to change the regulatory framework for noise and emission. We want to innovate to meet it, as Secretary Chow talked a lot about this morning. There's an opportunity for us to fundamentally change global travel and get around the world much quicker. Decades from now, we're actually working on the technologies that we believe can bring hypersonic flight forward. With the investments that's going on in space travel and tourism, hypersonic flight one day could be a reality, putting you anywhere in the Earth in 2 to 3 hours. Again, fundamentally changing the way we would travel. So what we're focused at Boeing is how do we make the impossible possible? How do we make it a reality? A couple things that were mentioned today. Our cargo air vehicle that's been in flight test, you see it flying there without the shell on, having good success. Our passenger air vehicle, which we're working on, we're actually working on now and increasing its overall capacity. Hypersonic flights, supersonic flights with Aireon, and then also through our Horizon X Venture Fund, making investments in the capabilities that will help enable the ecosystem. Whether it's Near Earth Autonomy, who's solving the problem around not the last mile of flight, but also the last 50 feet of flight. Or Fordham radars that are working on how do we really integrate at scale autonomous systems into manned airspace. How do we make sure we don't lose any integrity in the airspace that we fly and travel in today? And then companies like Matternet that are focused on logistics in the last mile in a very high-tech and seamless way. And then we also want to be focused on spurring the innovation, not just from companies like the ones that many of us represent in this room, but from individuals around the globe. And that's why we partnered with GoFly, where we sponsored and helped sponsor their competition to bring innovation for personal flight forward. It's these type of things that we think will fundamentally change how we move and travel around the Earth. But the last thing is we can't forget safety. I get asked often, Steve, when will we see this? When will I be able to fly in an air taxi? When will I be able to take a personal air vehicle? When will I get a package delivered to my doorstep? And the answer is, when it's safe. This is the key focus. and making sure that we're all working together, working with the regulators, sharing in our experiences, and bringing together an ecosystem that not only reinforces the advances that technology can gain, the economics that will make it work, but most importantly, bring forward safety that makes the traveling public willing and able to get on to these vehicles and have safe transportation. I want to thank Uber for the opportunity to come out and talk to you all today and really enjoy the show. I hope you enjoy the rest of the afternoon today and the event at the Smithsonian this evening. Thank you.
Please welcome Antonio Campello, President and CEO, Embraer X.
Hello, good afternoon, everybody. I'm proud to announce our newest electric vertical takeoff and land aircraft concept. This is an important point for all of us, and it's important to understand that we are a company that are producing aircraft for the last 50 years. And then we have started doing that back in 1969. And we had a dream at that time. We had a dream of creating the regional aviation. And we ended up being a major player in the executive aviation, commercial aviation, defense and security. And today, we operate in more than 100 countries. It's important to understand that now we are moving to a new frontier in aviation. The electric vertical takeoff and land towards a full autonomous aircraft is something that is very important. And now we're moving to that. And when we talk about that, we're talking about the people that are behind that, the knowledge, the passion, and the motivation of the people that are around it, the celebration of the victories, the journey, and all the safety aspect that we have that, and we dare. We jump into the opportunity. We jump into the challenge. Every 10 seconds, one of our crafts takes off in any part of the world. And this is what we are. We are a company that is very much passionate about that. And we serve the passengers. We serve the people. We serve the people who want to fly, the people who want to make their dreams come true. And this is why we have a variety of aircraft, and we have a vision. We have people that do it for a long time, and we fly above the clouds, and we see what's happening there. And next step, we consider that's creating the ecosystem. Now it's not just about the aircraft. It's about the entire ecosystem. It's an entire ecosystem that has to come alive. And this is what this summit is about, bringing many stakeholders together. And at Embraer X, we decided to have a multi-project approach because we have the right to play in several areas. So we have launched 1 week ago the Flight Plan 2030, which is a path to the future air traffic management, the path to go to autonomous. But it starts today, and we have lots of things to do with the air traffic management. And we launched this white paper together with ATEC, which is our traffic management company of Embraer that has been doing that for decades, and Harris, that's a very well-known CNS company in US, and then we launched that recently. Another important point that we launched a few days ago is a platform, a business-based platform for making maintenance, aircraft service, that we're pretty sure that we're going to change the way we do business in this arena. And this is so important. It's being tested now. It was launched recently with Jet Suite. And then we'll be prepared to urban mobility, where it's very much needed. So the integration of everything is the most difficult part. Designing an aircraft is very difficult. Making the air traffic management is very difficult. And the maintenance as well. However, the integration of all of them is what counts, is what we are here for. And then I'm going to show you the latest product configuration and how it is now. This is a human-centered design. We have been talking, we have heard many people all around. It's not just the passengers, but pilots, mechanics, air traffic controllers, and so on. So we've invested a lot in engineering manpower to come to that conclusion. And there are some very important design drivers that I'd like to highlight here. So by using the knowledge that we have accumulated over the last 50 years, we consider that the smart use of technology is quite important. So in this type of aircraft, the way we design the wing will bring the way we conserve energy when we are cruising with this aircraft. And it's very important to have a reliable solution, because this aircraft will operate all day long, many short trips. Then it shouldn't stop because of mechanisms, complex mechanisms and so on. It must be very much straightforward, simple. And peace of mind. We are in the 5th generation of air traffic, or air flight controls, which is our fly-by-wire. So having a fly-by-wire, very well designed, we are going to have a smooth flight, which is very important for the passengers' comfort. And being 100% electric powered is community friendly. And, we are considering very much people needs. So if you have young guys, elderly guys, if you have people that have special needs, all of them can go into this aircraft, because being designed for all, because we consider that many people will be transported on that. And we are doing a bridge to the future, because it's going to become eventually an autonomous aircraft. It will start autonomous ready, but we know that's going to take many fly hours till it's really accepted as an autonomous aircraft. One important thing is that all these aircraft, they need to go through the certification process. We have been doing that a lot. And we understand that this design is very adequate to go into the certification process and come earlier in the market. So, and we're talking about integration. We're talking about ecosystem. So Uber is doing an excellent job on defining all the ride-sharing platform and everything that is around it, fostering the ecosystem. It's a great job. And we are bringing the aircraft, air traffic management, and also the maintenance together. So it's a matter of collaboration. It's a matter of having everybody in the same page, everybody working together, many companies working together, because it's a new market, it's a new products around. And you need to put safety above everything. Safety comes first. Everything that we do in our life is considering safety coming first. This is our history. And I'd like to invite all of you, because all of you are collaborators of this new ecosystem. You are here because you want to collaborate. We invite you to go into the internet and help us to name your eVTOL, because this is for everybody. Everybody here is going to travel there. So name your eVTOL, and this is what we are launching, a campaign to have the eVTOL named in a while. And, it's not just about having dreams. It's about make them happen. It's very important when we make a dream come true. And this is what we are here for. Thank you so much.
KARAM Aircraft was founded on the idea that aeronautical innovation, following the blueprint of the great designers, can change the way we fly and make the world a more connected place. For the past 2 decades, we've been reinventing VTOL flight with support from private investment and our partners in the U.S. military, using rapid cycles of design, analysis, fabrication, and test, resulting in VTOL technology that's safer, faster, quieter, and more efficient. At the 2018 summit, we introduced Butterfly, our all-electric, emissions-free air taxi. Our technology lets us meet Uber Air's challenging requirements so efficiently we can fly on battery power alone, using batteries available today. Through the Uber Air network, we'll bring you home faster, safer, and more affordably than any other urban transport solution. We want to bring joy back to the experience of flying. We've been hard at work since the last summit, developing Butterfly. And we're not focused on just the first vehicle, but the 100,000th vehicle to make sure that everyone has the opportunity to afford Uber Air. Together with our partners, we're looking forward to making this dream take flight.
Please welcome Ben Tigner, President, KARAM Aircraft.
Thank you. I'm very, very excited to be here today. Thank you for having me. We're very, very proud to be part of this community, and really super grateful to Uber, to everything that they've done to get this space turbocharged, and a lot of exciting things are happening. Many people don't know very much about KARAM Aircraft. People are unfamiliar with the KARAM Aircraft, but as you saw in the video, we are participants in the Army's Future Vertical Lift program, Future Vertical Lift initiative, which aims at replacing all mainstream Army rotorcraft fleets starting before 2030. In particular, it was announced a couple of months ago that we, like our colleagues at Bell and Boeing that you've heard from earlier, were selected to be part of the first such replacement aircraft, something that the Army calls the FARA program, Future Attack and Reconnaissance Aircraft. We're very, very proud to be one of the 5 prime contractors in that operation. In thinking about how our military systems compare to our commercial systems and to Butterfly specifically, it's interesting to note that while the applications are very, very different between those two spheres, the vehicle solutions between those two spheres are very, very different. Even the manifestation of the technology looks quite different. Still, the underlying physics are identical between the two. And the central attributes that make our vehicle solutions very attractive to the military are the very same things that are key enablers of the commercial space. So, for example, there's a central thread that runs through all KARAM aircraft designs, which we strive for a very, very high efficiency. High efficiency in hover, high efficiency in cruise, with no compromise between those two.
And in the military side, what does efficiency mean? Efficiency means that we can fly the aircraft on less power. Less power means smaller engines and less fuel. Smaller engines are cheaper to procure, they're lighter to go on the aircraft, they're simpler to maintain. Efficiency also means the aircraft can fly faster on less power. Faster means that we can give our military customers the ability to be more responsive to events on the battlefield as they're rapidly evolving. So efficiency sounds like this fairly academic, esoteric metric, but in fact it translates very directly into real economic advantage and real operational advantage. Now, likewise on the commercial side with Butterfly, efficiency puts us in a position where we can fly multiple Uber missions on a single battery charge with lots of reserve, lots of margin left over. It also means, and we don't need to rely on any exotic power systems. We're just straight battery power alone. Efficiency also means that we can fly faster, 150 to 200 miles an hour. So we'll get you there sooner, shorter gate-to-gate times, shorter door-to-door times. Everybody likes that. And it turns out that the propulsion system that we've developed that gets you these high efficiencies, also by virtue of its design, turns out to be lighter weight, simpler to implement, and also, very critically, happens to be quieter, which is a key enabler, we all believe, of community acceptance. Now, most importantly, efficiency affects safety. So the high efficiency of our propulsion system allows us to design in large margins that allow normal operations to be further away from the edges of our operating envelope. And what that means is that when we find ourselves in off-nominal operating conditions, we have further to go before we get into a point where the vehicle can no longer perform. So extreme gust, unpredicted gust environments, or unexpected traffic situations, we can deal with more robustly because we have these large margins. Now, I mentioned our participation in the Army's FARA program, and in that program we've built a wonderful team of large, very capable aerospace companies that are working alongside us to help bring our designs to fruition. And that gives us access to resources that we would not ordinarily be able to touch as a small entity. Likewise, on the commercial side with Butterfly, we've been working very hard over the last 12 months to assemble partners that are able to take us, to help us get to certification and production very aggressively. And we're very pleased with the position that we find ourselves in. It turns out that there are some wonderful companies that are, in a sense, you could say, hiding in plain sight, because they are companies that you wouldn't necessarily think of as participants in this space, but whose capabilities are very, very well aligned with this and would like to participate. So we are very excited about events as we expect them to occur over the next 12 months. And we're very happy with where that stands. Now, one final note, you noticed in the video, we had some brief clips of some subscale models flying. We've gotten a lot of mileage out of those models. We've been very pleased with what we've been getting out of those. Those help us understand aspects of control allocations and help us explore aspects of the configuration that give it inherent redundancy between different control effectors. They help us develop elements of the flight control software. And to be sure, those models do not mimic all the features of the full-scale aircraft. Each one is a targeted tool aimed at specific learning tasks, and we've been able to learn an awful lot from those. And to be sure, the subscale models are only a handful of the risk reduction activities that we have underway, so that when we get to the full-scale airplane, we're in a position to have very high confidence that we're going to get exactly what we want. So we're very happy with how that's been coming out. So in closing, I would just like to say that once again that we're very, very grateful to Uber for everything that they've done to make this ecosystem really take off. And we're not just happy about the fact that they are making the ecosystem work. They've also been very, very generous with their time in helping us connect to all across the ecosystem. So we really are very, very grateful to that. I hope you have a wonderful rest of the show. Enjoy the displays. Come visit us at the Caram Aircraft booth. And thank you very much.
Please welcome Dr. Tine Tomazic, CEO and Director of Research and Development, Pipistrel Vertical Solutions.
That's a big photo. Thank you for joining us for a moment that's very important to the history of Pipistrel. We are this year celebrating the 30th anniversary, and part of the celebrations is also unveiling of what we call our Model 801. It's our 5-seat eVTOL air taxi vehicle. But before we come in, let's talk about what we mean by those 5 seats. We all come with some baggage, right? Either emotional or actual. Our vehicle will start off by being piloted, taking 4 paying passengers, and everything they may want to take with them. On a business journey, on a luxury journey, and instead of apologizing for the baggage, we decided to just take it along. And yes, we do know how much a golf bag weighs. This is our 801. It's an aeroplane with vertical lift, vertical takeoff and landing capability. Why do we call it 801? It has 8 lift fans for the takeoff and landing and hover. The 0 stands for nothing tilts. And the 1 is for one dedicated tail-mounted propeller dedicated to support high-speed cruise. The vertical lift system is entirely integrated into the wing. There is a system of doors which open and close in order to enable air to pass through the fence effectively. You can see the vehicle is a high-wing design. That's on purpose. We like people to approach the vehicle in an easy way. Essentially, walk right into the cabin below the wing, even if it's raining. So this vehicle is passenger-centric. But it's not only quiet, it's also very, very fast. So after the transition, and when the doors of the vertical lift system close up, the efficiency becomes the name of the game. And this is what Pipistrel has been known for in our 30 years of dealing with airplane design. In fact, the transition is less than a minute. It's more powerful than a jetliner takeoff, so you are in for a sporty ride. Let me tell you a bit more about the DNA of our vehicle. We want it to be quiet, safe, and fast. The integrated lift system is fully redundant. In fact, the vehicle can fly even with 2 fans not operating. We want our passengers to always reach their destinations no matter what. The next hot topic is the battery safety. Pipistrel has built electric aeroplanes since 12 years. We have always done our batteries in-house. We have seen and experienced what battery safety means. In the 801, we are packing what we call the next level battery safety. Not all batteries are created equal, and here we intentionally create different battery sets to avoid them being affected by a same potential hidden issue. Not only that, the vehicle has 4 battery packs and can achieve a safe landing even with these packs malfunctioning. We also want our passengers to be safe, so we have built in a multi-layer safety principle, from energy-absorbing cabin frames to energy-absorbing seats to specialized seat belts. My colleague was talking about when these airplanes are ready to go, when they are safe. We like to say, when our friends and family would agree to fly on board. This is what we want to achieve. Going on, next generation ideas that we are building into these aeroplanes require next level tools and solutions. So we have actually established in-house tools to help us accelerate the design process of what is really difficult. Transitioning from hover into forward flight is the most difficult part when it comes to VTOL airplanes. You go from something that is essentially standing still to something that flies 200 miles per hour. So apart from the CFD analysis, that is the most usual quick way of analyzing the problematics, we're flying a fleet of scaled vehicles ranging from this small to very big in order to de-risk the challenges we are facing, just like everybody else, with the transition. And it's really exciting to be working on that. Noise. This is something that will make or break eVTOLs when it comes to community acceptance. By having the vertical lift system completely integrated into the wing, we all of a sudden have the opportunity of being able to control the noise aspects much more carefully. Passively, by carefully shaping the fan blades, but also actively. Each of the 8 fans operates at a different frequency, so we are able to disperse the noise spectrum and have a more pleasant acoustic footprint of the vehicle. We're not showing you the hidden sauce there in the right-hand corner, sorry. We're really excited to have these vehicles be deployed overhead cities in Europe and abroad, and we are doing this thanks to some amazing partnership. You have seen the looks, we've talked about the muscles, let's mention the brain as well. The brain comes from Honeywell. Why Honeywell? We are partnering with them in order to have the very first solution of the digital fly-by-wire system and vehicle management certifiable. Not only that, we want to have it prepared for autonomous operations. The seat where the operator will be seated when the vehicle is initially deployed is a first-class seat with the windows ranging all around, so some extra revenue could be pointed into that direction. Honeywell is a leader in innovative, safe products, and together we are working on a simplified vehicle operation principle, which does not require as much pilot training as what this necessitates today. How is it done? With a modular design ranging from navigation solutions to displays to exciting radars, which detect non-cooperative traffic and allow us to land super precisely. All of this is thanks to the new fly-by-wire platform that you can also see outside, right next to our scale model. As said, this is our 801. It's an aeroplane, all battery powered, that has VTOL takeoff and landing capability, flying up to 60 nautical miles away at speeds 175 miles per hour or faster. So this will get you across Los Angeles in 20 minutes. How cool is that? We decided not to show you the actual vehicle today. You know that we never show you everything. But instead, what we'd like to show you is how the vehicle sounds like. What you will hear is a recording of a departure power profile of the vehicle recorded from about 100 feet away from the microphone. Can we please have the recording? You now know it's real, and I hope you are as excited as we are to ride it in the coming years. Thank you very much.
Please welcome Representative Scott Peters of California. United States House of Representatives.
Good afternoon. Did you ever hear we're from the government and we're here to help? I want to thank you for having me here at the Uber Elevate Summit 2019. I was excited about what I saw on the way in. It's pretty amazing, pretty transformative. And I think that innovation is one of the most important ways to address our transportation and infrastructure challenges. Just a little bit about me. I've had the privilege of serving San Diego as an elected official after a career in environmental law. I was elected in 2000 to the San Diego City Council. I became its first city council president. I was also the Port Commission chairman, thought a lot about transportation, how to move things around. You may not know that in 2015, San Diego was named one of the world's smart cities by National Geographic, the only U.S. city to receive that honor. In my town of San Diego, people work collectively to attract innovative businesses, to leverage our elite academic and military institutions, to implement sustainability practices for which we won awards, showcase our cultural diversity, and to create an overall sense of community. So the region is a perfect partner for the things like you like to do, with innovative tech companies, large ones like Qualcomm, which is based there, and new startups. And we are the 8th largest city in the country, a diverse cross-border region with top research universities, high-paying jobs, and we want to attract and retain talent from around the country and around the world. And you should mention that, by the way, we have better housing prices and probably weather than the Bay Area. To some extent, Uber recognized San Diego's importance when it decided to work with local agencies as part of a project for the future of Uber Eats and food delivery with UAVs. So we thank you for that. We're excited about it. Looking forward to working with you and other folks who want to do this kind of innovation. So while it's all good in California, the federal government has to play catch up. And to get even close to the speed at which we need to be functioning, not just to compete with other countries, but to be a good partner with industry to make sure that we can facilitate and not get in the way. I'm a member of the Energy and Commerce Committee. This is my 4th term in Congress. The Energy and Commerce Committee is the one that deals with telecommunications and the digital economy. We're quite challenged to deal with things like data privacy. How do we protect data privacy, usage, and ownership? We need protections that don't hurt innovation, and the government itself, we're not in a place where it's appropriate for us to set those standards. We've got to look to you to help set those standards. We'll provide some enforcement mechanisms because we want to make sure that your bottom line understands the need for compliance. But it would be silly to see us trying to do that without you. When we think about infrastructure investments, the electrical grid, we want to make the electrical grid more reliable, more secure. 5G, public transit. Public transit's not going to be the old model, as you're telling us. And water recycling, these all have the potential to go from archaic to next generation systems with the right foresight and with the right investment. We need to streamline regulations while we keep high standards. And in Congress ourselves, we're trying to catch up with technology. We've got a committee on the modernization of Congress led by my friend from Washington, Derek Kilmer, trying to integrate technology, staff retention, more transparency to our systems. But frankly, we're behind. I don't know if you saw the hearings where we had Mr. Zuckerberg come in and some of my more senior colleagues basically asked him, what's Facebook and how to use the internet. We're not all that way, but we want to learn. But I think we're humble about our own capability, even at our best functioning, to do this up by ourselves. I also want to just mention that we're also looking at the future of work and what the workforce is going to look like. And you're right on the cutting edge of that. The whole issue of employees versus independent contractors, flexible work hours. You had some challenges in the C-suites and in on the roads, but just with basic employee issues. We ask you to be nice to your employees. And in Congress, I think there's a couple areas where we're trying to help accommodate the shifting nature of work so that we move away from the kind of work where you used to just figure you'd sign up with a company and stay there for the rest of your career. First, and I just want to mention a couple things about portable benefits. I root for Obamacare because Obamacare's theory was that for those people who don't get their health care through their employer, that they could have a place to get it. We still need to do more work on that, but the theory matches the future in that the market for health care insurance is separated from your employment. For retirement, I wanted to tell you about a bill I introduced, Saving for the Future Act, that would assure that every American has the ability to save for retirement through a minimum employer contribution of 50 cents an hour. That's $20 a week, about $1,000 a year, but with standard contributions and with reasonable assumptions about returns, that generates over $600,000 saved over a lifetime work. And at a time when I think 70% of families can't come up with $400 to meet an unexpected expense, we think that's pretty important and matches the kind of work that you're all pursuing in Uber. If you offer a traditional retirement plan, you don't have to change anything, and employers at small companies would be able to save through federally provided UP accounts, modeled after the Thrift Savings Plan for federal workers. And independent contractors will be able to participate in the accounts with employers, their workforce being, their employers being required to let them know how to enroll. I think it's a good idea. We're looking for other ways to make sure that we're accommodating your innovation, your workforce. We'll look forward to partnering with you on these issues. Again, we're humble about what we know about this, but we will expect from you that you help us figure out how to make it work. When we talk about flying things across Los Angeles, a lot of us can't imagine that like you can. We're going to need to know how to understand it, make sure that we don't get in the way, but that we make sure that this is the kind of infrastructure investment that will facilitate what our goals are as well, which is to get people around and to encourage commerce and public safety. So our future is full of exciting opportunities. We're looking forward to working with you. Please consider us a partner in this ongoing conversation. Don't underestimate the impact of reaching out to us, letting us know where we're getting in the way, where there's opportunities, where you might be able to use some help. Thank you for including me in this year's event, and we're looking forward to really exciting things ahead. Good luck. Thanks.
All right. So, I'm thrilled that I'm able for the second year in a row to welcome a new vehicle partner to the Uber Elevate network. This partner is developing a very unique all-electric vertical takeoff and landing aircraft that's focused on achieving both low noise and high cruise efficiency in a little bit different way than some of our other partners. And so I'd like to welcome Caden Stanzione and Martin Perea, who is the CEO and CTO, respectively, of Jaunt Air Mobility, onto the stage and introduce their new concept and talk a little bit about what makes it different and exciting for the Uber Elevate network. So, Caden and Martin.
Please welcome Martin Perrier, Chief Technology Officer, and Caden Stanzione, CEO, Jaunt Air Mobility.
So, I thought I'd start out, Caden, by asking you a question. So in a nutshell, can you tell us just who is Jaunt and where have you guys come from?
Well, thank you. First of all, Eric, thank you for being here. We appreciate everything Uber has done, Martin and I, and our whole Jaunt team. Excited to be here. We are a relatively new company. We have been incorporated in April of this past year. However, we're steeped deep in a team that's very experienced in VTOL aircraft development with engineers, scientists, managers, pilots, and financial individuals. And what we have done is we basically have looked at Carter Aviation's success with 3 flight test demonstration aircraft to vet out the technology. So we started off saying, can we meet the technology requirements necessary to execute the Uber urban air mobility mission? That was very important for us. So we needed to make sure that technologically we could meet the safety, the noise, and the mission requirements. So as a company, we first looked at the technology requirement and then also looked at the direct operating cost to make sure that was important. We also added our own technological factors to that, ride comfort, and we also wanted to take a look at, a clear path to certification. So when we did that, we came across the concept that this is very, very feasible. And Martin had been working for a couple of years in refining the slowed rotor compound technology, which was quite different than where we are today with our reduced rotor operating speed aircraft technology. And with that, we made a decision to acquire Carter Aviation, and here we are today.
Right. So Martin, Mark just a few minutes ago told us that helicopters can't do our mission. But this isn't a helicopter, is it? Instead, it seems to be, what I find really interesting and intriguing about the technology that you guys have both acquired and continue to develop is that in a very real way, I think this is an illustration of the power of distributed electric propulsion that opens up new design, new variables, effectively, new degrees of design that you can actually take and do interesting things with that weren't possible, perhaps, with traditional propulsion technology. Do you agree?
Yeah. So I'll comment on that. So, Mark Moore mentioned earlier this afternoon that, the helicopter, really doesn't fulfill the requirements for the Uber mission. And so our aircraft, does have a large main rotor on it. It has a set of wings. And that's about, as close you can get to similarity from a helicopter and an airplane. So we do have a very low disk loading rotor system, which is very, very efficient in hover flight. And as you transition, from hover into cruise flight, the wings pick up the majority of the lift of the aircraft. The rotor is unloaded in flight, and we can reduce the speed of the rotor significantly. So it's a very, very quiet configuration. Very efficient with high lift-to-drag ratios. Another unique attribute of the aircraft, if you notice, there's no tail rotor associated with the aircraft. And the tail rotor is the second largest noise generator on a typical helicopter. And when you size the propulsors or the propellers for cruise flight, you end up with redundancy for any torque in a hovering condition. And so we do have the ability to provide anti-torque with any set of propellers, if you will, in low-speed flight. So we have a level of redundancy in the aircraft itself as a result of that. So this rotor, again, is not typical of a helicopter type of rotor. I know that Uber is very, very concerned about the direct maintenance costs, the DMC. And so the fact that we unload and slow the rotor down in flight, it allows us to look at design options relative to how you control collective and pitch. And so we don't have bearings and pitch links that you find in the typical rotor system. It's a very, very simple, clean design. It's a bearingless design. We're using elastomerics for pitch control.
And that will allow us to, lower the maintenance costs and have very long periods, before inspection requirements. So we're pretty pleased with, with that design attribute. They should lower DMC inspection requirements, similar to a fixed-wing airplane, which is what you're looking for. So, all of these technologies really kind of combine into a very low-noise, high-efficiency aircraft. There's another element, this aircraft offers from a safety perspective. It is capable of, obviously wing flight like an airplane and rotorcraft flight. And so we have the ability to eliminate what they call the dead man's curve, or the HV avoid area in flight manuals. We have an ultra-high energy rotor system that provides, a degree of capability that you don't typically find in a rotorcraft.
Fantastic. So, Caden, it's pretty difficult, even for a large company, to develop a new electric VTOL aircraft. What is your perspective on how a startup like Jaunt is able to do that? How do you have a chance to do this?
Well, actually, we're following Uber's model. The idea is to reduce the risk by bringing in premium partners that will enable us to achieve our goals by following on the RDT&E investments that they have made that get us to where we need to be. So, for example, as we take this multi-pronged risk reduction approach, we couple that with a strong management team and relationships across working with Uber and the Uber design team, which has been absolutely wonderful in helping to really specifically define the requirements so that we don't over-design or under-design. And we've partnered with Honeywell and Triumph. This has become key because what happens is Honeywell has a huge investment in the digital components of the aircraft. So if you look at the aircraft from tip to tail, we really reduced the number of participants, which actually reduces the risk because we have less integration problems. From tip to tail externally on the aircraft, everything that you see structurally is provided by Triumph. That helps us. Triumph has had a large investment in advanced structural materials. They have the design capability. Again, those cost savings get passed down to us. Internally, inside the aircraft, again, from tip to tail, we've selected Honeywell. This is an all-digital aircraft for the most part, from avionics to the flight deck to the flight management computers, fly-by-wire, the electric motors, motor controllers. It's one complete integrated digital aircraft. So when we do this and we take a look at this, we have a much lower risk, compounded because the key technologies in slowing the rotor down has already been achieved. When we originally looked at the aircraft, the technology readiness levels were already high enough that we didn't have to invest a tremendous amount of money. So as we detail our plans right now, we have our work to do. We're actually scheduled to meet with Honeywell, Triumph, and our team and our financial team to work together to come up with a very intricate cost plan, and we're working with Price Systems, that is the honest broker, in helping us understand that we've included all the price elements and that we understand that what we need to do is to make sure that all the components are properly integrated right through the full life cycle. Other than that, where we stand now, we've been fortunate, we're self-funded, we're sufficiently funded to get us to the next level.
Fantastic. So, Martin, you have a pretty impressive prior history. You were at Bell, you led several of their helicopters through certification, kind of a long, illustrious career there. But you certainly know, as a result of that, how difficult it is to certify even a conventional aircraft. One of the reasons we were partly attracted to partnering with Jaunt is because you have a little bit of a different approach to certifications than some of the others in the eVTOL ecosystem. Could you share what your thoughts are on that and what your approach looks like?
Sure. Yes, and we've been thinking a lot about this here recently, and we have engaged the authorities relative to putting that plan in place. It's still obviously a plan in work.
So, if you look at the FARs today, under Section 1.1, under general definitions, you will find the definition of a gyrodyne. And actually, our aircraft fits the definition of a gyrodyne, which happens to be a rotorcraft. A helicopter is actually a rotorcraft, and a gyroplane is a rotorcraft. And of course, we power the rotor full time in flight. And so, rotorcraft are actually certified under Part 27 and Part 29. And so we're going to go down the path of certifying this particular aircraft with Part 29 requirements. We are going to set the bar in terms of certifying this thing as a transport category aircraft. We believe we can get Performance Class 1 from the aircraft because of its unique design features and the redundancy that we have in the electrification. And the fact that our rotor, acts as a spare engine, if you will, upon certain engine failures. So we are going to, set that up with the authorities. What I like about that aspect of it is the fact that the authorities are familiar with the method of compliance. The engineers are familiar with the design requirements for Part 29 aircraft. And we believe that we can get through, certification quicker than, some of the discussions that took place this morning under Part 23, which hasn't really been fully defined yet. We will, handle, the special conditions that are written against the aircraft. The fact that it is a winged aircraft, and there hasn't been a Rotodyne certified in a few decades. And we are going to, obviously use the rigor of, ARP 4751 and 4761. I'm a big, believer that drives your entire design, your configuration of the aircraft, and so that's the plans today. We are going to be building a, full-scale flight demonstrator. We're working on an integrated master schedule right now with Triumph and with Honeywell, and we expect to have that demonstrator flying in the 2022 timeframe. Really, it's a technology demonstrator to demonstrate the performance of the aircraft, both in payload range and the acoustics. We'll use it as a test bed to mature some of the technologies, and then we'll develop, 4 flight test aircraft for the certification program, which we are planning on entering in the 2023 timeframe, and then get through a certification program and try to get the aircraft certified in 2025 with production, following shortly after.
Super interesting. I think that this is a really, like I started with, a fantastic illustration, again, of these additional degrees of freedom that arise when you start to change the propulsion system in an aircraft. And I'm really excited to partner with you guys because you're taking a bit of a different approach to the problem. And we don't know what the right answer is yet. And I'm excited to have partners that are working on this problem from several different perspectives. And I want to have many different vehicles that we can operate on our network in just a few years. So thank you so much for partnering with us, and look forward to be working with you for many years to come.
Yeah,
same here. Thank you
Appreciate
very much.
it. Thank you very much.
Thank you.
Thank you.
Please welcome John Badalamenti, Head of Design, Uber Elevate.
Thank you. Good evening. Customer obsession
is one of the world's most important values at all of the greatest companies that you could name, and is one of the fundamental reasons Uber exists as a company. To ignite opportunity by setting the world in motion, you need a vehicle that is fit to transport you through the challenges of everyday life and not get in the way. But we're not here to talk about cars on the ground. And I'm not here to talk about Hollywood's flying car fantasy either. This image this year turned 60 years old. And retrospectively, it's completely ridiculous. But it's always easier to criticize than to create. So we must remain courageous in our vision to inform future iteration. Aerial ride-sharing calls for an entirely reimagined aircraft experience, and we're at a crucial time in history to define it. How might we design a cabin for a new type of vehicle that feels just as familiar as entering in the back seat of an Uber pool? Customer obsession is not about designing from the outside in, but asking questions from the inside out. It's about starting and ending with the mission, which is all about you, the riders. Millions per day at scale. So if you take the cross-section of a pressurized tube, like we see in most commercial aviation, what advantages can a low-altitude cabin offer? And it's entirely enticing to make it big and take advantage of a more rectilinear profile. But as we know, these lightweight aircraft are extremely weight sensitive, and size equals weight on an exponential scale. So how might we measure small, but feel big? Like you have enough ample personal space, even when traveling with 3 other riders, and ensure that every seat is equally preferable. How might we simplify ground crew operations while saving time for boarding and egress? It's our job as designers and engineers to struggle through these kinds of questions so the customer won't have to, until we're left with thousands of details executed perfectly, turning even the seemingly obvious into the unnoticeable background. Together with Safran Cabin, we've designed for the first time in history a bespoke aircraft cabin that is truly mission-driven for aerial ride-sharing on Uber Air. Starting with the customer experience, it's highly considered from the inside out, yet extensible across various fuselage geometries and carefully engineered with a path to certification. To realize this design physically, combined with our VR flight experience outside, has been extremely encouraging. Today represents a moment in time, but we remain completely consumed with the road ahead and the skies ahead. I think we're at a transitional time in aviation aircraft design history where designs like this will serve as the influential typology to inform future iterations for generations of aircraft design to come. So please join me in welcoming Safran Cabin CEO Norman Jordan to the stage to share this incredibly thoughtful design for you tonight. Norm?
Please welcome Norman Jordan, Chief Executive Officer, Safran Cabin.
Thank you, J-Bad. I appreciate the announcement, introduction. Thank you for welcoming me here today. background on who Safran is. Thank you again for welcoming me. I'm pretty sure you're glad to see me up here because I'm almost the last one of the day. Would like to thank Eric and his entire team for putting on this event, for inviting us, and for making us a valued partner. I'd like to give his whole team a round of applause if we could right now. As we were in discussions about partnering with Uber Elevate to envision this aircraft of the future, we found out very quickly that we were very, very closely aligned as a company, Safran, with Uber Elevate's vision of the future. Clearly looking at greener, more electric, or eventually all electric, and eventually autonomous. So if you look at things that we do in terms of cybersecurity, advanced materials, big data, Internet of Things, artificial intelligence, 3D printing, the cabin, which I'll come to here in a minute, and of course also propulsion. You look at our partnership with Bell on the Nexus. We're working with them as a group, Safran Group, to develop the airplane of the future and the propulsion system for that airplane. But again, we knew from early on that our vision was very close to what Uber Elevate's vision was, that we were closely aligned on taking bold steps to bring this vision into the future, but quickly. So in terms of aligned vision, I'm going to start to get a glance of the cabin. You've seen the mock-up today. Hopefully you were as impressed with it as I was when I first saw it. I give a lot of credit to our team. But we decided to work with Uber, and they selected us ultimately because we were, I think, a logical choice for that. We had the ability to start from a complete blue sky cabin, clean sheet paper approach, working with a company that had a great vision. And we brought our own vision of what it could be in terms of this cabin of the future and this experience to work on creating what we call a mission level value. We weren't working on just designing parts. We were working on designing an experience. We were working on designing this transportation mode of the future and optimizing things like the passenger experience, efficient operations, and optimized vehicle performance. We did that through a collaborative partnership. We started out, you can see the evolution of mock-ups on the screen that we went to. Those are actual physical mock-ups that we worked on. Early engagement, we decided and we committed to, and Uber Elevate committed to, a collaborative partnership. It was great working with them. I can tell you the first time I met Eric and some of his team, JBAD and some of the others, we were literally crawling around on some of the earlier mock-ups, testing it ourselves, and I can tell you for sure, I'm a good test for whether all those seats are comfortable, and they are. But really, our innovation studio, our design and innovation studio at Safran Cabin helped take Uber Elevate's vision, worked with their team, and brought this cabin that you see, this mock-up that you see, into reality. Design, engineering, working in parallel, rapid prototyping, all of those things came together in what you see out there today. We came from the cabin level. You can see some of the testing that was going on, test fitting with some of the team, working literally from the cabin down to the very finest details in the cabin to create a cabin that enables that mission that we talked about, I talked about at the beginning. Seamless user experience, fast turnaround times, highly reliable operations. This thing has to be reliable. We know that. We know that from our experience, our ability to integrate entire cabins. And at the heart of it all, a safe and pleasant journey for your passengers. We definitely work to optimize that vision in 3 key areas. So in terms of optimizing the vehicle, create a highly efficient cabin layout to minimize the overall vehicle size. Reduce weight and drag to ensure that it will actually take off and fly and do what it needs to do, obviously. And again, working on seamless travel, safety, quick turns, dealing with potentially, usually 4 strangers coming for an 8 to 15-minute flight. The doors are open and inviting. The baggage is easily accessible, both loading and unloading. The seats enable an easy entrance and exit. And the whole package is simple and robust. To get there required diligent analysis and a painstaking attention to detail, as you'll see in this quick video of people testing it in and out, in and out. So the interior became seamless in terms of entry and egress. We celebrate the amazing journey for the passenger, the visual effect of them canted out towards the windows, featuring seats angled to do that, give them a bit of privacy, but also give them that view, and realizing that that real show for that flight for 8 to 15 minutes is in fact the views that many people won't have seen at the low altitudes this aircraft will fly at. So optimizing the experience. We call what we're calling a mission-driven cabin. You've heard that terminology today. We really think we've achieved that working with Uber Elevate. And if you'll take a few minutes to watch this video, I think you'll find it very interesting. Thank you very much, and let us know what we can design for you next.
I don't think I've ever seen 2 teams come together like this before.
And we haven't seen anything this profound in quite some time.
The Uber team and our development team here have just been sparking each other.
Yeah, this was a completely new approach to a brief for a cabin because it's not traditional tube, it's something completely new. It's reissuing a brief for a new way of transporting people.
Our studio here in Saffron Cabin is a very collaborative environment.
There's a lot of design agencies out there, there's a lot of engineering organizations, but to have that research and development facility within a manufacturing organization like Saffron is just super powerful.
Here at Saffron Cabin, we have the talent and the tools to bring any concept to life.
We get to start with a blank slate, and we can create environments and fundamentally build this cabin together through many iterations, try things that maybe you wouldn't think of.
So taking the high-level requirements of the turnaround time and the 4 people on board and the 8-minute flight, we had to first really understand how large the vehicle was.
We had 6 full-scale mock-ups. There was multiple iterations within each one of those, whether it was the seat or the liner or the window positioning.
So for us, prototyping and building the thing was just a natural progression to get into it and understand how human beings have to interact with it.
I think Uber was very instrumental in helping us do that as well. They didn't say, no, this is what you have to do. They said, oh, where are we going? Let's go there together.
Come on in. What we have here is the 3rd iteration of an ergonomic study. This has been just such a tremendous process in terms of seeing things in real life and a one-to-one scale to validate assumptions around the passenger experience.
Just for me to see these mock-ups come together is a really cool emotional, because I've been working on this my whole life. When people are taking this, it's just going to be such a cool way to see and experience your own city.
I think what Uber really educated us on is the idea of movement and how their vision of how you move people and goods and services around is really the global picture that we're looking at. How do you take your luggage out of the car and bring it up to the aircraft and put it in? How do you interact with your personal devices or a coffee that you have in your hand that you're able to put in a cup holder in the car, but what do you do in the aircraft? You have 4 people pulling in a vehicle for an 8-minute flight that has to turn around in 5 minutes. And keeping them comfortable and safe along their journey really drove a lot of the design decisions once we get into the actual process of building the vehicle.
We don't want any excess weight, any excess cost, anything to take up space it doesn't need to. But that doesn't mean it's not purpose-built for the mission. The mission requires safety, it requires a comfortable user experience, and it requires a seamlessness of all the interactions. And so while the cabin may be minimal in some ways, it's absolutely purpose-built to the mission, and I think that's the important part.
This is a flight experience for 4 strangers, but you don't want to start closing it off and making it private and putting privacy dividers up. Again, it's cost and weight. So the herringbone is just a nice subtle way of turning your shoulder away from the person next to you. You don't feel so intruded. And it faces you out to the windows, so you can enjoy that amazing view at 1,500 feet, which is just going to be spectacular.
We're looking for complete optimization because Uber's building an ecosystem where the entire aviation and transportation community can thrive together. The energy around it makes this inevitable.
We will see this, and we'll see it fairly soon.
This is like the origins of aerospace again. It's nothing like this has happened for decades, so it's very exciting.
This is only the beginning.
Thanks again to the Uber Elevate team and to the Safran Cabin Design and Innovation Studios. Thank you.
Wow. Give it up one more time for Norm. That brings us to the end of day one. What an incredible day of presentation and exhibits from all of our partners across the Uber Elevate system. Please join me in a massive round of applause for everybody who presented today. We're not done yet. We have our evening celebration event at 7 o'clock at the Smithsonian National Air and Space Museum, just under a mile away. That starts at 7 o'clock. All registrants got an email earlier today with a free Uber code to take from the Reagan Center to the Air and Space Museum from now until 7 o'clock. So check your email. If you did not receive one, please go to the registration desks and they'll be able to help you out. In the meantime, feel free to mingle. There, of course, is the Bell Nexus outside on the Woodrow Wilson Plaza. We've got our Safran Air Cabin here, as well as a number of other exhibits throughout the atrium. Tomorrow, we start up at 9. Doors open at 8. So get here early, get through security, and enjoy the exhibit. So thank you again, everybody, for joining us today. See everyone tomorrow.